course takes a look at SpringBoot, which is one of the latest and most exciting additions to the Spring framework. Using Boot, you will see that Spring projects that once took hours to configure now take a few minutes. SpringBoot makes this possible by relying heavily upon the convention over configuration approach and supplying default configurations known as auto-configuration. If you are new to Spring, Boot makes it extremely simple to get up and running with the framework. It knocks down the barriers to entry and levels the playing field for developers new to Spring development. It has never been easier to use the Spring framework thanks to SpringBoot. So let's take a closer look at SpringBoot. The days of manually configuring Spring projects are quickly fading away, and the developer's job has become significantly easier. As you learn more about Boot, you'll see that we can set up any type of Spring project in a matter of a few minutes. A variety of starter POMs and auto configurations made available by SpringBoot will have you building Spring applications in no time. You'll also find that the framework relies heavily upon self-executing jars, so even the complexity of working with an external servlet container has been removed. These changes are your passport to exploring the entire Spring ecosystem. In the past, it would have taken years to learn how to configure each individual Spring project. Now, SpringBoot performs all of this work on your behalf. This allows you to quickly test and evaluate all projects under the Spring umbrella. So you're going to be easily able to step into something like a Spring MVC project or a SpringBoot project or a Spring Data project and get up and running quickly. In the past, configuration was one of the toughest problems to solve when working with the Spring framework or any of the modules falling under its umbrella. These barriers are eliminated by SpringBoot. Let's now take a look at how our course is organized. So the course is broken down into three main sections. First, we'll learn about the basics of SpringBoot. We'll explore creating a boot project with Maven and Gradle. We'll see how to customize the auto configuration provided by Boot to meet the specific needs of our project. Sometimes we don't want to use the default configuration for Boot, and we have to know how to override it. Once we have these basics covered, we'll move on to see how SpringBoot integrates with various other Spring Framework modules or projects. We'll see how quick it is to set up an application that persists data using JDBC or Spring Data. We'll learn how to leverage caching support with EHCache, and we'll see how to set up a Spring MVC project to build a dynamic web application. You'll learn how to protect your applications with Spring Security as well. All of these modules and more are unlocked by SpringBoot. You'll no longer need to pay the cost of entry to get up and running quickly with all of the Spring modules. Most of these modules correspond with a third-party framework that Spring eases the integration to. So not only will you unlock the different modules within Spring, you're going to be opening the door to these third-party libraries that you can include within your projects. After we cover how to configure all of these modules, we'll take a look at some tools provided by SpringBoot that fulfill common developer requirements. For example, we'll learn how to automatically trigger builds based upon a changing class path. We'll see logging improvements and also learn how to use the Actuator. The Actuator is very exciting. It provides a whole toolbox of features that support application diagnostics. So we're talking about things like health checks and getting further insights into the Spring IOC container and viewing beans, all through HTTP calls to our application and the Actuator. By the end of this course, you'll feel confident that you can quickly establish a Spring project for existing and future modules using SpringBoot. So let's talk a little bit about the prerequisites for this course and the intended audience. You can't be a beginner. This shouldn't be your first programming course. But at the same time, you don't need to be in that intermediate range. You should be a developer looking to take on a better approach to building applications. So if you're in that situation, what you'll need to know is definitely some Java. So you got to have the basics, creating methods, creating classes, looking at things like interfaces, inheritance. You should have those principles of Java down. You should have some understanding of the Spring cores, looking at things like dependency injection, as well as auto wiring, also looking at other concepts such as controllers and REST controllers. Those things should be part of your playbook. You should also have a little bit of familiarity with a build tool. Maven or Gradle will do. You don't have to have a lot of heavy knowledge in that area. One thing you will need to be able to do for some of the lessons is be able to configure your data stores, so like a MySQL data store and MongoDB. If you want to complete those lessons, we're not going to walk through the configuration step by step. There's too many third-party tools that we would have to configure in order to use. If you can configure those data stores on your own, you'll be fine. If not, there are plenty of guides out in the web that show how to do this. And there are other resources provided by O'Reilly that demonstrate how to set up these data stores. So that's it for our course overview. This is going to be an exciting course that's really going to open doors in the Spring framework for you. If you're familiar with my style, I rely heavily upon being in the IDE and doing actual work. I'm not going to PowerPoint you to death. So looking forward to working with you throughout this course. In this chapter, we're going to introduce the SpringBoot framework and begin to learn a little bit more about the tool. We'll take a look at the core concepts of the tool and the different principles that are in place and how those principles are achieved using SpringBoot. Next, we'll shift into the configuration of various tools that support our use of SpringBoot when building out our Spring applications and our Spring projects. Finally, we'll get our first look at SpringBoot in action by developing a simple, groovy application and using the SpringBoot command line interface. This chapter is meant to arm you with the information and the tools that you need in order to be successful with SpringBoot. In this lesson, we're going to talk about some of the core concepts that govern how we work with SpringBoot. There are some underlying principles within SpringBoot that you will recognize when working with the framework. The overall goal of SpringBoot is to reduce the work required for Spring developers to use the Spring platform. Much of the manual configuration that we have performed in the past in order to work with Spring is now unnecessary. We no longer have to provide boilerplate configuration for each of our applications every time we want to use Spring. It really returns the focus of Spring developers to application development. Much of the developer's work is reduced by the convention over configuration principle. Under convention over configuration, SpringBoot makes decisions on your behalf that it hopes will match the most common behaviors desired by Spring developers. Under this principle, manual configuration is the exception. We only customize the configuration when we want to have it behave differently than the conventions that are commonly applied. SpringBoot uses reasonable defaults for the configuration that it automatically provides, and then we are provided with a mechanism to easily customize that configuration when necessary to fit our specific purposes. Now, just a warning, this convention is also applied to third-party libraries such as Hibernate. So when we allow SpringBoot to configure our Spring Data JPA projects, it automatically chooses our ORM provider, which will be Hibernate. Another tenet of SpringBoot is that dependency management should be made much simpler for developers. If you have ever fiddled with the versions of the different artifacts within your application, you know the difficulties here. Usually you will have some method that's missing on a class, and you go out to find jar, and you find out it's not in the particular version that you're working with, so you go out and find the right version, and then maybe that conflicts with a version that's required by another dependency. It's a mess. So the great thing about Spring Boot is that much of this work to configure all of our dependencies, and mainly their versions, is handled for us. When talking about Spring Boot, another thing that is strongly emphasized is that there is no code generation or requirement for XML. Now, I'm sure everybody has their own opinion on code generation. Some folks have had good experiences, others have had poor experiences. In my experience, I have not been in favor of code generation. I really like having that control. So I'm glad to see this part of Spring Boot. Now that we know what Spring Boot is trying to achieve, let's talk a little bit about how these principles are achieved. We're going to discuss the technical approach of the framework. One of the ways that Spring Boot reduces the amount of configuration the developer must provide is by performing automatic configuration. Essentially, Spring Boot will interview your code base in order to determine the features that you need from the Spring platform. So, for example, if you have a REST controller, Spring Boot is going to assume that you are working with a web application, and then it's going to consult the conventions for configuring a web application, and it's going to build those into your project. Spring Boot achieves this by using conditional annotations, which were released in Spring 4.0 to conduct that interview with your code base. It's going to make decisions regarding things such as security, persistence, web development, and other aspects of application development, and this frees you from writing explicit configuration for those components. Spring Boot is able to simplify dependency management by providing starter POMs and dependencies. So when you are building your application, you can choose from pre-constructed POM files, and they're going to define all of the necessary dependencies and transitive dependencies to build your application using the appropriate pieces of the Spring framework. These convenient dependency descriptors have a naming convention of Spring-Boot-Starter, and you'll see these for many important areas such as web or for security, and you can rely upon these to easily configure the dependencies within your application. A major aspect of the technical approach is favoring executable jars. So the jar is the packaging of choice for Spring Boot, and this often requires a bring-your-own-container approach when we're developing Java web applications. Instead of building out a WAR and deploying it to a standalone container, we're now using embedded containers. Your jar contains everything it needs to run, and it's packaged within your jar file. Finally, a good build tool goes a long way with Spring Boot. While you are not locked into choosing a build tool, it is highly recommended that you use either Maven or Gradle, because Spring Boot is going to rely upon their dependency management system in order to pull down the artifacts that you need for your project. When you work with Spring Boot, the folks at Spring have provided you with several options. First is the traditional Spring Tool Suite integration. So there is tooling built into Spring's Eclipse-based IDE that you can work with in order to build out your projects and perform their initial configuration using Spring Boot. There's also a command line interface that you can use to quickly set up a prototype project, which you can further expand into a full-blown Spring application. Another mechanism that Spring provides is the Spring Initializer web page. So this is a web page that you can go to and you fill out a form, and it's going to provide you with a zip file, and within that zip file is going to be all of the configuration that you have requested for your application. So it will set up a Spring Boot project for you, and it will have the various components such as web, security, persistence, whatever you request via the form. So there are multiple avenues to working with Spring Boot, and all of these are going to make your life easier as a developer because you're going to spend less time focusing on configuration and more time focusing on developing your application. In this lesson, we will be downloading and installing the Spring Tool Suite, which is an Eclipse installation that has been outfitted to work with the Spring platform. Within STS, you'll find some integration for Spring Boot that is going to facilitate how you work with the tool. So if you scroll down on the Spring.io homepage, you will see a link for the Spring Tool Suite. We'll navigate over to the Tool Suite page, and you will see a download link and an all versions link below that download link. Here on the download page, you will see multiple versions of STS that can be downloaded for your respective operating system. In my case, I'm going to go to the Windows operating system, and I'm going to pull down the version of Spring Tool Suite that is based upon Eclipse.4.6. I am using a 64-bit architecture, so I will go ahead and click the 64-bit zip file, and then I'm simply going to download this file to my desktop. Now you can see I have already downloaded the zip distribution just to save us some time. So I'm going to cancel this download, and now I will head to my desktop. The first thing I will do is right-click on the zip file, and I will use my favorite extraction tool, 7-zip, to extract to the Spring Tool Suite -3.7.3.release. You can get the rest from that, but I'm extracting it to a particular folder on my desktop, and that's where the installation of the software will be completed. Once the extraction tool has completed, we'll double-click on the newly created directory, and within this directory, you will find the STS bundle. Inside the STS bundle is the Pivotal TC server, as well as the Spring Tool Suite. We won't be using the Pivotal TC server because Spring Boot provides embedded server capabilities. We'll be talking about that a little bit later within the course. We are going to be using the Spring Tool Suite, so click on the STS folder, and then within the STS folder, click on the sts.exe executable. This will launch the Spring Tool Suite, and the first thing it's going to do is prompt us to specify our workspace. So I'm simply going to use the Browse dialog to create a new folder on the desktop, and I'm going to name this folder sts-workspace, and then I'll be sure to select that folder and hit OK. Now also check the Use this as the default and Do Not Ask Again checkbox. This will prevent STS from prompting you every time you open the IDE. Finally, click on OK. At this point, you will see the Spring Tool Suite open, and it prompts us with a dashboard, as well as it displays other areas within the IDE. We're not going to dive into any of these just yet. You'll see them throughout the course. But what I will point out is that within our menu options, we have the option to create a Spring Starter project, and this is going to be one of the ways we can quickly create a Spring Boot project. So in this lesson, we learned how to download and install Spring Tool Suite, and that is a version of Eclipse that has been outfitted for Spring development, and it also contains some tools that are going to facilitate how we create our Spring Boot projects. Now, this is just one option of several that we have in order for working with Spring Boot. In this lesson, we will install Spring Boot CLI. CLI stands for Command Line Interface. Spring Boot CLI allows us to quickly prototype Spring applications using automatic configuration and project starters. Along with these features, SpringBoot CLI also allows us to use Groovy scripts, which can cut out all of the boilerplate code within our Spring applications. To get started with our installation, I'm simply going to Google for SpringBoot CLI, and this will bring up the documentation for SpringBoot. Inside the documentation, you'll notice this hyperlink for the SpringBoot CLI, and that's going to take us to that section of the documentation. Under the manual installation section, you're going to see a link for the zip distribution of SpringBoot CLI. And all you need to do is click on that zip, and it will prompt you to download it. So I'm going to go ahead and I will save the SpringBoot CLI zip distribution. And then once it is done downloading, I'm going to navigate to my desktop where I have stored the software. At this point, we simply extract the software to our desktop, and now we need to put the software onto our path. So I'm going to open up a command line. From within the command line, I can view all of the directories on my desktop, and then I'm going to change directories to the newly created SpringBoot CLI directory. And from within this directory, I'm going to change directories to the spring-1.3.3.release directory. And if we look inside this directory, we'll further see the bin directory that I'll navigate to. Now, inside the bin directory, I'm going to go ahead and add this directory to my path using the setx command. So I can say setx path, and then I can specify the current directory, and it will go ahead and be added to my path. With SpringBoot CLI on my path, I can now execute SpringBoot CLI commands, and to do that I simply type spring, and then I need to specify some command that I would like SpringBoot to execute. So there we see we just got the version for SpringBoot CLI, and we see our version is 1.3.3.release. We'll see a little bit more about how to use SpringBoot CLI in later lessons. In this lesson, we're going to demonstrate the power of SpringBoot by constructing a simple Spring application using SpringBoot and Groovy. For those of you who are not familiar, Groovy is a powerful, optionally typed dynamic language for the Java platform. It runs against the JVM, and we can use it to develop a Spring application. To get started, we're going to complete our Application.Groovy file. You'll see that I have created the Application.Groovy file using Notepad, much like you would a text file, but you just changed the extension. Now, within Application.Groovy, we're going to specify the code for a simple Spring application. So the first thing we'll do is we will create a class, and I'm going to call this class Hello World. And then I will open up the class body. And then within the class body, I'm going to declare a new method. And this method is going to return the word hello. And you can see how flexible Groovy is just with the syntax that we have to use. It's a lot less strict than Java. Now on our method definition, I'm going to add a request mapping, and we'll map this method to the root context of our application. We're also going to declare our class as a REST controller. So this is a very, very simple class definition that actually contains a full Spring application. Now, you may be asking, how is that so? Well, let's take a look. What we need to do is we need to go over to a command line, and I'm sitting on my desktop, so you can see I have the application.groovy file on my desktop, and I'm just going to issue the command spring So I'm using Spring Boot CLI, and I'm going to say run, and I'm going to say application.groovy. And what you'll see is that we're going to see some lovely ASCII art here in a minute, but Spring Boot is going to inspect our application.groovy file, and based upon what it finds, it is going to add different functionality to our application. So for example, since we use the REST controller, Spring Boot is smart enough to realize that we're building a web application, and it's going to enable Tomcat and Spring MVC. So we'll get an embedded Tomcat container, and we'll also get a Spring MVC configuration that has been built for us. So now if we navigate to a browser, we can go to our local host and we just go to the root of that context. And there you see we've actually invoked our controller. And that is actually a full-blown Spring application. And this is the demo that you always see when you see the Spring developer screencast where they're showing the application that can be tweeted. This application can in fact fit within a tweet. Now you'll notice how much is not there. We're not using imports, we're not specifying a main method. All of that is being added by Spring Boot. It's quite amazing what we're able to accomplish with such a small amount of code. And that really demonstrates the power of Spring Boot and how it makes using the Spring platform much easier because it handles the configuration for us. The Boot Basics chapter is designed to build your foundation with the basic Spring Boot principles through hands-on examples. The chapter takes a deep look at the inner workings of Spring Boot to further your understanding of the framework. These lessons will demystify a lot of the benefits that Spring Boot provides to you. One of the critiques of the framework is that it feels like it has this code generation aura around it, but it actually does not. All of the benefits Spring Boot provides to you are actually rooted in principles of Spring, mainly conditional annotation. So we'll take a look in depth at auto configuration and starter POMs and see how they really build the foundation for Spring Boot and provide us with a lot of benefits as developers in the fact that we have less work to do. We'll do this through hands-on examples, and sometimes we'll actually get into the source code of Spring Boot just to give you a real up-close experience with the framework. We'll then begin to manually configure a Spring Boot project. So we're going to work step by step through how you would set up a Spring Boot project by hand. This will give us a further look at starter POMs and auto configuration, and then we'll see how we can override the configuration that is provided to us through those mechanisms, and look at how we can extend our configuration to include custom beans for our applications. Now, once we've done all this manual work by hand, we're going to take a look at a quick way to do all that work using a Spring Initializer project that Spring provides to us. And using Spring Initializer allows us to easily create Spring Boot projects. So you'll see that we just tell this Initializer project what we would like our Spring Boot project to contain, and it will configure that project for us for our use. And we can get up and running with a Spring Boot project under a minute easily. But it's important that we do know the details of how Spring Boot achieves all of this kind of auto configuration for us so that if we do encounter a problem, we know what is going on underneath the hood. And it also helps to know how to manually configure a Spring Boot project because it takes some of that magic or code generation feel away, and it makes us more comfortable working with the framework. In this lesson, we'll take a look at how to manually configure a Spring Boot project. While there are more automated ways of building a Spring Boot project, It's important to understand the different pieces that make up Spring Boot and how they allow us to easily establish these projects. The best way to get an understanding of these pieces is to manually build out a project yourself, and that's what we're going to be doing. So to get started, we're going to go to File and then select New, and we will make a new Maven project. From the new Maven project dialog, we want to check the Create a Simple Project checkbox and then hit Next. Now we'll need to specify some information about our Maven project, particularly the information that will identify this artifact. So to start out, we're going to use a group ID of com.o'reilly.boot, and then we're going to specify an artifact ID of spring-boot, and then for the name field, we will also use spring-boot. At this point, we can go ahead and hit the Finish button, and STS will begin to build out our Maven project. So just like every other Maven project, we will have a POM.xml file, and this is a file that is used heavily by Spring Boot in order to determine how to configure our project. Now, there are various ways to configure a Spring Boot project. You can also use something like Gradle. In our example, we're just going to focus on Maven. So here we have our Spring Boot POM.xml file. And one of the things we can do from this file is specify a parent POM. And a parent POM is a simple manner of using pretty much inheritance within Maven. So it allows our parent POM to establish some configurations, and those configurations will be inherited by our POM.xml file. In our case, we're going to select a parent POM. So just click that icon in the upper right-hand corner. And now we're going to look for the POMs within the org.springframework.boot group ID. And you'll see that we get a number of available artifacts that we can select from. And the one that we are interested in is the Spring Boot starter parent. So let's stop here and talk a little bit about what's going on. The Spring Boot starter parent is actually a starter POM. A starter POM provides us with a set of pre-configured dependencies and other configurations that allow us to quickly get started with a Spring project. You will not need to hunt through different examples and different articles to find the appropriate configuration because it's all encapsulated in this pre-made POM file that Spring Boot calls a starter POM. Now, the Spring Boot starter parent POM is a special type of starter POM that is used kind of as the base for Spring Boot projects. So we'll go ahead and select that POM and hit OK. With that in place, we will save our pom.xml file, and now we're going to go ahead and add another starter POM as a dependency. So I'll go ahead and move to the Dependencies tab, and I'll click on the Add button, and once again we'll look within the org.springframework.boot group ID, and here you can see a lot more starter POMs are now provided. The one we are interested in is the Starter Web POM. So we'll go ahead and select that POM and hit OK. And this is going to contain a bunch of artifacts that are necessary for running a web application with Spring. So we'll go ahead, we'll save our POM file, and then we can take a look at our effective POM. And this is going to show us some of that pre-configuration that was provided to us by our parent POM and the web starter. So here you can see there's a lot of configuration that has been provided to us, and it's no longer necessary for us to ensure that our configuration is correct. And sometimes that requires a lot of detail and a lot of troubleshooting because of things like version compatibility. So all of that is configured for you, and you no longer have to waste your time determining what the appropriate configuration is. Now that we have our pom.xml file set up, we're going to go ahead and navigate to our Package Explorer, and we're going to create a new class within the source main Java source folder. So I'll go ahead and open the new dialog by pressing Ctrl N, and I'll just type class to create a new class, and then hit next. And I'm going to put this class within the com.o'reilly.boot package, and I'm going to name this class Application. I'll go ahead and hit finish, and you'll see that STS will build out our new class file, and we'll go ahead and open it up. So now let's build out our application class. The first thing we'll do is add the REST controller annotation to specify that this is a Spring web application. And then we'll add the new Enable Auto Configuration annotation. And that's a SpringBoot annotation that tells SpringBoot to guess at our configuration using some clues it gathers about our application. The next thing we'll do is we will build out a main method, and within that main method we're going to use the Spring application class to invoke the run method on our application, and that will bootstrap our application. The next thing that we need to do is we need to provide an endpoint for our REST controller. So we're going to build out a new method, and we'll just call it home, and we'll return the string hello world from this method. And then we need to add the request mapping annotation to this controller method, and we're going to map it to the root context. At this point, we have our application established, and SpringBoot is able to run it. So we'll go to run as, and then SpringBoot. And if we navigate to our console, you'll see that SpringBoot fires up, and eventually it starts our application. And now if we navigate to a browser, we can head to our local host, and in fact, our new web application built with SpringBoot is able to serve our request. So in this lesson, we took a look at how to manually configure a SpringBoot project, and we took a look at the various pieces of configuration that must be put in place in order to build out our SpringBoot web application. We'll take a deeper dive on some of these areas as we move throughout the course. One of the mechanisms that SpringBoot uses to reduce our project complexity is the starter POM. Now, in order to take a look at the starter POM and the benefits it provides to us, we're going to modify our simple application to use a unit test. So if we look in the Package Explorer, you'll see that the application test.java file has been provided. And this file establishes a unit test that will be used to test our Spring application. The unit test makes use of the Spring test framework as well as some new annotations that are built into SpringBoot. We'll discuss those specific testing annotations a little bit later in the course. The important thing to notice is that we are importing classes from various libraries in order to make our unit test work. Now, at the moment, we have not provided those libraries. This is where SpringBoot starter POMs come in. The starter POM is going to allow us to import the appropriate artifacts via our dependency management system, Maven, and that's going to ensure that we have the proper versions of our dependencies. So let's navigate to our pom.xml file. You'll already notice that we're making use of the SpringBoot starter web POM. We're going to go ahead and add another starter POM, and it's going to be the spring-boot-starter POM-test POM. And we'll go ahead and pull in that dependency to our project. So we'll just select it and hit OK. Now, if we save our pom.xml file, you're going to notice that all of our import errors are no longer valid for our class. In fact, our class is now valid and would compile. And we can do so by running our unit test, and you'll see that our unit test comes back successful. So what made that happen? Well, let's look more closely at our pom.xml file to see how SpringBoot was able to leverage the starter POM in order to provide our dependencies. You'll notice that we did not specify individually that we would like to use JUnit, or that we were using Hamcrest, or even the Spring Test Framework. So all of those dependencies were automatically pulled in for us. And the way that occurred is if we look at our dependency hierarchy, you'll see the SpringBoot starter test. And if we look at that dependency, we can actually open the POM. And within that POM, we're going to see the dependencies on those libraries or those artifacts that we are now using within our project to conduct our testing. So these would actually be transitive dependencies of that starter POM. And if we look more closely at the source for the POM file, you'll see those dependencies declared. Now, the interesting thing is that we're not defining any versions. So you'll notice that for the JUnit dependency, there's no version declared, the same with Mockito. And if we take a closer look at our project POM, you'll see that this is defined within the actual parent POM. So here is our parent POM, and we can open that parent POM, and looking at its source, you'll notice that it specifies a number of versions for all of the different dependencies that we would like to use. So if we look at the effective POM, here we're going to see all those versions listed. And if we look closely, you're going to, there's Mockito, there's Hamcrest. So you're going to see versions specified for all of those different dependencies that we're pulling down in the SpringBoot starter POM, but it's actually that parent POM that has the overall versioning and the compatible versions built within it, and the other starter POMs just leverage that to make sure they have the right version configuration. So this takes a lot of work out of the hands of the developer and allows them to focus on writing their unit test or their application code, focusing less on the versioning of our different dependencies, what dependencies we do need. You can pretty much just write within your POM file the functionality that you need. So here we just say we'd like to test our application, or that we have a web application, and we're really using a faceted type of marking for our project, and then SpringBoot takes care of the rest for us. And that really saves us time as a developer. In this lesson, we'll discuss another technique that SpringBoot uses to facilitate the configuration of Spring projects. This technique is known as auto-configuration. When we enable auto-configuration, using the Enable Auto-Configuration annotation, we are signaling to SpringBoot that we would like the framework to make intelligent guesses about the types of configurations and the types of beans that we will need within our project. When using auto-configuration, it's important that we place the Enable Auto-Configuration annotation on our main class, or the class that runs our application. So here you see the annotation applied to the application type, and it's also important that class resides within a properly packaged structure. So here you see the com.o'reilly.boot package, and then within that package is our application. We want to avoid placing our main class within the default package because it's going to have some later consequences for some of the scanning that will occur. For example, the enable auto configuration annotation serves as a marker for the base package, which we will then use to perform scanning for our different entities in something like JPA. Essentially, auto configuration enables specific features within our application without us explicitly defining the beans necessary for that feature and their configuration. So let's walk through an example to see a little bit more what we're talking about. First, if we look at our pom.xml file, you'll notice that we have included the SpringBoot starter web POM, and if we look at the dependencies within that POM, you'll notice it's pulling in a lot of different artifacts. There we actually see an embedded Tomcat being placed within our class path, and if we look at our Maven dependencies, we do in fact see embedded Tomcat, and that's because we are working with a web application. Now, normally we would need to specify some information or configuration to Tomcat, but what happens is the auto configuration feature within SpringBoot detects this jar on our class path and recognizes that it needs to provide us with some default configurations. And this allows us to get up and running very quickly and very smoothly. So let's go one level deeper and talk about how this is accomplished. One of the ways we can really see some of the internals of this auto configuration feature is by adjusting our run configuration. So within our run configuration, all we need to do is click the Enable Debug Output checkbox and then hit Apply, and then we can close our configuration. Next, we'll go to the Run menu item, and we can run as a SpringBoot application. And if we now inspect our console, you'll see that we get some debugging output which talks about the different checks that the auto configuration is making to determine what types of configurations are appropriate. So towards the top of our console output, you're going to see that we have these positive matches. And what's going on is SpringBoot is using different conditional annotations. And basically these conditional annotations check to see if a particular condition is present. And if it is, it will then apply the configuration. And we'll take a closer look at that. But here you see that it's running the embedded servlet container auto configuration check. And it's checking that the Tomcat class is on our class path, and then it also makes sure that we don't have any other servlet containers set up so it doesn't overwrite some configuration that we would actually like. And if you look within the dependencies pulled down with Maven, you'll see the SpringBoot auto configure jar. And within this jar, you're going to find a bunch of these auto configuration checks that SpringBoot performs in order to determine how to configure our application. So here we do see the embedded servlet container auto configuration class. And if we look at the source for that class, what you're going to notice is that our checks are there. So there we see the configuration annotation. We're using Java configuration. And then we use these conditional annotations to determine whether or not we should build out an embedded Tomcat container for use by our application. So that's a little bit about how SpringBoot actually works to perform our auto configuration. So one of the key principles with auto configuration in SpringBoot is that the framework will attempt to provide you with the best configuration possible. But if you specify your own specific configuration, the auto configuration will then back off. So for example, when we run our web application here, because we have auto configuration enabled and we have the Tomcat server on our class path, the auto configuration within Spring Boot knows that we need to run a web application, stand up a Tomcat server, and then it applies some defaults, like we're going to be on port 8080, that we're going to use the root as our context path, so it's just going to be localhost 8080. And we can see that if we just navigate to our application. But what if you need to change that? Well, that's the great thing about the auto configuration, is that it will back away in those cases. There are several ways to specify your specific configurations. Let's just take a quick look at one of them. If we go into the run configurations, we can specify arguments for our application. And there are these defined configuration properties that we can specify. So for the server port, it's just server.port, and we can set that to 9000. And then we can also change our context path with server.context-path, and then we just set it to whatever we would like. And then we can go ahead and apply those configuration changes, and they will be provided as a program argument, and then we can go ahead and close. Now, one important thing when you're working with Spring Boot in STS is you'll want to use this relaunch Spring Boot application button to continually run your application, or else the previous Java process will not shut down. So let's go ahead and we'll run our new application configuration. And just taking a look at it here, you can see there we did start up on port 9000. And if we go to our browser and we switch our port over to 9000, and then we use the context path of test, we once again hit our application, just with a different configuration that the auto configuration within Spring Boot did not overwrite. So here you see one of the ways that Spring Boot really facilitates our configuration of our Spring projects, and that's using auto configuration. And it works hand in hand with the starter POMs. I really wouldn't recommend using them independently, although you can, but they really seem to work very well together. So with those two facilities provided by Spring Boot, you can get fully configured projects. And then if you'd like to modify those projects, you can always go to your run configurations, and within your Spring Boot app, you can provide specific arguments via the Arguments tab. And using the auto configuration from Spring Boot, we can really simplify our configurations, and it takes a lot of that work away from the developer. When working with Spring Boot's auto configuration, we can use system parameters to override the default auto configuration settings. This approach is a little bit less than ideal. One of the issues you'll encounter is that those system parameters have to find their way into a startup script that would run every time the application starts. This creates a maintenance problem. Now, there are several other ways we can specify our configuration when using auto configuration. Spring Boot allows us to use environment variables, JNDI, and several other ways. In this lesson, we'll discuss one of the most common ways to override the auto configuration settings, and that's the Application.Properties file. The Application.Properties file is an externalized file that we can place on our class path to specify custom configurations to Spring Boot. This allows us to better organize the configuration for our project, and it will be in a more readable form. So to get started, let's create our Application.Properties file. Within the Package Explorer, navigate to the Source Main Resources directory, and within that directory, open up the New dialog by hitting Control and then pressing N. Within this dialog, we would like to open the File Wizard, so select File and then hit Next, and then simply type Application.Properties, and then click on Finish, and this will create the Application.Properties file within our project. And you'll notice that it gets that nice icon with the leaf, and that's because STS knows this file is important to Spring. So it gives it a little special icon there. And that should clue you in that STS is going to provide us with some additional features for this file and how we work with it. So if you go ahead and hit Control and then space, you'll notice that STS is providing us with IntelliSense to work with this file, and it's going to allow us to peruse all of the available properties that we can use to configure our Spring project. So for example, if we look at the server options, there we can specify the port. So you'll remember we were running our server on port 9000. And if we further look at our configuration options, you'll see the context path can be specified. All the different options that we have with Spring Boot for configuring our project can be found within this IntelliSense, and that's a great tooling feature of STS and really is a good driver for working with this IDE when building Spring projects. So we'll go ahead and set our context path to /test, and then we'll save our application.properties file. Now you'll remember that within our run configurations, for our Spring Boot application, we had specified these as program arguments. So we can go ahead and remove those program arguments because those system arguments are no longer required since we are using the application.properties file to specify our project's custom configuration for Spring Boot. So let's quickly demonstrate that our application.properties file does indeed impact our configuration. I will relaunch the Spring Boot application, and if I navigate to my browser, I can then go to localhost port 9000, hit the test directory, and I receive the response from our application. Let's return back to STS, and we're going to navigate over to our application.java file, and we'll put some changes into this file that will further demonstrate the power of the application.properties approach. So within this class, I'm going to add a new string, and I'm going to give it the name of name. And then I'm going to annotate this variable with the value annotation, and we'll import that annotation, and then we will specify some expression language to get the value that will be dependency injected into this string. So there you can see we're going to dependency inject the name property, and then we'll go ahead within our controller method and we'll return that name. So if we now head to our application.properties file, we can add our own name property, and we can just say Spring Boot, and that property within the application.properties file will become a property available to us for dependency injection within our Spring application. So once again, let's relaunch our Spring Boot application, and we'll navigate over to our browser, and we'll hit that URL once again. And this time you'll notice that the value returned by our REST controller is now Spring Boot, and that value was found within our application.properties file. So those values are available to the application. Returning back to STS, we'll run one more demonstration that shows how we can use placeholders within the application.properties file. So within the application.properties file, when we specify a property, let's say we specify a type property, and we'll just give it a value of framework, we can then reference that property later within the application.properties file. So all we need to do is go ahead and put a placeholder within our properties file using the expression language syntax. And you'll see now that if we relaunch our Spring Boot application, that we will have in fact used the value to fill that placeholder. So navigating back to our browser and running, you now see that we were able to use a placeholder within our properties to change that value that we display. So there's a lot of power within this application.properties file, and you can see that as your configuration gets more customized and more specific to your project, this is a very great place to put them instead of as a program argument where it's going to be a little bit less readable, a little less easier to maintain, especially when you consider the IntelliSense that you are receiving from the STS IDE within the application.properties file. So in this lesson, we took a look at another way that we can specify customized configuration for our Spring Boot project, and that allows us to overwrite some of the defaults provided by auto configuration. One of the things that you'll notice about the Spring framework is that it strives to provide developers with choices. Often, there are multiple methods to achieve the same end in Spring, and this allows developers to pick their favorite approach. Spring Boot adheres to this principle, and it allows developers to choose between different approaches of configuring their Spring Boot projects. So aside from our application.properties file, we are also provided with an approach using YAML. YAML is a serialization format that follows a hierarchical structure. It's very similar to JSON in the fact that it uses key value pairs. YAML is really popular amongst the Ruby crowd, so if you know Ruby, you may already be familiar with this format, but for most Java developers, this is something new. Don't be alarmed, Spring provides us with a lot of great ways to work with YAML, and it will really assist you as you work with the new format. So let's dive right in, and we will create our application.yaml file, and this will provide our configuration in the YAML format for our Spring Boot project, ultimately dictating its behavior. So right alongside our application.properties file, we're going to open the New dialog by pressing Ctrl-N, and then we will add a new file. We'll hit Next, and then we'll specify the name of this file as Application.YML, and that's the YAML file extension. So with this file in place, I'm actually going to go ahead and rename our application.properties file. So just select the file within the Package Explorer and hit F2, and it will open up this Rename Resource dialog. And then just put a 2 in the name. That way Spring Boot ignores our application.properties file. Now we will return to our YAML file, and we're going to duplicate the configuration that we put within our properties file. You'll notice that STS has given the application.yml file a special icon, and that's indicating that STS realizes this application.yml file is special to our Spring Boot project. So for those of you who are concerned because you may not know YAML, if you hit Control Space, you should be a little bit relieved because you'll notice there's some great IntelliSense built into STS for those of us who are not intimately familiar with YAML, but it's not very complicated. So if I start to type server, which is one of the properties or one of the configurations we'll need to specify, you'll see that I can choose the server.port property. And if I go ahead and select that, the IntelliSense will actually put that property into the appropriate format for YAML. And as I mentioned, YAML is hierarchical based, and you can see that all it did was indent the port property, which is nested under the server node there. And that's how we define our different properties in the hierarchical format, is by nesting in further from the parent node. So here we see this child node is nested further within from the parent node, and that makes it kind of an extension of the parent. So we're going to specify that our port is going to be 9001, and then we're going to head to the next line, and we'll define our next property, which is the context path. Now notice how this additional property is just nested within the parent. So we're specifying multiple properties here via kind of a key value pair syntax that we would use in JSON. And we have that parent node of server, the two child nodes of port and context path. So let's go ahead and we'll specify our context path as /test. And then we're going to actually put in our own property here. So we'll specify a type node and we'll say that the type is going to be framework. And then we will specify the name node and we're going to say Spring Boot just like last time. And you'll also see that we can use the placeholders within YAML. So there's some familiarities there between application.properties and application.YAML. And just further looking at IntelliSense, you'll see it's going to do a lot of nesting for you. So here, if we pick this property that looks like it has about 4 levels of nesting, it will complete that for you as you work through defining the configuration for your project. The other neat thing is if you are working within one property, so let's say here we're working with the active MQ node and we specify a broker URL of something, and then we come up here and we are working within the active MQ node and we're going to specify a password. Notice it automatically groups that where it should be nested within that appropriate node. So STS has some great IntelliSense built into it, where it's really not that important that you have this in-depth understanding of YAML. So I'll go ahead and remove that node, and I'll save our application.yaml file. Now we'll go ahead and relaunch our application so that we can confirm that our YAML configuration is in fact working. So if we go to, let's say, localhost 8080, this should fail. But if we go back to our 9001 port, I believe it was this time, you'll see that if we hit the test directory, we get our response back, and it uses the placeholder that we had included within our YAML configuration. So there we've seen another way that we can override the auto configuration of our project using the YAML format. So it's just a little bit different. It's an alternative to application.properties. This would be probably more appropriate for the folks coming from a Ruby background, or if you're just interested in a more hierarchical format for your configuration. Before we conclude our lesson, I just want to show you one last tidbit that's really interesting. If we go to our pom.xml file and we take a look at our dependency hierarchy, you'll notice that looking at our dependencies that we have the snake YAML dependency, and this is actually the YAML parser. Now, it's really not provided by the web dependency, it's actually within the starter project, but that parser was included to parse your YAML, and you didn't even know it. And it's because we used a starter POM or a starter dependency with Spring Boot. So that just illustrates the power of Spring Boot. There we're working with this different type of format to basically represent data, and we didn't even have to think about pulling in the parser for it. It was just pulled in for us because we told Spring Boot that we are building a web application, and it knows that, well, when you build a web application, maybe you'll be using YAML. So it really demonstrates the power of Spring Boot as we worked through this lesson and didn't even know we needed that dependency on that artifact. When building out our Spring Boot project, we may need to configure beans that are specific to our application. In this situation, it's not reasonable to expect Spring Boot to auto-configure these new beans. As a developer, it's our responsibility to specify the configuration for those beans using the Java or XML configuration provided by Spring. In this lesson, we'll take a look at how you can include configuration for those beans within your Spring Boot project. To get started, we're going to navigate to the Package Explorer, and we will create a new class within our com.o'reilly.boot package. To do that, hit Ctrl-N to open the new dialog and type class. And you'll notice that we are building a Java class, and this class will contain our configuration for the custom beans for our project. Now, this is because Spring Boot prefers to work with Java configuration, and that's the preferred approach from the folks at Spring. So we'll go ahead and build out our new class. We'll name it My Configuration, and then I'll simply hit the Finish button, and this will build out our new class. Within this class, we will provide the configuration of different beans we would like to see in our Spring IOC container. The first thing we'll do within our configuration class is add the configuration annotation, and this indicates that our class will declare several bean methods that will then be used to create beans that are put within our IOC container. So we'll add the bean annotation to a method that returns a string, and we'll just name this method message, and we'll import the bean annotation, and then we'll simply return our strings. So what we're going to have happen here is we're going to create a new bean within the IOC container that is of type string, and it has the value of Hello O'Reilly. So we have some very simple Java configuration here, and it declares a bean. Now what we're going to do is we're going to include this configuration within our Spring Boot project in our Spring application, and the way we can do that is by using the import annotation that's provided by Spring, and that annotation requires us to specify a type. So we point to our configuration class, and that allows us to include that configuration within our application. That allows us to auto-wire our bean into our application class. So I'll add the auto-wired annotation, and then we'll create a new field message, and that bean will be auto-wired to our string message, and then we're simply going to return our message within our REST controller. And if we relaunch our Spring Boot application, you'll see that we are going to reference our external configuration when we visit our REST controller and its endpoints. So there's Hello O'Reilly, and that came from our My Configuration class, which we then auto-wired the message bean into our application, and then returned its value from our request mapping, our method that was mapped to our controller method, and that allowed us to provide a response to the end user. Now, this is very basic Java configuration. You're probably familiar with it. What we can also do is, if we had multiple configuration classes, we can add the component scan annotation, and what we can do there is, if we do not provide a path, it will just component scan from the class that contains the annotation. So here we would basically be starting from the root of our project, because this is the class that would have the component scan annotation, and it would scan this package as well as any other packages nested within it. So if we once again return to our application after we relaunch it, you'll see that we receive the same results as when we had manually imported the additional configuration. Now, what we'd like to take a look at is a way we can simplify this configuration. So Spring Boot provides us with the Spring Boot application annotation, and this is a shortcut for specifying the auto configuration annotation, as well as the component scanning annotation and the configuration annotation. So it would be as if we added the configuration annotation, the enable auto configuration annotation, as well as the component scan annotation on our application type. So it's just a shortcut to specify all three of those annotations, and you'll see it used quite frequently because it's a very common task to do this. So let's go ahead and save our application. Now we can relaunch the app, and then we can navigate over to our browser. And once again, you'll see that the response provided by our REST controller is determined by the bean that was specified in our additional configuration. So you can also do this with an XML approach. We're not going to go into that because Java configuration is the preferred approach for Spring Boot. In this lesson, we learned how to include additional configuration for our application-specific beans and how to include them within our Spring Boot project to work along with auto configuration. And we learned this nifty method of using the Spring Boot application annotation to reduce some of our configuration. And you'll encounter this as you work with Spring Boot projects, so it's important to know what is really behind this annotation. In this lesson, we'll take a look at Spring Initializer, which is a tool that allows us to quickly generate a Spring Boot project. We can interact with Spring Initializer via several approaches. The first approach that we'll take a look at is start.spring.io. This is a simple web UI that we can use to configure and generate a Spring Boot project. So within my browser, you can see that I have navigated to start.spring.io, and this takes me to a simple web interface provided by the folks at Spring. And within this interface, I can specify the details of my Spring Boot project. So there's a number of pieces of information that I have to provide. First, it will ask me to select between a Maven project or a Gradle project. I'm going to go ahead and proceed with Maven, but know that Gradle is another configuration approach or another build approach that you can use. It also asks me to specify which version of Spring Boot I would like to use, and then it asks for some coordinates for our new project. So I'm going to go ahead with com.o'reilly.boot for my coordinates, and for the artifact ID, I'm going to just say quick start. And now I can search for different dependencies within my project. And here I'm really telling Spring Initializer what I would like to use. So I can go ahead and say I would like to use the web stack. I can say Spring Data, and there you see it prompts me with the different Spring Data packages such as JPA, MongoDB. If you're not exactly sure what you'd like to use, you can switch over to the full version, and that will allow you to peruse your different options. So here you'll see a number of projects provided by Spring that we can use within our application. I'm going to go ahead and select the web project. I'll select the security project, as well as a JPA project, and we'll put an embedded database into our project. And those are some of the most common facets that Spring records people using, but you can see there are quite a few dealing with various sorts of concerns of your application that they are able to address. So you're able to just simply select those, and then at the top you click on Generate Project, and it's going to prompt you to download a zip file. So I'm going to go ahead and save that quickstart.zip to my desktop, and then I can go ahead and navigate to my desktop to find the quick start. And what I'll do is I will extract it to a quick start folder. And now I can go into STS. And if I go to File, Import, and I can say Maven Project or existing Maven projects, I can go browse to my desktop and find the quick start directory that has unzipped. And you can see that it is a Maven project, so I'll just hit OK. And all I need to do at this point is hit Finish. and my new Quick Start project from Spring Initializer is imported into STS. And if I peruse the different packages within this directory, I can see the different structures that are provided for me. So there we see a Spring Boot application annotation, as well as we should see our application.properties file was generated for us. So it provides us with a fully configured project that all we need to do is unzip, and all of the manual configuration is done for us. Here we see the POM file for our project. We can load our effective POM, and there we see the Spring Boot starter parent being pulled into our POM. So we are able to quickly generate a project using the initializer. Now, I mentioned there are various approaches to using Spring Initializer. Via the web interface is one, but there is also tolling built into STS. So I'm going to go ahead and I'm going to delete our application, and I'll just delete it from disk as well because it's very simple to create. And now I can go ahead and proceed with using the STS integration. So I'm just going to go to File, New, and then Spring Starter Project. And here I'm going to be asked many of the same questions I was via the web interface. So it's going to ask me for a name of the artifact, and I'm just going to call it Starter Project. And then I can pick the type of packaging I would like, a jar or a war. Now, Spring Boot favors an executable jar. I can also select between Maven and Gradle, and actually different ways to work with Gradle. I can pick my Java version. I can specify my coordinates, so com.o'reilly.boot, and then we can specify our artifact ID. We'll go with starter project, and then we click on next, and here is where we can specify our dependencies via the STS integration. So it's just like when we click those checkboxes on the web interface. I can say I'd like it to be a web project, and I can say, okay, JPA, and it's quite amazing how many projects are out there under the Spring umbrella that you can actually search through all of them as opposed to just clicking all the checkboxes. And it's amazing just looking at how large that ecosystem is. So once we then have picked the dependencies we would like, we can hit next. And here you'll see that the STS integration is actually just talking to start.spring.io. Here we see the URL that it's going to invoke. So it's working with Spring's web service for start.spring.io in order to create our packaged project. And you'll see that if you were to copy this URL and then navigate to a browser and paste it, it's going to prompt you once again to download a project that has been created by the Spring Initializer web interface there. But we're going to proceed through the IDE integration. So just click on Finish. And the great thing you'll see now is it's just going to directly import that project right into Eclipse. And we no longer need to actually unzip it and then import it as a Maven project and then wait for everything to build. So once again, looking at our application, you see we get our main app, which is annotated with Spring Boot application, and then we have our application.properties files. It also built out some directories for our web resources, which we'll talk about later, and it builds out a nice test directory for us as well to encourage us to use unit testing. Another thing that you'll notice if we open the pom.xml file and we take a look at our dependencies, you'll see that all of the project facets that we checked off within the STS integration are now available via starter POMs within our pom.xml file. So each time you select one of those different areas that you'd like to include in your application, this is how Spring Boot configures them. It uses starter POMs. So in this lesson, we saw how Spring Initializer allows us to quickly configure a Spring Boot project. We saw the various approaches that we can use to build a project quickly with Spring Initializer. We saw there is a web interface via spring.start.io. There is also the STS integration. You can use curl to call the web service with the appropriate parameters, and it will generate your project. And you can also use the SpringBoot command line interface, which provides some features for working against that Spring Initializer web service. All of these approaches allow you to quickly get started building a Spring application with minimal configuration. When working with Spring Boot, we'll primarily have the choice between two build tools, Gradle and Maven. We have already seen how Maven is used to build Spring Boot projects. So in this chapter, we're going to focus on Gradle. Gradle is a build tool first started in 2009. It incorporates concepts from Ant and Maven. It uses a Groovy-based DSL, or domain-specific language, to declare project configuration in a Build.Gradle file. The Build.Gradle file serves a similar role to Maven's POM file. The tool was designed to simplify the construction of large projects that have multiple modules within them. Now, at this point, you might be feeling a little bit overwhelmed by Spring Boot because there's been quite a bit of new technologies that get introduced with it, such as YAML and Gradle. And that's kind of one of the roles of Spring Boot, is to tie all of the different technologies together that we use when building a Spring project and to provide developers choices with the technologies they use within their projects. The great thing about Spring Boot and Spring Initializer is it limits the interaction we have with these new technologies, or it performs a lot of the work for us, so don't be deterred. Let's take a look at some of the goals for this chapter. In order to work with Gradle inside of STS, our IDE, we'll need to install some tooling into the product. We'll see how to install and work with Buildship. Buildship is an Eclipse plugin that provides Gradle support within the IDE. In order to better understand how Gradle builds projects, we'll take a look at how Gradle approaches the builds by creating a simple project and exploring the Gradle wrapper. The Gradle wrapper is a unique way of distributing the tool that really limits some of the version conflicts you can have when building out a project. From there, we'll move on and inspect a build.gradle file, and we'll explore the project configuration within that file to see what we need to specify in order to build out a Spring project. And within that build.gradle file, you're going to see some familiar characters. You'll see our starter POMs being used because Gradle can work with POM files through its dependency management system. And you'll also be introduced to some new players. So you will see the SpringBoot Gradle plugin. And this is a plugin developed by the folks at SpringBoot that helps aid the construction of executable jar files and also the construction of WAR files. Additionally, the plugin will allow us to run a SpringBoot application in place, and we'll see all that in action. So for those of you who may not be too keen on the Maven approach, this chapter is for you. Gradle presents an attractive alternative to Maven. It combines some of the best practices from the popular build tools such as Ant and Maven, while at the same time adding unique capabilities to improve project builds for developers. As you'll see within the chapter, there is also integration with SpringBoot, and it can be used as an alternative to Maven. If we would like to use Gradle as our build tool in conjunction with SpringBoot, we'll need to add some tooling into our STS installation. In this lesson, we will walk through the installation process of the Buildship Eclipse plugin, which is used to integrate Gradle into the Eclipse IDE. To get started, let's attempt to build out a new Spring Starter project. So we'll go to the File option within the menu, and we'll select New, and then we will select the Spring Starter Project menu item. This will open a dialog where we can build out our new project. you'll notice that we can choose the type of our project. Currently, it is set to Maven. However, if we click on the drop-down, you'll notice two options for Gradle. Now, we want to be sure to use the Gradle Buildship option. This is referring to the tooling that is built into STS in order to support Gradle. So you'll notice if we click that option, we are told that the Buildship Gradle tooling is not installed. Now, one word of advice, the Gradle STS tooling is actually deprecated. They're starting to remove that tooling and they will not be supporting it within the future. So let's go ahead and we can close that dialog, and now we'll open the new dialog by pressing Ctrl N. And if you take a look by just typing Gradle, you'll also notice there is no support for Gradle out of the box with Spring Tool Suite. So we're going to add that tooling into our IDE. And the way we get started is by clicking on Help and then checking the Eclipse Marketplace menu item. And this is going to pull up a dialog that we can use to pull new software into our IDE. Within this dialog, we are going to type Buildship in the Find text box and just hit Enter. And this will search the Eclipse Marketplace for the Buildship Gradle integration tooling. Then just click on Install to begin installing the Gradle integration. And it's going to begin to pull down all of the features that are present within the integration so that you can select which versions you would like. You'll just want to select the default options in order to install the Eclipse plugin for Gradle. Hit Confirm and continue on with the wizard, and now it's going to ask you to accept the license, so just click I accept and then hit Finish. And now Eclipse will begin to download the software and install it. Eventually, you will be asked if you would like to install unsigned content. Now, this software is authentic, so you can go ahead and hit OK, and the installation will continue. Once the installation is complete, you will be prompted to restart STS. So go ahead and hit Yes, and let the restart begin to take place. With the tooling now in place, you'll notice that we can begin the process of building our Spring Starter project, and this time we can in fact choose the Gradle type as our build tool for our project. Now, we're not going to move along with this process, and we'll go ahead and cancel. The other thing that you'll notice is that if we open the new dialog, we now have options to build out a Gradle project. So the tooling did, in fact, get installed, and you'll also see that if we look in the Quick Access panel, we have the option to look at Gradle tasks as well as Gradle executions. And this is some of the tooling that Buildship provides to us when working with a Gradle project. As we build out our SpringBoot project that uses Gradle as a build tool, we'll use some of this tooling to work with and run our project. In this lesson, we'll focus on creating a new SpringBoot project that uses Gradle as a build tool. To get started, we're going to click on the File menu item, and then we'll navigate to New and select the Spring Starter project. This will open up a new Spring Starter project dialog, and here we can specify the name of our project. We're going to name our project Starter-Project-Gradle, and we're going to ensure that the Gradle Buildship option is selected for the type, and this specifies that we'd like to use Gradle as our build tool, and we're going to use the Buildship tooling within STS. We'll specify our group ID as com.o'reilly.boot, and we'll make sure the artifact ID matches our project's name. So make sure the artifact ID is starter-project-Gradle. Finally, you'll want to make sure that the package is com.o'reilly.boot. With these configurations in place, go ahead and click on Next. And now we're going to select the web dependency for our project. It's going to be a Spring MVC project. So we'll select that option and hit Next. Now here you'll see the URL that's going to be visited in order to download our project and import it into STS. So go ahead and hit Finish, and you'll see that STS will begin to synchronize our workspace and pull in our project. Now the first thing you should notice is that our project now appears within the Gradle Tasks tab, and we are exposed to all of the tasks that we can execute as far as our Gradle build is concerned. So we'll talk a little bit more about these in later lessons. The other thing we're going to take a look at is within the Package Explorer, there is a Build.Gradle file. The Build.Gradle file is very similar to like a POM.xml file in that it contains all of the configuration for our project's build. So let's go ahead and open that file, and we're going to pay particular attention to a configuration at the bottom of that file. And that's the specification of this wrapper task. And I'd like to talk a little bit about what this wrapper task does for our project and how it is a real benefit to building our Gradle project. So to proceed with our discussion of the Gradle wrapper, we'll open a terminal using the quick access bar within the STS IDE. So just type in terminal and you'll be able to choose the terminal view. And this is going to open what is essentially a command line to your local machine. You'll notice the small icon will allow you to open a terminal and just select the local terminal and proceed. So here I have what is essentially a CMD window or a command line within Windows. Now the first thing I'd like to demonstrate is that if I were to issue a Gradle command, so here is the command for Gradle to show its version information, the command is not recognized. Well, why is that? Normally, when we work with a tool, we have to install it on our computer. For a lot of build tools, you'll perform the installation and then you'll add some bin directory to the path, and that allows you to invoke the tool on the command line. Well, this creates some extra work for people that want to build our application. First, they have to proceed with installing the tool, and then second, they need to make sure they have the right version of the tool installed, or they may not properly build our software. So here's where the Gradle wrapper is really unique in that it solves those problems for us, in the fact that we have specified the Gradle wrapper within our build.gradle file. So here we see that we're specifying to use version 2.12 of the Gradle wrapper, and it's going to be pulled in for use by our project. So if we navigate back to our terminal, and we can head to the desktop, and then within the desktop, we'll navigate to our STS workspace, and inside this directory, we can navigate to our starter project Gradle directory, and that's going to contain our project. You'll notice if we look within that directory, you'll see the Gradle W application there. And Gradle W stands for the Gradle wrapper. So essentially, our project has Gradle installed within it, and it has the appropriate version. So if I were to issue the Gradle W-V command, it will go ahead and invoke that Gradle command on the internally installed version of Gradle. And that's because we specified that version within our wrapper. When we use the Gradle wrapper, we can execute Gradle commands from the root of our project. And remember that each wrapper is tied to a specific version of Gradle, so everybody building our project will have the appropriate distribution. With the Gradle wrapper in place, we can go ahead and run our SpringBoot application by invoking the boot run task. And once we invoke that task using Gradle or the Gradle wrapper, you will see that our project will begin to build and eventually will run. So there we see the ASCII art for SpringBoot, and our project begins to set up, and eventually we will have a running SpringBoot application. There you can see Tomcat has started on port 8080, so our application would be able to service requests at this point. So in this lesson, we built out a SpringBoot project that uses Gradle as a build tool, and we took a closer look at the Gradle wrapper to see the benefits that it provides to developers looking to build software. In this lesson, we'll take a look at the Build.Gradle file that was generated by the SpringBoot Initializer. The file is located within the root of our project, and it serves as the build specification or configuration for our SpringBoot project. Understanding the Build.Gradle file is key to understanding how SpringBoot works with Gradle as a build tool. So let's take a closer look at our Build.Gradle file. Double-click on the tab to maximize the file, and you'll notice we are first presented with the build script block. The build script block allows us to specify configurations that are specific to our build. Within the build script block, you'll notice the ext block, and this simply contains a property that we would like to set for our entire build. So here we create a property named SpringBoot version, and this acts like a variable that we can then reference within the remainder of our build script. So here you see the SpringBoot version being used to specify which version of the SpringBoot Gradle plugin that we'll be working with. And that brings us to our next point. Within our build script, we are able to specify dependencies that need to be on the class path when our project is built. And here we are pulling in a plugin provided by the folks at SpringBoot. We're able to download this artifact because we have specified a repository within our build script block. So here we're saying we'd like to access the Maven Central repository, and we'd like to pull down this artifact that we will use to work with SpringBoot and Gradle inside of our project. Having this plugin in place allows us to experience the benefits that we saw when working with Maven as our build tool. If you'll remember, we specified a parent for our Maven build, and that parent contained a bunch of version information about all of the different dependencies that may be required by our Spring project. We are unable to specify a parent within a Build.Gradle file, but what we can do is pull in the Gradle plugin, and this allows us to leverage a bill of materials that is provided via the plugin, and that allows us to leverage the versioning information that SpringBoot provides. So we no longer need to specify any version information when we download dependencies from our repositories. So you'll notice that within our project's dependencies, we are able to specify the SpringBoot Starter Web POM, and that artifact will be downloaded via Maven Central, and we don't need to provide any version information about that artifact. In this way, the SpringBoot plugin works with Gradle's dependency management system in order to facilitate how we pull down the dependencies of our project. Now, Gradle's dependency management system used to depend upon Ivy, but now the dependency management system within Gradle has been built out within the tool, and it is able to leverage both Maven and Ivy descriptor files. So it's able to read POMs as well. And that's how we get our starter POMs into our project. And here you can see we can specify them for different phases in our project's lifecycle. So here our SpringBoot starter test POM is actually applied in the test compile lifecycle as opposed to the compile phase where the SpringBoot starter web POM is applied. Looking more closely at the top of our Build.Gradle file, you'll notice that we apply different plugins that we would like to use within our project's build. We can then invoke tasks on those plugins in order to achieve some piece of functionality in our build, and we're also able to set different properties that will apply to our project. You'll see here that we are excluding some items from our class path using the Eclipse task. Now, if you were not familiar with a particular task inside of your Build.Gradle file, you can always go to the Gradle website to further explore the DSL. So the Build.Gradle file is written using a groovy syntax, and there is also a DSL that we can reference when we need to know more about tasks. So here we are at Gradle.org, and we're going to take a look at some of the tasks used within our Build.Gradle file. So on the Gradle.org website, you'll go to Documents, and this will take you to the release notes for the latest Gradle build. And here you'll see the DSL reference. And this is going to look very familiar to you. It's going to look like the Java APIs that you may have worked with when writing Java code. So here you'll see all of the different blocks that are available within a Gradle file. And you also see different types that you can look at. And there's core types, and then there's other different types that you can use when configuring your project. There's quite a few. There you see like a find bugs type you can work with. There's also a type that will allow you to generate a Maven POM. There are many different types that you will find and possibly use. Now looking here at the Eclipse project, you'll see that using the Eclipse plugin, here's the Eclipse type, and you can further look at the options available to you within this plugin if you see something that you are unfamiliar with in order to learn more about your build and what is being performed. This is very similar to the Java docs that you would work with or when you would explore an API. Now, returning to STS, we're going to minimize our Build.Gradle file, and you'll notice that within the Gradle Tasks tab, there is our project, and within that project, we have all sorts of different tasks we can run. So here we see the boot run task, and that is actually provided by the SpringBoot plugin. This allows us to run our application in place. So to finish up our lesson, we're just going to go ahead and run this Gradle task, and you'll see that within our Gradle executions, we will see the different steps within the task execute. There we see it compiling our Java source code, and once that's complete, it's going to eventually get to the boot run task within the plugin, and that's going to launch our application. So if we look at our console, we should see boot kicking off, and there it was. So there we see the SpringBoot ASCII art, and we know our application has been launched. And then we see that the Tomcat ports have been opened and that our application is now running. So in this lesson, we learned about the Build.Gradle file, which is pretty much the equivalent of Maven's POM.xml file, and we saw how the Build.Gradle file is used similar to the POM.xml file in order to pull in the different starter POMs from the Maven Central Repository MongoRepository, and that is done using the SpringBoot Gradle plugin. And that plugin also provides us with the boot run task, which we can then use to execute our SpringBoot applications. One of the main features of the SpringBoot Gradle plugin is its ability to package the project as an executable jar or a WAR file. In this lesson, we'll walk through two demonstrations that illustrate the power of the boot repackage task within the SpringBoot Gradle plugin. If we expand the Gradle task tab, you'll notice that within the build subdirectory, we have the boot repackage task. This task can be used to create an executable jar or a WAR file. It is provided by the SpringBoot Gradle plugin. Thanks to the Buildship integration, all we need to do is right-click on the task and hit Run Gradle Tasks. This will execute our Gradle tasks, and we will see its progress within the Gradle Executions tab. Eventually, our classes will get compiled, and then our application will be packaged as an executable jar. If we minimize the Gradle Executions tab, and we click on the Project Explorer and hit F5, you'll notice that our directory structure will now include the build directory. And within the build directory, you will see a starter-project-gradle jar file. Now you'll see the snapshot versioning information also on that jar file. But this was the executable jar file that was constructed by the boot repackage task within the SpringBoot Gradle plugin. If we would like to more closely inspect this jar file, we can open a terminal using the Quick Access toolbar. So just type terminal and then select the terminal view. Within the Terminal tab, we'll be presented with a command line that has navigated to the root of our starter project Gradle directory. From this directory, we can change to the build directory, and then we can navigate into the lib directory, and that directory is actually libs. So from the libs directory, if we inspect, you'll notice that we have our jar file, and we can further explore this jar file by using the jar command and then supplying the tf option and then putting the name of our actual jar file. And here you'll see all of the classes and the other libraries that are packaged within this self-executing jar. So there we see our embedded Tomcat container. We see the library for that container. We also see some libraries from Spring, such as the Spring Web MVC library. And this is the nature of a self-executing jar. Everything that we need to execute our application is packaged within this large Uber jar file. Now, this is in contrast to the conditional approach of building out a WAR file, which is then deployed to a standalone container. I'm going to go ahead and clear our console. And then you'll see from within the console, I can use the java-jar command to actually launch our jar file. So here I'm just using basic command line to launch our self-executing jar, and this will launch our application. Now let's return to our console, and what we're going to do now is we're going to look at how we can modify the Build.Gradle file within our editor to package our application as a WAR file instead of a jar file. So the first thing we'll do within the Build.Gradle file is we will include the WAR plugin, and this will allow us to provide the WAR task, which we're just going to go ahead and switch over our jar task to a WAR task. And within this task, we can provide different properties. And the properties available to us are actually the base name and the version. So it's very similar to the jar file in the fact that they have these two properties in common, and we're just going to leave those in place. Finally, we'll also need to add an additional block to specify that our runtime is provided to us. So we will add a configurations block or closure. And within that block, all we need to do is say provided at runtime, and this will indicate that our container will be available at runtime, and we do not need to have it packaged within our war file as a library. So now with the war plugin applied in our Build.Gradle file and the war task being invoked, we can go ahead and execute the boot repackage task on the SpringBoot Gradle plugin. And this will cause our application to be packaged as a war instead of as an executable jar file. So simply navigate to the Gradle Tasks tab and then right-click on the Boot Repackage task and hit Run Gradle Tasks. And here we can see its execution, and you'll see that we have quickly created our war file. And if we navigate to our Package Explorer and we now refresh our project, and you can do that by hitting F5 or right-clicking and choosing Refresh, we now have a war file that we could in fact deploy to a container such as Tomcat. So in this lesson, we took a look at the boot repackage task within the SpringBoot Gradle plugin, and we saw how it allows us to package our application for various forms of distribution. In this chapter, we'll focus on some of the advanced configurations that are provided to you through SpringBoot. These configurations are designed to provide us with flexibility when we configure and build our applications. One of the things we'll see is how we can use random configuration values within our configuration files. And this can be useful when testing or when working with something like a REST API to develop a key. We'll also see how to use profiles to conditionally select the configuration for our application. And this is a very important concept. In the past, you'd often see application logic built to make your application perform or behave a particular way for an environment. And with Spring, they have created the profile, which is a very useful tool to allow us to say, hey, these particular beans are used when I'm running in this environment, and these particular beans are used when I'm running in this other environment. And that nice feature has been enhanced within Spring Boot, and we'll take a look at that. We'll also see a way that we can inject the properties from our configuration files. So we've seen in the past that when we specify different program arguments or we specify different properties within a Spring application, they're available via the expression language because they are actually built into the IOC container using various features. We'll just take a look at a flexible way to obtain those properties by injecting them into our beans. Finally, we'll take a look at how we can execute some code when Spring Boot starts up one of our applications. And this is a frequent requirement. You'll see that you'll need to do some pre-work before your application actually begins to execute. So we'll take a look at some interfaces within the Spring Boot library that help us out. One useful feature provided by Spring Boot is the ability to create random values within our configuration files. This can be helpful when building tests or creating values for things like cache busting or REST API keys. In this lesson, we'll take a look at this feature within Spring Boot. To get started, we're going to build out a new Spring Boot project using the Spring Starter Project dialog. Within the dialog, specify the name of the project as Spring-Boot. Be sure to select a Maven project and then specify your artifact ID as Spring-Boot. With those values in place, you can hit Next, and then select the web dependency and hit Finish. Spring Boot will build out our new project. Now, in order to demonstrate random configuration values, we're going to need to build a new class within the com.o'reilly.boot package. So open up the New dialog, and then create a class, and we'll name this class MyMessage. Simply hit Finish, and our new class will be generated. Within our MyMessage class, we will add the component annotation to the class declaration, and then we're going to create a new int, and we'll name the int message value, and then we'll generate accessors for the message value. So we have get and set methods for our new class, and then what we'll do is we're going to use the value annotation on the message value field to specify an expression that will provide the value for our field. And we're just going to use the property my.messageValue. So we'll go ahead and copy that, and then we'll import the value annotation. And now we're going to navigate to the Application.Properties file, and we are going to specify a value for that property within the Application.Properties file. So here's where the random feature comes in from Spring Boot. Within our expression, we can type random and then .int. And what this will do is it will use a random value property source object within the Spring Boot library, and that's going to provide us with a random integer. Now, in order to display that integer within our application, we need to do a few things. So I'm just going to make this a REST controller, and then I'm going to create a new method that returns a string, and we'll call it the welcome method. And then I'm going to make this an endpoint by adding the request mapping annotation. And then what we'll do is we will auto wire our MyMessage bean, and then we can return the value from our welcome method. And I'm just going to say welcome, your lucky number is, just to make it a little bit fun. And then we can use the MyMessage bean, and we'll invoke the getMessageValue method. And if we import AutoWired, we now have an application that's going to serve lucky numbers. And that lucky number is going to be randomly generated by Spring Boot when the application starts. Now everybody will have the same lucky number. So now let's go ahead and we will run our application. I'm just going to navigate to the Package Explorer, right-click on the project, go to Run As, and then Spring Boot Application. And that will launch our application, and we can visit the context root, and there we see our lucky number. Well, that's not a very good lucky number. Luckily for us, Spring Boot allows us to specify an upper limit, so we can say something like, give me all the lucky numbers from 0 to 9. And now if we restart our application, you'll notice that our number is going to be more reasonable. So we can hit our URL again, and there we get a number under 10. We can also specify a range. So let's say I say between 10 and 1500. And this is going to give me a number between 10 and 1499. You need to remember this max is actually exclusive. And I also want to talk about the syntax of this statement. So it's random.int, and then actually this parenthesis can be any character. So we could actually change these up to asterisks. And then you have to specify your lower value, your upper value, separated by a comma. Now be very careful. If you put a space in there, it's not going to work. So while they were very robust in allowing you to use any character, they were not so robust with not allowing you to use a space after the comma. So let's go ahead, restart our application, and we will now hit the URL once again, And this time we see that our lucky number is 325. So we can generate random ints, and we have a lot of control over those. We can also generate a long, and if we would like, we can also generate a string. Now the syntax for a string is random.value. So let's go to the myMessage class, and we'll switch up our int for a string just using find and replace. We can easily swap our field type, and I'll go ahead and save our class file. And now I can run the application one more time. And if we take a look, you'll now see that we get an alphanumeric value, and it looks a lot like a hash that was generated by SpringBoot randomly. So this would be good for something like an API key. For our last demonstration, I'd just like to show you this can be achieved with YAML as well. So if we go to our source main resources source folder, we can create a new file, and I'm going to name this file Application.YML. That's the YAML file extension. And then we can specify my, and then say message value. And then we can use the expression language to generate a random value within YAML. Now we'll need to, I'm just going to rename our application.properties file so our application no longer picks it up. And now we'll see if we run our application, it's going to rely upon the YAML configuration, and we will indeed get a new lucky alphanumeric number. So in this lesson, we saw how to use the random value property source object within our configuration files to generate random values. And this is a feature provided by SpringBoot that can be used to create test data or API keys within our configuration. When working with Spring, we can use profiles to conditionally select the various beans and configurations that should be present within our project. This is extremely helpful when dealing with multiple environments and different run configurations. In this lesson, we'll explore how SpringBoot facilitates working with profiles. So to get started, we're going to navigate to the myMessage class. Within this class, we're going to remove the component annotation as well as the value annotation. And that's because we're no longer going to component scan for this class. Instead, we're going to declare this class within an application configuration file. So we're going to create a new class, and we'll name this class Application Configuration, and this is going to be a Spring configuration file. So we'll go ahead and add the configuration annotation to our class, and this signifies to Spring that our class is going to declare several beans which will be instantiated inside the Spring IOC container. So we're going to declare our bean annotation, and then we're going to declare a method that returns a type of myMessage, and we'll just name it myMessage. And then within the body of that method, we're going to declare a new variable with the name myMessage, and it's going to be of type myMessage. So we'll invoke the constructor, and then we're going to return myMessage, and we can also set the message value field on the myMessage type. Now, the way we're going to set this value is by using the value annotation and specifying it within our method arguments. So we'll use the expression my.messageValue, and then we will declare a string, and we'll call it message value. So we will read the my.messageValue property from our application.properties file, and that will be injected into our myMessage method, and then that will be used to set the message value field on the myMessage object, and that instance will eventually be declared as a bean within our Spring IOC container. The next thing we'll do is duplicate this bean definition, And then we need to do some modifications. So I'm just going to change the method name, and I'm going to remove our argument to this method, and I'll just simply hard code a simple string within our myMessageDev method, and I'll just say this is the dev method. And with that hard-coded string, we now have two different bean configurations for the myMessage type. At this point, we will use the profile annotation from Spring, and we'll import that type, and then we need to provide the name of the profile that will cause this bean to be used. So we're going to call this profile prod, and then we're going to add another profile annotation, and we'll call this profile dev. So we have two bean definitions, and the first will be used when we're running under the prod profile, the second while running under the dev profile. So now we need to go ahead and specify which profile we would like to use. We can do that within the Application.Properties file. So we can look at the Spring Profiles Active property, and we can go ahead and set that to whatever value we would like for our profile. So let's use the dev profile, and that will cause our value that is displayed to be this static message that we have put within our myMessageDev method. So let's go ahead and we'll run our application. So I'll just right click on the project, go to Run As, and then Spring Boot Application. Now, once our application is loaded, we can go to the localhost, and there we see the message displayed to us, and we know that that message came from our configuration of the bean that had the static message within it, and that bean corresponds with our dev profile being loaded. So there we were able to conditionally select our bean based upon our profile, exactly what we wanted. And the reason that occurred is because we specified the spring.profiles.active property within our application.properties file. Now, another way to achieve this is to provide a program argument that specifies your preferred profile. So we're going to go to Run Configurations, and within our Run Configuration for the Spring Boot application, we're going to define a program argument for the spring.profiles.active property. And we're going to set our profile to prod. So we would like to run under the prod profile, and that will cause our message value to be read from our application.properties file, and that's going to be randomly assigned. And that's because we're under the prod profile and we're using this bean. Now, you may be asking, well, we've defined the property within the application.properties file at the moment as dev. Well, what is going to happen, and we need to make sure that we stop our application to have those changes picked up, but what will happen is the command line arguments or the program arguments are going to override our application.properties setting. So let's go ahead and relaunch our application, and then we can see that if we hit this URL again and everything is properly loaded, we now get a random value as specified in our production profile setting. So we still have a little bit more to talk about with profiles, but at this point we're going to stop and take a break, and we'll pick up where we left off in our next lesson. In our last lesson, we saw how Spring Boot's application.properties file can be used to load an active profile. And to do that, we use the spring.profiles.active property. Continuing on, we're going to take a look at another approach to specifying conditional properties with profiles. This approach will rely upon how we name our application.properties file. So what we're going to do is we're going to copy by hitting Control-C and then paste our new application.properties file. And we'll need to rename this file. And what we do is we embed the profile name within in the properties file. So I'm going to label this as my prod application-prod.properties file, and that will define my production profile. Within each of these files, I'm going to remove the spring.profiles.active property, and within my prod profile, I'm going to switch the value of the my.messageValue property. So I'm going to put this to something like this is the prod profile, and that's just an indicator for us to determine what profile we are using. Now, within our application configuration file, I'm actually going to remove our second bean, and I'm going to remove our profile annotation from the myMessage method. So at this point, we only have one bean, and that bean is going to rely upon our properties in order to determine the message value. Now, our message value will differ depending upon which properties file we look at. So for the prod properties file, we have this static string, and then for the application.properties file, our just regular application.properties, we have a randomly generated value. Under this configuration, our program arguments are going to determine which profile is set. So if we look at the arguments for our SpringBoot run configuration, you can see that we are passing in the prod profile. So that will cause the application-prod.properties file to be read. Now, if we did not specify this, and let's just remove it, and we'll apply it, and then we'll run our application is going to default to the application.properties file. So let's go hit localhost, and there we see we get our random value. Now, if we were to return to our run configurations and we look at the arguments for our SpringBoot application, we can add in the active profile property and specify it as prod. And if we apply that property and then stop our SpringBoot application and then restart it, you'll now notice that when we navigate to our application and we hit our context root, we get our prod profile applied. This is a great way to configure our applications because we can have our different application.properties files and the different profile-specific versions right within our source code. And depending upon our environment, we can have different command line settings to choose which of these configuration files that we will actually apply depending on the profile. So you're able to see all of the different properties and easily switch between them using this approach. And if you are not in a specific profile, you can always default back to the application.properties configuration file. So there is some precedence built in that you can take advantage of. So in this lesson, we worked with the profile facilities within SpringBoot, and we learned how to create profile-specific application.properties files in order to determine our configuration. When working with Spring, we're able to use the value annotation to inject properties from our external configuration files. So for example, here we are using the value annotation on a method argument, and we could also use this on one of our fields within a particular class. In this lesson, we're going to take a look at another approach that allows us to inject properties from our external configuration files. So instead of specifying the value annotation on our field, we're going to use a different annotation provided by SpringBoot, and that's the configuration properties annotation. This annotation allows us to specify a prefix, and this prefix is actually going to come from your application.properties file. When we look at the property my.messageValue, my is considered the prefix, and message value would be considered the final node of the property. So if we head back to our class, you can see that we specify a prefix of my, And then if we're to look at our fields, and we take our field name, and we would concatenate that using dot notation with our prefix, we would provide the coordinates of our field within the myMessage class, or our path to that field. Using this approach, SpringBoot is able to inject properties into our beans and configuration classes. So I'll go ahead and clean up our imports, and then we need to register this class with our application so that it is qualified to have its properties injected. And the way we do that is by adding an Enable Configuration Properties annotation to our application class. And within this class, we need to specify all of the classes that are available to have properties injected within them. And we would like that to occur on our myMessage class. So I will go ahead and specify the class, registering it to have properties injected. And then the final thing that we need to do is we need to head to the application configuration class, and we need to just comment out these annotations so we don't step on our toes when we run this application. We don't want to have these beans registered. We can also change our message value to something a little bit more distinct. So let's just say 13, and we'll spell it out to be very specific. So now if we run our application, what we'll see is that once we navigate to the browser, we are then able to confirm that our properties were injected from the external configuration files. And that's all due to the way that SpringBoot is able to bind our properties to different fields within our beans. This approach is very flexible. It allows you to use several variations of the property name. So for example, you can write your property names in all caps, separated by underscores, much like you would using a database. It also allows you to use dashes in that manner. And you can see actually IntelliSense is helping us out there and showing us the valid values. We're just going to go with the all caps approach for our next demonstration. Before we run that demonstration, I'd like to show you another way that we can register our bean to have its properties injected. So we don't necessarily need to specify the Enable Configuration Properties annotation. Instead, we can just rely upon component scanning to pick up our myMessage bean, but we need to make sure we annotate it as such. So we'll add the component annotation. This will make the class get picked up during component scanning. It will become a bean. SpringBoot will notice the configuration properties annotation and then inject the appropriate properties from our configuration file. So let's rerun our application and we'll just take a look. We'll get the same result, but we can just validate that our changes are now working. So we'll head back over and let me just do this to prove I'm actually applying the changes. So there we go. We see that we were able to use the more flexible approach to configure our property injection. And for our final demonstration, we're going to specify the specific source of our properties. So we're going to create a new properties file. So I'm just going to copy, so Control-Z, Control-V, our application.properties file. And I'm going to name this file example.properties. And if we open that file, let's make this 15 now. And what we can do is within our myMessage class, under the configuration properties annotation, we are actually able to point to a specific file. So here we can say that we would like to use the example.properties file on our class path. Now, when we provide a specific location for the configuration properties annotation, it will override any of the defaults that SpringBoot's going to put in place. So it's going to ignore the application.properties file. Now, when you run this demonstration, be sure to shut down the SpringBoot application and then rerun it. So now if we navigate to our browser, we can hit our REST controller and we see that we receive the new value which has been injected from the example.properties file. And we were able to specify that by providing the locations element on the configuration properties annotation. So you can see how Spring Boot really assists us by injecting the properties we have configured directly into our beans with minimal explicit configuration on our part. Now, I would argue that it's not as self-documenting as actually having those configurations specified right within the class file, but really that is your preference as a developer. The ability to inject these properties is one of the many features within Spring and Spring Boot that allows us to run the same source code within multiple environments. We see this within profiles as well. So in this lesson, we took a look at another tool that Spring Boot provides to us to allow us to manage kind of the build process in working in multiple environments. A frequent requirement for developers is to execute a particular block of code once an application is started. This can be necessary to perform some notifications or execute specific logic for the application. In this lesson, we'll take a look at Spring Boot's Application Runner and Command Line Runner interfaces, which will allow us to execute code upon the startup of a Spring Boot application. These interfaces allow us to register hooks into Spring Boot's startup procedure. To get started, we're going to create a new class within our com.o'reilly.boot package. So simply hit Ctrl-N to open the new dialog and type class and then select the Java class. We're going to name this class MyCommandLineRunner, and we'll want to implement the command line runner interface provided by Spring Boot. So just select the command line runner interface and hit OK. And now that we've defined that interface, we can hit Finish. Within the class, the first thing we need to do is add the component annotation so that this class is discovered by component scanning and made into a bean. Now we can provide the specifics of our run method, and we can provide some implementation here. We're going to keep it really simple. You'll see that the method provides a var args string. So this is going to contain all of the program arguments that are passed into the application. So let's just write out to the console. These are the arguments used to start the app. And then below that, we can iterate through each of those arguments. So it's going to be a string, we'll name it arg, and then for each argument, and then we can print out the particular argument. So this is going to execute when our Spring Boot application begins to start up. Normally, you would have a little bit more application-specific logic here. Maybe you'll send an email or something. You'll maybe populate some values and maybe some configuration files. Really, the possibilities are limitless here. Just to add to our demonstration, let's go ahead and add some arguments to the run configuration. So this can be anything and just give it a value of something. And what we'll see is that when we start up our application, we'll now see that our logic will be executed. So there we see these are the arguments used to start the app, and we see the arguments printed out within our console. And that's all because we created this command line runner bean, which provides an implementation of the run method that is tied into Spring Boot's startup procedure. Now let's do the same thing for the application runner interface. So we're going to create a new class, and we'll name this class MyApplicationRunner, and then we click on the Add Interface button, and we select the Application Runner interface and hit Finish. And you'll notice this is very similar to the command line runner The only difference is that instead of receiving the raw arguments as a string that were passed to our application, we now get them via this application arguments object. We do need to register this class as a bean, and at this point I'm actually going to go deregister our other class so we don't get confused. And now we can provide our implementation for this class, and it's going to be very similar to our last implementation. So these are the args for the application, and now we can just iterate. Let's just go through all of the option names. So we'll grab all the option names, we'll get them as a string, and we can print them out. So you would have those options available to you when writing your startup logic if you needed to make some sort of determination based upon them. So with this in place, we can relaunch our Spring Boot app, and let's head over to our console. And there we see the nice ASCII art. And then we see these are the args for the application, and once again, we print out those arguments. And that's all made possible by the application runner interface and how it ties in with Spring Boot's startup procedures. So that's pretty simple stuff. Define an interface, implement it, register it as a bean, and Spring will do the rest of the work. We've seen that pattern in the past. Now, the other thing I'd like to take a look at is these application arguments, and these can be passed in and injected into any of our beans. So if we navigate over to the application, we can auto-wire a field of type application arguments, and that will be available for dependency injection within any bean. And then we will print out the value of one of the arguments, or the name of one of the arguments. So let's just use the arguments, and what we can do is we can get the option names, and we can just grab the first program argument, and we'll return that from our REST API. So it's kind of nonsensical, but it demonstrates our points. So let's relaunch the application, and what you'll see now is if we navigate to a browser, we can hit our localhost, and we now print out your lucky number is one of our program arguments. Not a very lucky number. But what you can see from this demonstration is that we were able to inject the application arguments, and then we were able to use those arguments within our REST controller. And just know that those application arguments, as useful or unuseful as they may be, are available for auto-wiring throughout your application. So in this lesson, we took a look at two approaches to executing code when a Spring Boot application starts, and that's the application runner, which provides us with the application arguments via a run method we provide the implementation for, and the command line runner, which provides us with the program arguments as a var args string. Either approach works, and you can use whichever one you would prefer. Spring Boot provides strong support for developers building web applications. The Spring framework has always placed an emphasis on web development, and this tradition is continued within Spring Boot. Primarily, Spring Boot supports web development by focusing on making Spring MVC features more accessible and by helping us define the configuration of embedded servlet containers. In this chapter, we'll explore how Spring Boot can help you unlock powerful features within these areas. So let's take a look at what we'll be covering within this chapter. First, we're going to take a look at all of the auto configuration provided by Spring Boot within the web arena. Now, most developers take this for granted because it is so easy to build out a web application with Spring Boot. Behind the scenes, many features or beans are configured for you, and we're going to explore those. That way you can take advantage of all of the benefits provided to you through Spring Boot. Next, we'll take a look at how templating technologies can be used to construct our view layers, and how Spring Boot supports supports their configuration and makes it easy to get started using a template technology such as Timeleaf or Velocity or FreeMarker. There's support for several different templating technologies. Particularly, we'll be looking at Timeleaf and Mustache. We'll also see how we can version our static resources in order to control caching. Now, this is traditionally a Spring MVC feature, but using Spring Boot makes it much simpler. Within Spring MVC, we would have to register some complex view resolvers to achieve this functionality, where you'll see within Spring Boot, it really boils down that configuration to a single line. We'll then shift our focus to looking at embedded servlet containers. So that's pretty much the standard when working with Spring Boot, is to include embedded Tomcat or embedded Jetty within your application. So you're packaging up into an executable jar file that will then be used as opposed to a standalone servlet container. You'll hear the expression make jar, not war thrown around quite a bit within the Spring circles, and that's something they're heavily advocating for, is moving to these embedded containers. So we'll take a look at how you can easily switch out your embedded container and how you can then provide some customizations for that container. It's very simple, you'll see within the customizations, to change the way you connect to the server or the way it provides responses to a user. We'll see how we can use compression there, which is pretty interesting and very beneficial to us. We'll continue with a deep dive into embedded servlet containers and take a look at how we can register things like servlets, filters, and listeners with the actual container itself. And then finally, we'll see how we can programmatically configure an embedded container. Spring Boot provides us with several approaches that we'll explore if we would like to configure our container using good old Java code. So in this chapter, we're going to learn a lot about how Spring Boot supports web development, and it's very extensive. The first bullet point, the auto-configured features, are just such a large area, and often they're an oversight to us as developers, and it really demonstrates the power of Spring Boot. In this lesson, we will inspect the web application features provided to us by Spring Boot's auto-configuration for Spring MVC. Many developers working with Spring Boot enjoy this feature with limited knowledge of the underlying components and their purpose. We'll be taking a deeper look at what is provided by Spring MVC Auto-Configuration so that you understand the components provided for you by Spring Boot. To help us get started, I've placed a simple Spring Boot project that uses Spring MVC within our working files directory. The project was created using a Spring Starter project specifying the web dependency as we have seen in previous lessons. To get started, let's inspect the project structure. So you'll notice that we have the source main resources source folder, and we see our Application.Properties file, as we've worked with. But you'll also notice the static directory as well as the templates directory. And within these two directories, I have placed a CSS file as well as an index.html file and a viewresolver.html file. Now, these are very simple front-end resources that we're going to be using throughout this lesson. First, I'd like to show you how Spring Boot's auto-configuration for web applications allows us to easily display static resources. So I'm going to go ahead and I will relaunch our Spring Boot application, and then I'm going to navigate over to our browser. From the browser, we can just hit the context root, and you'll see that we get this message in red that says this is the entry point to the application. So let's talk a little bit about what happened. Well, first, I want to talk about something we don't see. You do not see a web XML file anywhere within our project. In fact, you won't even see a declaration of the dispatcher servlet. The dispatcher servlet is automatically configured for you by adding the Spring Boot application annotation to our application class and by having the starter web dependency within our POM.xml file. This will automatically cause a dispatcher servlet to be registered to the root of our application. So every request will be initially processed by the dispatcher servlet. Now, the reason we were able to see our index.html file, even though we have not specified a request mapping to index.html, is because out of the box, as long as we have our index.html file within one of our static resource directories, Spring Boot Autoconfiguration will map our root context to index.html. So this is where we saw our page being displayed, and here we see the markup for that page. Now, you'll also notice that we have included the index.css file, and that is contained within our CSS directory inside of our static resources. So here's what I'm getting at. If you have ever manually configured a Spring MVC project, you know that you need to specify the directory of your static resources. And this tells the dispatcher servlet to neglect those directories or those paths when you are processing requests through the dispatcher's front controller pattern. So by default, Spring Boot Auto Configuration will specify the static, public, or resources directories as special directories that we will use for serving static resources, and you no longer need to configure that manually on your own. If we inspect our application class, you'll see more proof of Spring Boot Auto Configuration in action. So you'll notice that we have specified the request mapping annotations, and these instruct Spring to use request mapping handler mappings, as well as a request mapping handler adapter. And that's how we enable the use of the request mapping feature in order to route requests to the specific controller methods. Now, normally, we would have to register the request mapping handler mapping within a Spring MVC application. But luckily for us, since we have included Spring Web MVC on our class path by way of the starter POM, we have those components registered for us behind the scenes without our knowledge. And that's how a lot of the auto configuration works. These components are just registered for you and you're not really aware of them. And then you use something like request mapping without even thinking about it. So you'll notice that we have specified a request mapping to the /view resolver URL. And that path will navigate to a view resolver template that we have set up within the templates directory. If we take a look at our pom.xml file, you'll notice that we have included the Spring Boot starter timeleaf starter dependency. And that instructs Spring Boot to configure components in the background that will handle view resolution of our timeleaf templates. In fact, what you'll see is that we get a timeleaf view resolver. So we're able to take the logical view name of view resolver and map that to one of our actual timeleaf templates. So if we navigate to our browser and we fire a request against that URL, you'll now notice that our timeleaf template is displayed for us, and that is all handled by beans configured by Spring Boot behind the scenes. You'll find that by having the Spring Boot application annotation on your application and having the Spring Web MVC dependency on your class path, it's very much like having the Enable Web MVC annotation in place from the Spring MVC project. It provides you with a number of essential Spring MVC beans that you'll need for your project. Another bean provided by Spring Boot's auto configuration is the Content Negotiating View Resolver. This bean allows us to return a particular response depending upon the content type requested by the request. So, for example, we have the /cat path mapped to the cat method on our controller. And this controller method is annotated with the response body annotation. And this means that the returned object from our method will be written directly to the response body for our request. So for example, if I returned a string, that string would be what is passed back to the client that has made the request as part of the response body. In our case, we are returning an object cat, and we would expect to see that serialized to a particular form. Now, when this occurs, when we get a request in for a particular content type, the content negotiating view resolver makes that decision about what we return. So let's take a look at the content negotiating view resolver in action. If we navigate to our browser, and then we can hit the /cat resource, and here you see that we get a JSON representation of our cat object. Now, if we return to our pom.xml file, we can add the Jackson data format XML artifact to our POM file. So let's go ahead and add the dependency. We'll just type Jackson, and that's going to give us a number of options. And we will click the Jackson-data format-XML artifact, and we will save our pom.xml file. And now let's relaunch our SpringBoot application. And once the application is relaunched, we can navigate back to the browser and specify we'd like to see the cat in XML. And there we get an XML representation of our cat. And that's made possible by adding in our content negotiating view resolver that is included behind the scenes by SpringBoot, and also adding in our dependency upon the Jackson XML serialization and deserialization artifact. You'll also see that you can request JSON using the actual extension. And if we do request something that is not available, let's make up a file type. It does have a default that it corresponds to. Finally, let's take a look at one last feature provided to us by the auto configuration. If we were to navigate to a path that is not mapped, you'll notice that we have a default error page configured for us, and that's provided by SpringBoot auto configuration for our web app. So there's all of this configuration that's provided for us, and there's all these beans that are registered for us behind the scenes through auto configuration. And that saves us a lot of time as a developer. Less time configuring and more time developing. SpringBoot provides support for the templating technologies available in Spring MVC. Templates allow us to render dynamic HTML content, which helps developers keep the user interface separate from their business logic. This minimizes the coupling between the layers of our application and results in more maintainable code. Currently, SpringBoot supports FreeMarker, Groovy, Timeleaf, Velocity, and Mustache templating. In this lesson, we'll take a look at how to configure and customize one of the more popular template libraries, Mustache. Let's start out by looking at our project within the Package Explorer. You'll notice that within the source main resources source folder, we have a directory named Mustache. And within Mustache, there is a Mustache template that we're going to use. It's very simple. Now, also within the source main resources directory, you'll notice the templates directory. Normally, when working with templates, you can put your templates inside this directory, and it will always be read by SpringBoot's support for templating. You'll see a little bit later that if you'd like to use a specific or a custom directory, there's a little bit of configuration that we need to provide to SpringBoot. The first thing that we'll need to do, however, is to add support for Mustache within our pom.xml file. So we're going to navigate to the POM, and we need to add a starter dependency. So I'll click on the Add Dependency, and then I'm going to look within the org.spring-framework group ID, and we'll get some choices here, and you start to see the Spring Boot starter POMs, and we'll pick the starter mustache POM. And once that is within our pom.xml file, we now have support for mustache. Now let's add the appropriate configurations to our Application.Properties file. Using the handy IntelliSense within STS, we can look at all of the properties that are specific to mustache configuration. So here you see quite a few. You can specify individual template names that this applies to. You can also specify some rules regarding caching. The two properties we are most concerned with are the prefix and the suffix. So these are added to our logical view names in order to locate a particular template. So Spring MVC will take a logical view name, let's say it's template, and it will add the prefix. In our case, it will need to be mustache, and then our suffix will need to be .html. So let's go ahead and configure that. And we want to specify that we are looking at this from the class path, and then we want to look in the mustache directory. And then we also need to specify the suffix, which is going to be .html. So when we construct a path to our template using a logical view name, we will use these two properties for concatenation to locate that view. So let's go ahead and we'll save the application.properties file. And now we're going to navigate to the application.java file. Within this class, we need to establish a controller method that will handle requests and route them to our template. So we're going to go ahead and create a method that returns a string, and I'm just going to name this method mustache. And within this method, I'm going to return the string template, and this is our logical view name. So that corresponds with the template that we have in the mustache directory. And it will be used to concatenate with those properties we've already specified. Now, another thing I'm going to do is I'm going to go ahead and add a model as an argument to this method. Then using the model, we will invoke the add attribute method, and this accepts the name of our attribute. So in our case, I believe it's company. Let's take a look at our template. Yep, so it's company, and then we provide the name of our company. In this case, I'm going to provide the name O'Reilly. Add our semicolon, and now we just need to add our request mapping, and I'll map this to the path mustache, and then we'll import the request mapping annotation. So at this point, our application is configured to run our demonstration. So let's navigate back to the Package Explorer, and we can right-click on our Spring Boot project, and we can run as a Spring Boot app. Now let's navigate over to our browser, and we can hit localhost 8080, and we want to hit the mustache path, and there you see that our template renders, and we display our dynamic content. So in this lesson, we learned how to configure templating support within Spring Boot to support the templates used by Spring MVC. Now, there is support for the other template technologies, and you can see that support if you start to look at some of the properties available via the IntelliSense. So here we see velocity. You're also going to see free marker. And configuring those templating technologies is going to be very similar to how we configured mustache. In this lesson, we'll take a look at how Spring Boot supports the cache busting features within Spring MVC. When building a web application, it is common to cache our client-side resources in order to reduce page load times and improve the customer's experience on our application. Unfortunately, when we cache client-side resources, we expose ourselves to displaying or providing stale resource files to the browser. And this can cause some issues when a user is looking at our web page because they may not have the latest file versions. Luckily for us, Spring Boot and Spring MVC provide us with an easy mechanism to control how we version those client-side resources, and this essentially busts the cache. So to get started, let's take a look at our project. We have configured our project to use time leaf templating. So you'll see that we've established a controller method that is mapped to the /time leaf path, and that's going to navigate to our time leaf template. The time leaf template is configured to use a global.css file, and that file is going to color the message that we display to the end user. We can quickly launch this application just so you can see what we're working with. So I'm going to go to Run As, and then Spring Boot Application, and then we can navigate to our browser. And when we hit the URL, we see that we get our message in blue. Now let's return back to STS, and we're going to enable some of the resource versioning strategies within Spring MVC using the assistance of Spring Boot. So imagine that within the global.css file, we switch the color of our message over to red. Now, if that client-side resource, global.css, is cached on somebody's browser, how do we break that caching in order to display the new resource and have our message displayed in red? Well, we can use a property within the Application.Properties file to trigger some of the cache busting built into Spring MVC. So within our Application.Properties file, we're going to use the Spring Resources chain, and then we're going to pick the strategy.content.enabled property, and we're going to set this property to true. And then we'll also set the content pass. So the first property just enables our resource versioning strategy, and this strategy is going to basically rewrite the file names using a content hash. So each file name will now have a hash suffix to it, and because that hash will constantly change as we update our files, it's going to bust the cache. But what we need to specify in this pass property is the path that we're going to apply this versioning strategy to. And in our case, we're just going to look at pretty much everything. So every client-side resource, we're going to add this strategy to. Behind the scenes, what happens is a version resource resolver is added as a bean, and it works its way into the chain, and it basically sets the cache on these files way out to a year, and then we rely upon the change in the URL or the change in the file name to essentially bust the cache. So let's go ahead and we'll relaunch our application. And now we're going to navigate back to the browser, and we can load, there it is. We loaded our application, and let's reload it with some networking tracking enabled. And there you see the name of global.css has been modified to include the hash, and that's going to bust the cache. So let's return to STS, and now we're going to run through a demonstration of another strategy that we can use to version our resources. It may not always be possible to rename our files due to different technologies that we use within our view layer for our applications. To support other situations, Spring has provided a fixed strategy, and basically a fixed strategy puts a version on the path to the client-side resource, and in that way we bust the cache. So in order to enable a fixed version strategy, we simply go down to the .fixed.enabled property, and we set that to true, and then we can go and set the fixed pass property, and we'll leave that the same way as our last strategy. And then we have one additional property we must provide, and that's the version property. And this is actually how your path is going to be modified. So you will see that placed as almost like a subdirectory on the path. So let's go ahead, we'll restart our application, and we'll take a look at the fix strategy and how it allows us to version our resources. So returning to the browser, we navigate to our client-side resource, and there, if we look at our CSS file, you can actually see that v5 was added to the path, and that is how we control the caching of global.css. There you can see the URL within our header. So it's a different strategy you can use when you can't change the file name of a client-side resource. So in this lesson, we took a look at how Spring Boot supports Spring MVC's cache busting features and how we can use that feature to make sure our users always receive the most up-to-date client-side resources. Now, this is a real simplification from how you would manually configure these features within Spring MVC. In Spring MVC, you need to manually declare a lot of these beans, and Spring Boot does a great job of simplifying it. When working with web applications, Spring Boot embraces embedded servlet containers. The library chooses to bundle the servlet container within the application instead of deploying the application to a standalone container. In this lesson, we'll see how to switch between embedded servlet containers and how to customize their behavior. If we inspect the dependencies within our pom.xml file, you'll notice that we have included the Spring Boot Starter Web, and looking further at the dependency hierarchy, you'll see that it has a transitive dependency on Spring Boot Starter Tomcat, and that is another starter POM. So by default, Spring Boot sets our web applications up to use Tomcat. Well, that may not be our preference, and we may need to switch that. So what we can do is right-click on that transitive dependency, and then click on Exclude Maven Artifact. And this is going to allow us to enter an exclusion into our pom.xml file. You'll want to keep the exclusion at that top layer for our project, so just hit OK. And now if we save our POM file, we can go inspect its source. And now you'll notice that within the Spring Boot Starter Web artifact, there has been an exclusion placed for the Spring Boot Starter Tomcat artifact, and it tells Maven not to pull down that library. So all we need to do now to switch over to another embedded servlet container is add a dependency on the starter POM. So we're going to look for org.springframework.boot, and this will display all of the starter POMs available to us. And let's go ahead and configure our application to use Jetty, which is another embedded servlet container. So if we go ahead and save that configuration, we can now relaunch our application. And now if we navigate to a browser, we can access our time leaf template. And you see that we are presented with our view. And if we look further in the logs, we're going to see that instead of Tomcat, we are now using Jetty. So here we see a Jetty embedded servlet container factory bean, and that is building out the Jetty container that is servicing all of our requests. Now also with Spring Boot, we can provide a number of properties that customize the behavior of our embedded servlet containers. These properties are found within the server node, and if we take a look, some of the most common configurations you'll see are changes to how we connect to the server itself. So for example, we can specify the address property. The address property specifies the IP address or the host name that the Jetty connector is going to bind our server to. In our case, I'm going to go ahead and enter my machine name, which is Titan, so you're a little bit more familiar with my local machine. You can also specify the port, and this once again is going to modify that connector information within your embedded servlet container. And let's say we go on port 9090, and then you can modify the context path, which is going to be the root path of your application. And it always needs to start with a /. So here we have set our application to run at Titan on port 9090, and the context path will be /app. So let's relaunch our application, and then we'll visit this URL. So I'm going to navigate over to the browser, and let's change things up here. So we need to replace localhost with Titan. We need to switch our port over to 9090, and then we need to navigate to /app/timeleaf. And we have modified the connector information successfully for our embedded Jetty servlet container. Returning back to our application.properties file, now we're going to take a look at how we can compress the responses that we provide back to the client. In order to enable compression, we use the server.compression property, and the first thing we need to do is enable it, and then we need to specify a size of the responses that we want to compress. So normally I believe this is set to 2048. So we would like to compress pretty much everything. So I'm going to set this to 0. So no matter what the size of our resource, we're going to compress it. Now you'll also see within these properties a MIME type, and you can specify an array of MIME types that this applies to. Now by default, SpringBoot is going to configure HTML, XML, plain text, and CSS. So these defaults are more than adequate for us, for our purposes, so we're not going to specify any additional resources there. But you can discern what SpringBoot will compress via the configuration for the embedded servlet container. So let's go ahead and we can restart our application. And then I'm going to navigate to the browser, and we'll open up the developer tools within Chrome. And I'm just going to navigate to this URL. And here you see on our network traffic that we have our request. And if we look at the response headers, we do see that it is now gzip encoded. So here, this is the header we're looking for, and that's going to help us serve resources to the client more quickly and reduce the traffic that we are sending over our network. Finally, I'd just like to point out that SpringBoot has support for Tomcat, Jetty, and Undertow. And you'll actually see some more Tomcat-specific properties within the application.properties file in the IntelliSense it provides. So you can further refine the configuration of these embedded servlet containers using SpringBoot. When building Java web applications, we may require additional servlets, filters, and listeners to be registered with our application. We may need a special servlet to provide request processing for a unique use case, or maybe a filter is needed for some pre-processing of our requests. Within SpringBoot, we'll find support for registering these servlet components within our applications. So let's get started taking a look at this support. Within our source main Java directory, we're going to create a new filter inside the com.o'reilly.boot package. So we'll open the new dialog, we'll create a class, and I'm going to name this class myFilter, and then I'm going to make this class extend the javax.servlet.filter interface. So we'll go ahead and hit finish, and here we'll see that our class is created. So we'll have a number of methods that we can provide an implementation for. And we're just going to focus on the doFilter method. We'll modify the arguments to be a little bit more descriptive. That way we can see the request, the response, and our filter chain, which I'll actually name chain. So of course, in order to pass along in the chain, we need to invoke the doFilter method. and we pass in the request and the response. Now, we're just going to add some very simple logic here that we would perform when this filter is invoked. So simple logic goes here, and we'll just print that message out to the console when our filter does the request preprocessing. Now, one important thing we need to remember is that we need to declare this filter as a bean. And this is how we tie in these servlet components with the Spring Boot application. Spring Boot is able to scan all of the beans, and if it finds a bean that implements the filter interface, it's going to register that filter with the underlying embedded container. So now let's start our Spring Boot application, and then we're going to navigate to our browser, and we can access the application. We'll hit the time leaf template, and there we see our pages displayed. And now we need to go look at our console, and you'll notice that the logic from the filter was invoked. So we are able to successfully register a filter with the embedded container using Spring Boot. Now let's take a look at another way we can accomplish this. So currently we're using the component annotation, but this could be substituted for the web filter annotation, and this is from Java EE, so it's more of a standards approach. Now with that in place, we do need to add an additional annotation to our application class, and that is the servlet component scan annotation, and this will signal to Spring to search for annotations such as web filter, web servlet, and web listener, and register them with the underlying container. So let's relaunch our application, and now we can navigate to our browser, and we can visit our URL. And once again, if we inspect our console, there you'll notice that we once again invoked the logic within our filter. So in this lesson, we saw how to register servlet components with a embedded container along with the help of Spring Boot. This was achieved by simply using annotations that are going to cause the components to be registered automatically, along with some scanning that Spring Boot will conduct of our project. We know that the Application.Properties file can be used to configure our embedded servlet container. Aside from this approach, Spring Boot provides two programmatic methods of configuring or specifying the behavior of our containers. In this lesson, we're going to explore those two approaches. For the first approach, we are going to create an embedded servlet container customizer bean. So we will navigate to our com.o'reilly.boot package, and we'll create a new class. And I'll just call this class my customizer. And then we need to make this class extend the embedded servlet container customizer interface. And we can go ahead and hit finish. And then the first thing we want to be sure to do is register this class as a bean. So we need to use the component annotation to perform that registration, and this will cause it to be a bean within our Spring IOC container, and then we can use the configurable embedded servlet container to specify the behavior we would like to see from that container. So I'm just going to call this configurable, and within the body of our method, we can explore all the methods that we can invoke on our embedded servlet container in order to provide its configuration. So these should look familiar. A lot of these are the properties that are available to us within the application.properties file. So let's just go ahead and we will set a simple property such as the context path. And I'm just going to set the context path to be app2. And now we can launch our application. And if we navigate to our web browser, we can once again visit our time leaf endpoint, and we now will not be able to access that endpoint unless we specify the app2 context route. So there we were able to programmatically modify the behavior of our embedded servlet container and provide that configuration through Java code. Now I'm going to go ahead and deregister this bean, and then I'm going to switch the bean over to a configuration bean. This will allow us to implement our next approach, which directly defines the embedded servlet container factory bean. So I'm going to go ahead and remove this interface, and we can take away our method here that we have implemented, and I'll clean up our imports. And now we're going to declare a new bean, and this bean has to be accompanied by a method declaration. So this method is going to return a bean of type embedded servlet container factory. And I'm just going to call this factory for the method name. And now within this method implementation, we will construct our servlet container factory bean. So the first thing we'll do is declare a variable of type Tomcat embedded servlet container factory, and we'll just name this variable factory, and then we can use the new operator along with the Tomcat embedded servlet container factory constructor. So we're using some very verbose class names here, but that's a good thing. And then using this factory, we can set a bunch of different configurations for our embedded servlet container. So we'll go ahead and just set the context path again. And this time I'm going to set it to app3 just to distinguish from our last configuration. And then we return the factory from our bean method, and that's going to register this bean within the IOC container. And when SpringBoot builds out our embedded servlet container, it's going to use this factory to create that embedded Tomcat container. So normally this would occur behind the scenes, but here we get a little bit more control where we are directly configuring and providing the embedded servlet container factory bean. And you see this a lot within SpringBoot. If there is something you'd like to override, you can declare a particular bean within your configuration, and it will override the defaults provided by SpringBoot. So let's go ahead and we'll relaunch our application. And now we're going to navigate back to our browser, and we'll try to hit app2, and that should be unsuccessful. But now, if we switch our context route to app3, we successfully invoke our REST controller method, and we are served with our template. So in this lesson, we saw two approaches to programmatically configuring our embedded containers. And one is by directly declaring the embedded servlet container factory bean, while the other uses the embedded servlet container customizer interface. In this chapter, we'll explore SpringBoot's integration with Spring Security to see how we can construct secure applications. Application security is often application-specific. Therefore, the security features provided by SpringBoot are somewhat limited. However, if you are looking to quickly stand up a prototype, SpringBoot provides a great starting point. Let's talk about what we'll cover in this chapter. We'll start out by taking a look at the auto configuration for Spring Security that is provided by SpringBoot. By default, all of our application endpoints will be protected by HTTP basic authentication. You'll see that you can quickly establish a secure application. However, it's going to be somewhat limited because the default configuration is pretty minimal and would not apply to a production use case. But it does provide a good starting point for building out the security within your application. We'll also take a look at how we can subscribe to different security events using an application listener, and this is another default configuration provided for Spring Security right out of the box with SpringBoot. Now, once we've seen the features provided by auto configuration, we'll then take a look at how we can customize those features in order to start building out our more specific security needs for our system. Finally, we'll dabble a little bit into the area of OAuth and see how we can use the GitHub API to require authentication for our application. We can achieve this by using the Oauth integration within SpringBoot, and you'll see how easy it is to get up and running with a simple application that integrates with Oauth. In this lesson, we'll focus on how SpringBoot integrates with Spring Security. We'll focus on a number of the features provided by SpringBoot's auto configuration that help us establish Spring Security within our projects. In order to integrate Spring Security into our SpringBoot project, we're going to build out a new Spring Starter project. I'm going to name this project SpringBoot-Security, and I will make sure the artifact ID is Spring-Boot-Security. I'll hit Next, and then within our dependencies, I want to make sure the Web checkbox is checked, as well as the Security checkbox. Once we have specified these dependencies, we can go ahead and hit Finish, and our project will be built. Once our project is available within the Package Explorer, we're going to navigate to the Source Main Resources directory, and we'll use the New dialog to create a new HTML file, and I'm going to name this file index.html. Within this file, I'm just going to specify within a span tag that this page is protected by Spring Security. I'll go ahead and save that file, and now within that static directory, I'm also going to build out a new folder, and I'm going to name this folder CSS. And then inside that CSS directory, I'll create a new CSS file, and let's just call this page.css, and I'll hit Finish. And inside this CSS file, I'll just make a new role named Message, so it's using a class selector, and we'll say the color's red. And now we can go back to our index.html file, and we'll add the message class to our span, and then within our head tag, we can create a link, and we'll specify that it's going to be a style sheet, and then we can specify that we're going to be connecting to the style sheet within the CSS directory, and its name will be page.css. So we have our content available, and now we're just going to go ahead and launch this Spring Boot application. Once all of our libraries have been downloaded, we're going to take a look at the console, and the first thing I'd like to show you is that you'll notice we see some security mechanisms being put in place. So here we see a security filter chain, and you also notice that this default security password has been included pretty prominently within our logs. So if we go ahead and copy that password, what we're going to see is if we navigate to localhost on port 8080, we'll get prompted to enter a username and password, and this is basic authentication. And this was configured by default just by using SpringBoot with Spring Security. So there is actually a starter POM within our pom.xml file that corresponds with Spring Security. And because SpringBoot has detected that library on its class path, it went ahead and configured HTTP basic authentication for us. So for the username field, by default, the default user is user, and then we take that password from our log and we use it to log in. And once we've logged in, you'll see that our page is now displayed to us. Now, one thing you should notice is that our CSS file made it through without being scrutinized by the security filter. So in this case, the CSS directory is ignored, and there are several common paths that Spring Security will ignore by default with its configuration in Spring Boot. And that's the CSS directory, a JS directory, as well as an images directory. So all those will not require authentication, but here hitting our context root did, because the index.html resource is protected. So let's navigate back and let's take a look at our POM file, and we can see that we have a dependency on the Spring Boot Starter Security Starter POM. And that's how Spring Security wound up on our class path, and that triggered a bunch of auto configuration by Spring Boot. One of the default beans that is created is an authentication manager. And this authentication manager uses an in-memory store that has a single user. And we saw that with the password we are provided and our user. Now, if we would like to customize that, we can use the Application.Properties file to change our username and password to something we customize. So using the security property, I'm going to set the username property to Kevin, and then I can go in and use security.user.password, and I'll just set that to password. And now if I restart the application and navigate back to our browser, I can hit localhost 8080, and I'll be prompted for a username and password, and then I can put in Kevin and use the password, and it once again allows me into the application. So that's one way we can customize the in-memory credentials used by the default authentication manager registered by Spring Boot's auto configuration. So in this lesson, we created a Spring Boot project that integrates with Spring Security and takes advantage of some of its default configurations to provide HTTP basic authentication for one of our web resources. Another Spring Security feature that Spring Boot automatically registers is an Application Event Publisher. The Application Event Publisher publishes security events that can be received by an application listener. In this lesson, we'll establish a custom application listener to subscribe to events published by Spring Security. Spring Security publishes several events to indicate when key authentication activities occur. In our case, we're going to subscribe to an abstract authentication failure event so that we're notified when authentication fails. So we'll start out by adding a new class to our project within the com.o'reilly.boot package. I'm going to name this new class Custom Security Event Listener. And we need to make sure that this new class implements the Application Listener interface. So we'll go ahead and add that interface and then hit Finish. And now we need to build out our class. The first thing that we need to do is provide a generic type for the application listener. And the generic type will specify the event that we want to listen for. So we're going to listen for the abstract authentication failure event. So there you see a list of some of the events and some of the other classes, but there you see an abstract authentication event. There's also an abstract authentication failure event. And that's the event that our listener will listen for. And that event will be triggered when a user fails to authenticate with our system. You'll notice that we get the little error mark, and that's because we haven't implemented the required methods for the interface. So just click on the error and then click Add Unimplemented Methods. And this is going to add the appropriate method that we must implement to our class body. So I'll go ahead and change our argument's name, which you can see is of type abstract authentication failure event. I'll change the name of that argument to event, and then we're simply going to print out the message from that event within the body of our onApplication event method. So on the event object, I'm going to invoke the getException method, and that's going to return a type of authentication exception. And then on that object, I'm going to invoke the getMessage method. Now, the final thing we need to do is we need to declare this event listener or this application listener as a bean. So I'm going to go ahead and add the component annotation to our class, and that will cause our class to be picked up by Spring's component scanning and registered within our IOC container. So with these changes in place, we're ready to run our demonstration. So let's navigate to the Package Explorer, and then we're going to run our application as a SpringBoot app. And we can watch the console to see our application fire up. And now we'll head over to the browser, and we'll navigate to localhost 8080, and we'll be prompted for basic authentication. And let's enter some wrong information. So wrong user, and I'll put in wrong password, and we'll go ahead and try to log in. So you'll notice we're re-prompted to authenticate because we failed. And here you see within our console output that we printed bad credentials to the console. And that's because we have configured our application listener, which is subscribed to the abstract authentication failure event. And this is a feature provided to us by SpringBoot's auto configuration of Spring Security. For all but trivial applications, SpringBoot's auto configuration of Spring Security will not suffice. For example, it wouldn't be feasible to have our users' login credentials randomly generated and placed within our log file. Ultimately, developers will need to manually configure Spring Security within their SpringBoot applications. Within this lesson, we'll take a look at how to turn off SpringBoot auto configuration and switch over to a custom security configuration that meets the needs of your application. To get started, the first thing we'll do is extend the Web Security Configurer Adapter class. So we'll go to our SpringBoot Security Application type, and we'll specify that it extends the Web Security Configurer Adapter class. This class acts as a convenient base class for creating a web security configurer. An instance of Web Security Configurer can be used to customize the web security provided by Spring Security. It provides us with a convenient method to specify how Spring Security should behave for our application. If we navigate to the body of our class and we right-click within the body, we can then go to the source option, and we have the option to override or implement methods. And this allows us to pick methods that are on the Web Security Configurer Adapter type and override them for our needs. In our case, we're going to override the configure method that accepts a parameter of type HTTP security. So go ahead and check that checkbox and then hit OK. And at that point, the method will be added to our class. Within the body of our configure method, we can use the HTTP security object to configure how our security will impact HTTP requests. So for example, on the HTTP object, we can specify that all requests must be authorized by invoking the authorize requests and then invoking the any request method. And then we specify that we would like them to be authenticated, and we can say with what type. So we say and then we can say HTTP basic. And that's currently what we have in place. So you'll remember that we have some customized credentials of Kevin and password. So we can now run a demonstration and use those credentials to log into our application. Before we do that, there's one last piece of configuration we need to add, and that's the Enable Web Security annotation on our Spring Boot security application type. So we'll go ahead and add the annotation and import it, and then we're going to navigate to the Package Explorer. We'll right-click on our project and go to Run As, and then Spring Boot Application. Our application will build, and then we can eventually navigate to our browser and hit localhost on 8080, and we're then prompted to authenticate. So I'll supply our credentials, and there you can see that we have now logged into our application. And the application has been configured manually using the Web Security Configure adapter class, as well as the Enable Web Security annotation. And that allows us to override some of Spring Boot's auto configuration. At the moment, we're just replicating what the auto configuration put in place, but we can do something different like a form login. So this is going to change how we authenticate with the application. So let's just go ahead and we'll relaunch the app. And now if we head back to our browser, we can hit localhost on port 8080. And now when we are prompted to authenticate, we get this nice web-based form. So I can go ahead and specify my credentials and then log in. So we're able to customize our app. And in order to do that, we need to use this nice Enable Web Security annotation. And then we start to build out our configuration as we normally would with Spring Security. There's really nothing different from a traditional Spring Security setup at this point. So you would want to consult the Spring Security reference documents in order to specify your application's configuration. So this wraps up our lesson on customizing Spring Security configuration within a Spring Boot project. In this lesson, we'll take a look at the support for Oauth provided by Spring Boot. If we include Oauth on our class path, Spring Boot provides some auto configuration that facilitates single sign-on or SSO. Let's get started by opening our pom.xml file and including Oauth support within our Spring Boot project. So if we navigate to the Dependencies tab, we can click on the Add button to add a dependency, and we're going to enter the group ID of org.springframework.security. And if we look within this group, we're going to see the Spring Security-OAuth2 artifact. And we want to go ahead and include that in our project, so we're going to hit OK. We'll then save our pom.xml file and close the file because we are done working with it. Within our project, you'll notice the Application.YML file. This file contains the properties that we need in order to connect to the GitHub API. The configuration is provided in YAML because it is much more concise. It is a lot easier to nest our properties instead of explicitly declaring them on each line. Let's talk a little bit about how each of these properties will be used. So the first thing you'll see is the configuration of our client. The application we're going to build is going to act as a client application, and in order to work with the GitHub API, it needs to have a client ID and a client secret. Now these are normally registered on the GitHub API site, so you register your app and you get these client credentials. Now, the credentials we're using are available publicly through one of the Spring tutorials, so we're just using those so we all have a common set of credentials. Now, when we need to access a particular resource, and in our case, we need to access a user's profile, we take our client ID and our client secret, and we go to the access token URI. So we hit this URL, and we say, hey, we would like to access this resource for this particular user, and this is who we are. Well, the access token URI will provide us with an access token. And it says here, take this unique identifier for you and your request, go back, give it to the owner of the resource that you are requesting, and have them come back to us. So we take our access token, we hand it off to the client, and then we ship them back to the user authorization URI with the access token. They present that token, which represents our request, to GitHub. So now GitHub knows, okay, that request that was just made a second ago, now the resource owner is coming back with the access token, and they are then able to say, yes, give them access, meaning our client application, give them access to this resource they have requested, or they can say do not. And in our case, the resource we're going to be requesting is actually the user profile, and we'll see that information returned from the GitHub API. But we'll be doing our authentication using the GitHub API, so we will be having the user log in to our application and having them authorize and authenticate with GitHub's credentials for that user. Now that we understand the properties within our Application.YML file, let's head over to the SpringBoot Security Application class, and we will add the finishing touches for our demonstration. The first thing we'll do here is change some of the annotations on our class. We're going to remove the Enable Web Security annotation, and we'll replace it with the Enable OAuth to SSO annotation. And this is going to enable single sign-on with OAuth. We'll also need to convert our class over to a REST controller, and that's going to allow us to serve different representations of particular resources. And one of the things that we'll do is we'll provide the principal, which is going to be an object representing our user. So we're going to get a bunch of information back from GitHub, and we're going to place it within a principal, and then we can return that via our REST API. So I'm going to construct a method that is able to return that principal object, and because we are working with a REST controller, it's going to be returned via a JSON representation of that object. And in order to do that, we need to establish a request mapping where a application user can request this particular resource. So we're just going to map this controller method to the /user path. Now we're going to remove the need to log in with a form because we're going to be using GitHub in order to authenticate our users, so there's no need for that form. But we will still require that every endpoint of our application or every path that a user would hit is protected by having our authentication in place. Essentially, every request coming into our application will require authentication. So let's run our demonstration by navigating to the Package Explorer, and then we can select Run As and a Spring Boot app. And this will go ahead and launch our application, and we can navigate over to a browser and start hitting a particular URL within our app. And I'll just go straight to the /user path. And you'll notice when I do that, I'm asked to provide my GitHub credentials. So hopefully I remember them correctly. And then my password. Okay. And now it asks me to authorize the example application to access my public data. And I can say, okay, go ahead and do that. And now the request returns, and you see a bunch of information about my account. This was all made possible by using Spring Boot's integration with Spring Security for OAuth. And it was very simple. You notice we don't need to be an OAuth wizard to put this in place. We added one simple annotation and then provided some properties for our application to define the client ID, the client secret, the URLs that we wanted to go against for access tokens, and Spring Boot and Spring Security did the rest of the work. It's quite amazing how much was done for us behind the scenes. So this wraps up our lesson on using Spring Boot with Spring Security in order to achieve OAuth authentication. In this chapter, we'll explore how Spring Boot can be used to facilitate simple data access and persistence to a SQL database. Throughout the lessons, we'll see various usage scenarios for a SQL database and demonstrate how Spring Boot supports them. Let's take a closer look at this chapter. We'll start out by establishing connectivity to an H2 in-memory database. In-memory databases are an excellent way to get up and running quickly for initial development and prototypes. We will also leverage a handy console exposed by H2 with the help of Spring Boot. This console will allow us to peek inside the in-memory data store to facilitate testing during our development. While working with the H2 data store, we'll use a JDBC Template bean to conduct CRUD operations. This bean will automatically be provided by Spring Boot. Moving away from H2, we'll switch over to working with a persistent database named MySQL. Persistent data stores are necessary for production environments because it's not feasible to simply throw away our data like we do within an in-memory data store. Our MySQL database will provide us with an excellent opportunity to explore some of the configurations within Spring Boot and how they can support our connection to a SQL database. We'll see some custom configuration settings that allow us to test our connections as they're pulled from a connection pool. Finally, we'll take a look at how we can use JNDI to build a data source and access it from a standalone application server. Before we start work in our chapter, I'd like to go over the connection details for the MySQL data store. So we'll be using a MySQL data store at some point, so you'll need to install MySQL and establish a schema within the database. Throughout the lessons, I'll be using the schema of test_schema. I'll be using the username test_user and the password of password. So if you would like your work to exactly match the lessons, you can establish your database with these connection details. Okay, let's get started on our chapter. In this lesson, we'll see how easy it is to begin working with a SQL database using Spring Boot. Spring Boot can jumpstart the process of working with a SQL database by providing auto-configuration of some commonly used beans. In order to get started, we'll need to build out a new Spring Boot project. So I'm going to go to File and then Spring Starter Project, and we're going to name this new project Spring Boot JDBC, and I'll change our artifact ID to Spring Boot JDBC, and then we'll hit Next, and now we can begin to add our dependencies. So we're going to make this a web application. We're also going to make this a JDBC application, and we're going to use H2. Now, H2 is an embedded database. It is strictly in memory, so you're not going to have persistent storage. Your data is not going to persist from one run to another. Each time you start your application, you will start with new data and you will throw it away once you are finished. This is a good database to use for prototyping and development purposes. Once we have included H2, we'll go ahead and hit Finish, and the Spring Starter project will be constructed. The first thing we'll do is we'll head to the pom.xml file, and here we can take a look at the various dependencies that were included for us. We notice that the H2 artifact has been added, as well as the Spring Boot Starter JDBC starter POM. these will put the required dependencies on our class path when we begin working with our application. When working with an in-memory data store, it's pretty common to execute some SQL scripts before every run of our application. Luckily for us, Spring Boot makes this pretty easy. All we need to do is add the appropriate SQL files within the root of our class path. And when we do that, we have two options. We can name the file schema.sql or data.sql. We're going to go ahead and build a new file within our source main resources directory, and we're going to name this file schema.sql in order to comply with the default SQL file name for Spring Boot. So we'll go ahead and build this file, and it will be executed every time we run our application. So what we'd like to have happen is we're going to create a table, and this table is going to be named stock. Now, within the stock table, we're going to have a few columns. The first will be a stock ID of type int. The next will be the company name, and that's going to be a varchar 2, and we'll specify the size as 50. We're also going to have the symbol of the stock, which will also use a varchar 2, and we're only going to allocate 10 characters for the symbol. And then we're going to have a price, which is going to be a decimal with a scale of 2 and a precision of 10. Now, with that table created, we need to insert some records. So I'm going to insert into the stock table. The first stock will be VMware, and then we're going to put their symbol, which is VMW. And then we need to assign a price to that stock, and we'll say it's $56.05. And then what we'll do is we'll go ahead and build out two more stocks. One will be AT&T, for those of you who like dividends, and the symbol is T, and we'll say it's 38.74. And then our next stock that will include is Facebook. And we'll say Facebook is roughly $118.25. So we've gone ahead and constructed our schema.sql file, and this file will be run against our database each time we start up our application. So our H2 database will now include this table and these three records. At this point, we can navigate to our application class that was created for us, and we can begin to work with the JDBC template that will be available to us because of the auto configuration provided by Spring Boot. Because we have the JDBC starter POM as an artifact within our POM.xml file, we can auto-wire a JDBC template. So I'm going to create a field of type JDBC template, and I'm going to name this field template, and then I'll import the auto-wired annotation and the JDBC template type. The template is made available to us by the auto configuration provided by Spring Boot. Now, if you know anything about a JDBC template, you know that it requires a data source. Well, the data source bean was automatically created for us because we are using an embedded data source as well as Spring Boot auto configuration. That data source is then provided to the JDBC template, which is a bean that we can use to assist different JDBC operations such as inserts, updates, and different queries. Basically, the JDBC template helps us execute core JDBC functions, and it provides a nice common interface that allows us to standardize how we interact with our data store. And all of these beans are provided to us automatically by Spring Boot auto configuration for JDBC. So with our JDBC template auto-wired, let's go ahead and turn our application into a REST application by using the REST controller annotation on our class. And now we're going to build out a request mapping and it's going to be for the stocks path. And for the associated method, we're going to return a list that returns a generic type of a map that has a generic type of string and object, and we'll call this method stocks. And then we're going to provide an implementation for this method within its body, and we'll simply use our template to query for a list of stocks. So query for list, and then we provide our query, which is going to be select star from stock. And at this point, we can return that list, and it should be turned into a JSON representation of that list of stock objects. So let's go ahead and we can save our class file. Now we can navigate to our Project Explorer, and we can run our application as a Spring Boot app. And this is going to allow us to use our JDBC template to access our in-memory data store. So I'm going to head over to our browser, and we will access localhost 8080, and then our path was stocks. And there we see we get a JSON representation of the list of stocks. And that was all made possible by the JDBC template and the data store that was auto-configured for us and made available by Spring Boot. In this lesson, we'll see how Spring Boot makes available the console for our H2 in-memory database. Within the H2 database, a browser-based console can be accessed to explore the database structure and execute queries while testing an application. By setting a few simple properties within Spring Boot, we can expose this console for our use. To get started, we will navigate to the Application.Properties file. Within this file, we can use IntelliSense to set some properties related to our H2 embedded database. So here you'll see within the spring.h2.console node, we have the option to enable the H2 console and also to set its path. For now, let's just go ahead and set the enabled property to true, and then we're going to navigate to the Package Explorer, and we can run our application as a Spring Boot app. Next, we'll navigate to our browser, and we're going to hit the localhost 8080 URL, and we're going to use the path h2-console. And as you'll see, once we navigate to this URL, we are then presented with the web-based console for our H2 database. Now, you can just go ahead and hit connect because by default, we do not need to supply a password. Once inside of the console, we're able to execute all sorts of queries against our embedded H2 database. Now, if we would like to change the URL where this console is exposed, we can set that via a property within our application.properties file. And you probably guessed that is the path property. So let's just set our path to /H2. We'll make it a little bit simpler. We'll relaunch our application. And now when we navigate to localhost on port 8080, we can simply go to the H2 path. And here you'll see that we can access our console via the custom path that we've specified within the properties file. Now, while we're here, I would like you to grab the JDBC URL. So that's the connection string for accessing this database. And one thing I'd like you to notice is if we connect, we do not see the stock table that we have defined within our project. So we have the schema.sql file, and within it, we define a stock table. But when we take a look at our database, we do not see that table. So if I execute select star from stock, I'm going to get an error because it cannot find the table. That's because we're not working with the same H2 instance when we execute our script. In order to remedy that, we can specify the URL to our data source. So using the spring.datasource.url property, we can then specify the connection string to our database. And now when we relaunch our application, we can go back and navigate to localhost on port 8080, and we hit our H2 console. And now when we log in, we see our stock table, and I can run a query against that stock table. And it helps if you include the from keyword. So this is very helpful when you are working to develop out your application because you can run queries pretty easily against the in-memory data store. This can be valuable for debugging or validating that your code is executing properly. While we're working within our application.properties file, let's take a moment to inspect some of the properties available to us that allow us to specify the behavior of our data source. So if we look within the spring.datasource node, you're going to see quite a few properties that allow us to configure how our data source will behave. So for example, here we can set some idle times. We can also set some timeouts. We can set the size of the poll if we're using connection polling. There you can see we can set the password. There's all sorts of great properties in here that allow us to configure our data source. Let's just take a quick look at the schema property. So the schema property allows us to point at a script file that will be executed when our data source bean is created and we're starting up our actual data source. So in our case, we're going to look for a file named load.sql on the class path. This file will be similar to our schema.sql file. In fact, we're just going to head to the Package Explorer and we will rename the schema.sql file to be load.sql. And now we're going to first head into our H2 console and we'll drop our stock table. Let's make sure that table dropped. That way we don't have any conflicts. Okay, so there we see we dropped our stock table. And now we're just going to re-execute our application. And if we look at our console, we should be able to see the load.sql file being consulted. And there it is. So we can see the scripts are being executed from load.sql. And then if we navigate to the H2 database and log in, we do in fact see that our stock table was once again built, this time from our load.sql file, which was specified as our schema properties value within the application.properties file. And that instructed SpringBoot to run the load.sql script when our data source bean was created. So this concludes our look at the H2 console and how we can use SpringBoot to expose that console for our development purposes. In-memory data stores are an excellent resource for development. However, they just don't cut it as a production database. It's just not practical to lose data every time we restart an application. Production environments require us to use persistent databases so that data can be stored more permanently. In this lesson, we'll take a look at how to configure a SpringBoot project to interact with a persistent MySQL database. To get started, we need to navigate to our pom.xml file. Within the pom.xml file, we are going to remove the H2 artifact because we will no longer be using an in-memory data store. So we just select the artifact and then hit remove. Now we're going to add the JDBC connector for a MySQL database. You'll notice the MySQL connector-java artifact ID, and you'll see that its version is managed, and that's thanks to one of our starter POMs. So we can pull that artifact into our pom.xml file And then we will have the appropriate JDBC driver to talk to our MySQL database, which is running as a service in the background. The MySQL database has a schema established named test_schema. This schema contains our stock table and a user named test_user. We're going to use these credentials within our SpringBoot configuration to establish a data source that will connect to our MySQL database. Now, before we get started on that configuration, let's take a look at our dependency hierarchy. Here you see the Spring Starter dependency for JDBC. Within that dependency, you'll notice the Tomcat-JDBC artifact, which is a transitive dependency of our Spring Boot Starter JDBC starter dependency. So the Tomcat-JDBC dependency is going to contain our connection pull. And with it on the class path, Spring Boot will automatically choose the Tomcat connection pull and configure it for us. Let's head over to the Application.Properties file and establish some of this configuration. So the first thing we'll do is remove the two H2 specific properties. Then we're going to turn our attention to the spring.datasource.url property. You'll notice that this property is still configured to use the H2 connection string. We need to switch that over to use the MySQL connection string. So we specify the protocol, followed by a colon, 2 forward slashes, our server name, and then we need to provide the name of our schema. In my case, that is test_schema. Your schema name may vary depending upon your underlying MySQL database. Once we've provided our connection string, we now need to provide the credentials to connect to the database. So we use the spring.datasource.username property to specify the name of the user we would like to connect to the database. In my case, that user is test_user, and each username is accompanied by a password, and the password for my user is password. Now, with the credentials in place, we need to specify our JDBC driver. And to do that, we specify the driver class name property. To set this property, we use the fully qualified name of our JDBC driver. When we're using MySQL, that is com.mysql.jdbc.driver. With this configuration in place, I'm going to go ahead and save my application.properties file, and then I'm going to navigate to the Package Explorer. I'll right-click on our project and then go to Run as Spring Boot Application. This will start up our application, and we can navigate to a browser, and we can hit the localhost 8080 stocks URL, and you'll see that we are then able to access our MySQL database. Let's return back to STS, and we will add some additional configuration to our application.properties file. When working with a connection pull, it's pretty common to test the validity of the connection that is pulled from the actual pull. We want to make sure that the connection is not stale or corrupt before we use it. Luckily for us, Spring Boot provides some external configurations that we can use to determine the behavior of our connection pull. So if we set the spring.datasource.testOnBorrow property to true, this will test out the connections coming from the pull, and we can also specify a simple query to run when we are pulling out a connection. We can specify which query we would like to use to test the connection. In our case, we're going to use a very simple ping because there's not a lot of overhead with that connection. So let's go ahead and we can relaunch our Spring Boot application, and we'll just navigate back to the browser, and we'll make sure that our connection to the database is still functioning. So I'm just going to head over to Google, and then we can navigate back, and we see that our connection is still functional. So in this lesson, we learned how to connect to a persistent database, which would be necessary for running SpringBoot along with JDBC connectivity in a production environment. We learned how to establish the appropriate properties to perform a basic connection to that persistent data store, and we also saw the dependencies necessary to connect to MySQL. In this lesson, we'll learn how SpringBoot can be used to configure and manage a data source with JNDI. In order to use JNDI for our data source, we'll need to run our application from an external container instead of from an embedded servlet container. To run our application from an external container, we'll need to make some changes to the POM.xml file. The first thing that will change within this file is our packaging. We're going to switch our packaging from a jar to a war. The next thing that we'll need to do is we'll need to specify that our dependency upon the Spring Boot starter Tomcat artifact is provided at runtime. So we're going to add a dependency declaration, and it's going to be for org.springframework.boot, and then we need to specify the artifact ID, and the artifact ID is going to be spring-boot-starter-tomcat, and then we just need to provide that its scope is actually provided. So with those two changes to our pom.xml file, we're on our way to running on our standalone server. So I'm going to go ahead and close the pom.xml file, and now we're going to make some changes to our Spring Boot JDBC application class. What we'll do is we'll have this class extend the Spring Boot servlet initializer, and this will allow us to override one of the methods within that class that will allow us to run as a standalone application. So we're going to right-click within our class file, go to source, and then override and implement methods. And then we're going to pick the configure method that we would like to override. You'll see that the configure method is passed a Spring Application Builder argument, and we're going to work with that argument to start up our application. So what we're going to do is here in our return statement, we're going to use our builder, and we're going to specify the sources, and then we're just going to specify the Spring Boot JDBC application.class, and that will tell our application what to start up when Spring Boot initializes our servlets. That completes our configuration within the Spring Boot JDBC application class. Now, since we have modified some of our Maven configuration, we need to navigate to the Package Explorer, right-click on our project, and then go to Maven and click on Update Project. Simply hit OK when the Update Maven project dialog is presented to you, and this will begin to update our project's configuration and pull in the necessary dependencies. At this point, we are almost ready to run our application. So if you right-click on the project and go to Run As and Run on Server, you'll notice that you're presented with an error that we are using a Cloud Foundry facet. So we need to remove that facet. So simply hold Alt and press Enter to open the project properties. And within our project properties, we're going to navigate to the Project Facets tab, and we're going to uncheck the Cloud Foundry Standalone Application checkbox, and then hit OK. Now, if we right-click on our project and go to Run As and then Run on Server, we can get the Run on Server dialog, hit Finish, and we will see our application start on our Pivotal TC server. Once our server is started up, we can navigate to a browser, and if we go to localhost 8080, and then we need to go to spring-boot-jdbc, because that's now our context root, we can then hit the stocks URL, and there we see we get the JSON representation of our stocks as we expected. Now, this has been provided by our Pivotal TC server instead of launching our Spring Boot project with an embedded servlet container. So just a slight difference there, but what this allows us to do is now establish a JNDI resource within our server that we can reference with Spring Boot. We're going to take a break before we move ahead with that part of the lesson. In the first part of this lesson, we configured our Spring Boot project to run on an external container. This was necessary so that we can establish a JNDI data source within the container that will be used by our Spring Boot project. To continue, we are going to shut down our standalone server and modify its configuration. To shut down the server, click on the Stop icon within the Servers tab, and you'll see that our server will begin to shut down. Next, double-click on the server to bring up its Configuration tab. On the Configuration tab, we'll click on the Open Launch Configuration link, and then we'll click on the Class Path tab. And what we need to do is we need to add the MySQL JDBC driver to the class path of our server. This will allow the server to create the data source that will be made available through JNDI. So if you click on User Entries, you can then hit Add External Jars. Now what I have done ahead of time is I have placed the MySQL connector Java 5.1.35 jar on my desktop. You can find this JDBC driver out on the MySQL website. You just simply download it and place it somewhere on your file system. And then you can add it onto the class path for the server. So go ahead and hit Apply and then OK. At this point, we can close the Server Configuration tab, and now we are going to minimize our editor, and we're going to start working to configure the data source within our configuration files for the server. We'll crack open the context.xml file and navigate to the Source tab. Within this file, we will configure a new resource that will be made available to our application. So the first thing we need to do is provide it with a name, and we're going to name it JDBC/test. Then we'll specify that this resource can only be accessed by the container. Now we need to specify the type of our resource, and it's going to be a javax.sql data source. So here you can see we're building out a data source that will be referenced using JNDI. Now we need to provide some configuration for that connection pool for the data source. So we're going to allow 100 active connections. We're going to say there can be 30 idle connections, and the max amount we can have waiting we'll set to 10,000. Next, we need to specify the credentials for connecting to our data source, and we're going to be hitting our MySQL data source, which is running in the background. So I'll use the test_user username, and then for the password, I'm going to specify the credential of password. Then we need to specify our driver class name, and this is the fully qualified name of the JDBC driver that we'll be using. In our case, we're using MySQL, which is running in the background, and we are going to be using its driver class. Finally, we specify the connection string for MySQL, and you'll specify the protocol, followed by a colon, then 2 forward slashes, your server, followed by the port, and then the schema name. So you want to be very careful when specifying this resource because a typo here can cost you hours. So just take an extra moment right now to make sure you have the proper connection information for your MySQL database. So with our JNDI resource established, we're going to navigate to the Application.Properties file to finish our configuration of Spring Boot. Within this file, we'll remove all of the connection details to our current data source, and then we're going to replace those with the spring.datasource.jndi name property. And here we need to specify the name of our JNDI connection. And you'll remember it is /JDBC/test. Now, every time we use JNDI, we need to start from the appropriate node on the JNDI tree. And it's a little bit complicated, so Java :comp/env, and then we can specify our actual JDBC name that we established as a resource. So we then put our JDBC test there. With that in place, let's go ahead and we can restart our server. You notice the embedded server starts a lot faster than the standalone. So it looks like it's started. Let's head over to our browser, and I'll just navigate to Google first, and then head back to our stocks endpoint. And you do see that we are able to get our stocks represented as JSON. And the connection that our application made to the MySQL database was established through a JNDI data source that was provided by our standalone container. And when working with Spring Boot, all we needed to do was specify the JNDI name property, and as long as everything was appropriately established within our container, we easily get our data source. In my opinion, Spring Data is one of the best Spring projects available to developers. It makes persisting data to an underlying data store trivial. The only slight problem with the project was the amount of configuration necessary to get it established. With the invention of Spring Boot, those headaches are now erased, and creating a Spring Data project has never been easier. Let's take a closer look at our chapter. We'll start out by using Spring Boot's starter POMs to quickly establish a Spring Data JPA project. Within this project, we'll use an entity manager to persist our entities. We'll then advance into working with Spring Data Repositories, which are a much more efficient way to persist our entities to an underlying data store. You'll see how Spring Boot auto-scans and looks for our entities and repositories within our project and creates them as beans within the Spring IOC container. We'll then move on to take a look at how we can configure our persistence provider to automatically build in changes to our underlying data model. Changes to our entities will quickly be reflected within our database, allowing us to develop freely and explore new options and new approaches during our development efforts. Finally, we'll take a look at how we can configure Spring Data JPA to connect to a persistent database. We'll be working with a MySQL database, and we'll see how we can configure our project using Spring Boot very quickly to establish that connection. Now, with the MySQL data store we'll be working with, these are the default details for that connection. So if you'd like to follow along verbatim, these are the credentials that we'll be using. So that's an overview of our chapter. Let's now get started with our lessons. In this lesson, we'll get started using Spring Boot's integration with Spring Data. If you have used Spring Data in the past, you know how much of a breeze it is to make data persistence happen within our applications using the framework. However, you will also know that the configuration of the different persistence approaches, such as JPA, is a little bit tricky. Luckily for us, Spring Boot has removed much of that complexity. Let's dive into some code. The first thing we'll do is create a new Spring Starter project, and we're going to name this project Spring-Boot-Data. You'll also want to make sure that the artifact ID matches that name. Go ahead and hit Next, and now we choose our dependencies. We're going to have dependencies on the web dependency, the H2 dependency for our embedded database, and then we're going to add the JPA dependency. Now, if you are familiar with JPA, it's the Java Persistence Architecture, and it provides us with a specification for object relational mapping. We'll wind up with a Hibernate library on our class path, which will act as our ORM. So STS will go ahead and build out our project, and then the first thing we need to do in this project is add our database. So we're just going to create a new file under source main resources, and we're going to name the file schema.sql because that is one of the defaults that Spring Boot will recognize. And then within this file, we are going to establish the tables within our database as well as any records we would like to insert within that table. Now, I'm going to use our table and records from past lessons, so you'll recall the stock table and our 3 stocks we enter into that table. So with that established, we have the appropriate database structure in place. And now we're going to create a new entity. So an entity is a representation of one of our domain objects. Normally, it's closely related to the tables within our database. So we're going to create a new class, and we're going to name this class stock. So we'll go ahead and hit finish, and our stock class will be created. Now we need to build out our stock entity. So the first thing we do with any entity is we add the entity annotation. Be sure to choose the javax.persistence.entity type. And then we start adding the fields for the entity. So in our case, we have a stock ID. We also have a string company name. We have a string for the symbol. And you notice these all relate to the columns within our tables. Now, with JPA, you'll always have to declare your ID field, and that is going to be stock ID for us. So once these fields are in place, I'm going to generate the accessors. So you can just right-click, go to Source, and then Generate Getters and Setters, select all, and then hit OK. And that will build out all of the accessor methods within our stock class. Now we have a little bit of work to do within our Spring Boot application. The first thing I'm going to do is turn this class into a REST controller. So we'll import the REST controller annotation, and that allows us to add the request mapping. The request mapping is going to be to a path named stocks. And then we're going to create a method associated with that mapping that returns a list of stocks. We'll name the method stocks, and we'll import those types. Now, how do we get the stocks? Well, we can auto-wire in an entity manager. So for those of you familiar with JPA, you know that the entity manager performs most of the persistence operations between our ORM and our underlying data store. So we can then take the entity manager, we can create a query, and for that query, I'm just going to select S from stock and then give the alias of S. Be very careful when building out your JPQL or HQL queries. They are case sensitive as opposed to something like SQL, which is a little bit more forgiving. We'll then invoke the getResultList method to obtain the list of stocks. And at this point, we have our application configured to have a stocks endpoint that's going to use a JPA entity manager to return all of our stocks. Now, we just need to do one final thing. We're going to open the application.properties file, and within that file, we're going to set our hibernate.ddl-auto property to none, and we'll talk about that a little bit later. But basically, we have an entity, and we also work within our application to return all those entities with an entity manager. Okay, so we got the code in place. Let's go ahead, run the application. So run as SpringBoot app. We'll let our app fire up, head over to our browser, and start navigating to our URL, which was localhost 8080/stocks. And when we hit the URL, we see that we get our list of stocks back in a JSON representation, exactly what we wanted. So in this lesson, we saw how Spring Boot can help us build a JPA application with Spring data. For those of you that are familiar with configuring a Spring Data JPA application, you're probably asking yourself, where's this component? Where's that component? There's no transaction manager. We didn't even have to build a data source. Spring Boot did that for us automatically. We didn't have to construct our entity manager. You'll notice that we did not need to build a persistence.xml file. Our entities were automatically picked up. By default, Spring Boot will instruct Spring Data to scan underneath our Spring Boot application annotated class for any entities. So it's going to pick up the stock entity just through component scanning, and it will pick up map superclasses as well. So there's a lot of great auto configuration happening for us. Like I said, if you've ever worked with Spring Data JPA, you're probably looking at this and saying, wow, where did everything go? And it's almost a little bit disheartening to know there's going to be a generation of Spring developers that don't know what a transaction manager is. So there's a lot of power and a lot of efficiency forwarded to you as a developer when working with Spring Boot and Spring Data. When working with Spring Data, it's not a good practice just to auto-wire an entity manager and start executing queries. There's a much better way, the repository, which is provided by the Spring Data project. In this lesson, we'll take a look at how Spring Boot supports the use of repositories within Spring Data projects. To get started, the first thing we'll do is build a new repository within our com.o'reilly.boot package. So we'll open up the new dialog, and remember that repositories are interfaces, and we're going to create a stock repository. And we need to make sure that this stock repository interface extends the JPA repository interface. So we'll go ahead, specify the extending interface, and then hit finish. This provides us with a new stock repository interface, and the first thing we need to do is provide the type of the class this repository corresponds with, and then we need to provide the type of the ID. So we'll go ahead and add those two items to our stock repository interface. And now we can build out a repository interface method that will help us locate different stocks. So it's going to correspond with queries that we would like to run. So let's add a query method, which we'll make public, and it will return an object of type stock, and we'll call it find by symbol. And then we'll make sure that this method accepts a string, and we'll name that argument symbol. The other thing we'll need to do is add the repository annotation to our stock repository interface. So with the annotation in place and our query method, we will be able to use the stock repository to find stocks by their symbol. Let's save our stock repository and now navigate to our Spring Boot Data application class. In this method, we're going to modify our controller method to accept a path variable, which we'll name symbol. And then we're going to add that path variable as an argument to our method. So we'll name that argument symbol, and we can then use that parameter within our method to invoke the appropriate method on our repository, which we're going to auto-wire into our controller. So instead of using the entity manager, we're simply going to invoke the find by symbol method on the repository, pass in the string argument of symbol, and we need to change our type returned by this method to only return an individual stock, and we'll change the method name to correspond with that. But here you see we are auto-wiring in our repository and then invoking one of our custom query methods with a parameter that is supplied through the path invoked on our REST controller method. So let's go ahead and launch our application, and then we can navigate to a browser, and we'll navigate to localhost on port 8080, and then stocks, and then /, and then we specify the symbol of the stock we'd like to see. So let's check out AT&T. And there you see that we get the individual stock object back that corresponds with the stock that has the symbol of T, and that's AT&T. So returning, this was all made possible by SpringBoot's support for Spring Data repositories. Once again, you'll notice we did not need to specify any information to our application about where to find our repositories. SpringBoot automatically scanned underneath the package with the class annotated with SpringBoot application, and it found our stock repository and automatically registered it as a bean within our project. And then we're able to auto-wire that bean into one of our controllers, which we can use within controller methods. Very handy, very minimal configuration. Another useful aspect of SpringBoot is that it grants us quick access to the properties that control the behavior of other Spring projects. For example, we can quickly tell the underlying persistence provider how to behave when generating tables. It's often advantageous to be able to generate your data model on the fly. So for example, if we were to add a new column to the stock class or a new field on the stock class, we would like that field to appear as a column within our data model and within our underlying database. So let's add a CEO column where we can specify the name of the CEO, and we'll go ahead and quickly generate the accessors for that column. And now we would like to see that column appear within our underlying data store. Well, the first thing we need to do is get rid of our static schema.sql file because we don't want to update that every time we have a new column. Now we can turn to the application.properties file, and we can work with the spring.jpa.hibernate.ddl-auto property. And here we can provide a number of instructions to our persistence provider Hibernate for how to generate tables once it starts up. So it can look at our entities and understand that it needs to put a particular structure in place in order to support our application. Let's go ahead and use a create drop strategy. This will cause all the tables to be dropped upon startup, and then we will create the tables all over again. This will cause any underlying data to be lost, so this is not a strategy you want to use when working in a production environment. Let's now navigate to our SpringBoot data application.java file, and we're going to add another controller method to help us demonstrate this feature. Within this class, I'm going to copy our existing controller method, and then we'll start to modify our copy. We're going to change the path to /stocks/create. And then what we're going to do is we'll change our method name, remove the path variable, and then within the body of this method, we are going to create a new stock. So I'm going to build out a stock using the new operator in the constructor, and then we'll set some fields. So let's set the CEO that will be me. And then we can set the company name. Let's have it be Coffee Planet. Then we can set our symbol. Hopefully I'm not stealing a symbol here. Let's go with COF. And then we can set our stock ID. I'm just going to set this to 5. It can be anything. And then we need to set our price. We're just a startup, so let's go with $5. And we need to make sure that we use set price instead of get price there. And then we remove our return statement, and we'll just actually return a string, and we'll say created. And here we can use our repository to actually create our stock. So we have a method that is going to create a stock that's going to have a symbol of COF, and then we'll retrieve that stock by its symbol. So let's go ahead and we'll launch our application, and then we're going to navigate over to our browser, and we can hit our stock's create endpoint, and there we see that our stock was created. Now let's go find our new stock. Okay, and our new stock is returned, and you'll notice that the CEO field or column has been returned with our JSON object representation. So we added the field to our entity, and through the auto generation of DDL, that field wound up as a column in our database that we were able to write to using our repository. And this was all made possible by the convenient properties that SpringBoot exposes that allows us to work with Spring Data and our persistence provider. There are several other strategies that you can employ when working with the auto DDL generation features. For example, you can just validate that your schema matches. You can update, so this would update only changes. You can completely turn it off. So you need to be careful when you select this strategy. By default, when working with an embedded data source, the default strategy is going to wipe out all your tables and then rebuild them. So you may need to switch that over to none if you'd like things to stay in place. You definitely want to be very careful in picking your strategy as you work up through your environments, especially moving into something like production. You don't want to have any nightmares by using create drop in production. So in this lesson, we saw how SpringBoot supports auto generation of our DDL for our Spring Data projects. SpringBoot makes switching a Spring Data JPA project from an embedded database to a persistent database very easy. It's just a matter of configuration. In this lesson, we'll see how to establish a connection to a persistent database to leverage with Spring Data JPA using the help of SpringBoot's configuration. So the first thing we need to do is we need to remove our embedded database so that SpringBoot doesn't auto-configure anything for it. So I'll just click on the H2 artifact within our POM.xml file and hit remove. Next, I'm going to add the JDBC driver for MySQL. So I'll just select the MySQL-connector-java. And this JDBC driver will allow us to connect to a MySQL database running in the background as a service on my machine. So I'll go ahead and save the pom.xml file, and now it's just a matter of setting the appropriate properties. So within the application.properties file, the first thing that we're going to set is the spring.datasource.url, and this should look pretty familiar. We're going to use the JDBC MySQL protocol, :2 /, your server name, your port, and then your schema name. In my case, it's going to be test schema. Then we need to start supplying user credentials. My user will be named test_user. Then you need to supply a password, and the password for me is password. And then once again, the driver class name. And we're using using the MySQL driver, so it's com.mysql.jdbc.driver. Now here's the one part that's a little bit different. When working with Hibernate, we need to specify our database platform so that Hibernate knows what dialect of SQL it's working with. So we set the property to org.hibernate.dialect.mysql.dialect. And that's going to vary depending upon your underlying data store. So just take a moment to make sure these configurations are correct. Once we are satisfied with our configuration, we can launch our application and then navigate to a browser. Within the browser, we will navigate to the localhost 8080 stocks, and we're going to first create a stock. And our stock was created, so we can now access it by its symbol, which is COF, and we get the JSON representation for our entity. So this was all achieved by working with the underlying MySQL data store and Spring Data JPA. The configuration of the necessary beans in order to establish that persistence was facilitated by SpringBoot. And here we see the configuration necessary, very much like configuring to connect to any persistent data store. We just need to ensure that we provide the database platform property. In this chapter, we'll be working with MongoDB. MongoDB is a NoSQL data store that stores semi-structured documents, and it's known for its speed. The combination of SpringBoot and Spring Data make working with MongoDB extremely simple for Java developers looking to move into the big data space. Let's see what we'll cover in our lessons. We'll start out by building a simple SpringBoot project that leverages the MongoDB starter POM. This will allow us to quickly establish persistence to a MongoDB data store. We'll take a look at how we can use the MongoDB factory to gain access to some more native components for interacting with the data store. Next, we'll move up in our abstraction and start working with the MongoTemplate, which is really going to abstract a lot of those simpler, more granular tasks of working with the Mongo data store. We'll see that a MongoTemplate bean can be auto-wired into our controllers, and then we can use more concise operations when performing persistence operations against the data store. We'll continue to abstract away the more simple lower-level calls and then begin working with the MongoRepository. And this is really the most simple way to work with a MongoDB data store. The MongoRepository is going to allow us to work from a very object-oriented paradigm and also work under the Spring Data Repository kind of perspective or approach. Using these three approaches, you'll see how easy it is to get a project up and running that can insert a document into a collection within a MongoDB data store. It's extremely simple. Throughout this chapter, I'm going to be working with a Mongo data store that I have running on my machine as a service. In order to replicate that data store, you'll need to create a database named Sandbox, a collection named Stock, and then a user with the username of Stocks, and then that user will have a password of password. If you set up these connection details within your MongoDB data store, you'll be able to follow along with this lesson verbatim. In this lesson, we'll use SpringBoot to quickly create an application that persists data to a Mongo data store. Using SpringBoot, we'll auto-configure a MongoDB factory bean, which will expose Mongo components necessary for data persistence. We'll get started by creating a new Spring Starter project. We're going to name this project Spring-Boot-Mongo. So we'll change the project name and the artifact ID and then hit Next. Within this project, we're going to rely upon the web dependency as well as the MongoDB dependency. With those two dependencies selected, hit Finish, and STS will begin building out our project. Since we have used the Spring MongoDB Starter project, we will now find that within our pom.xml file, the starter-data-mongodb starter POM has been added, and that's going to provide all of the components we need to work with MongoDB. Now, we need to do some additional configurations. So we're going to navigate to our Application.Properties file, and within this file, we need to specify some of the connection information to our underlying Mongo data store. The first property that we'll specify is the spring.data.mongodb.uri, and this is the connection string to our Mongo data store. So we put the protocol, MongoDB, // our server name, and then our database name, which in my case is Sandbox. So I have an underlying MongoDB data store running as a service on my machine, and it has a database named Sandbox. Now we need to supply some credential information. So spring.data.mongodb.username, and we specify our username. In my case, it's stocks. And then we need to specify the password for that user. And once again, I am using password as my authentication credentials. Okay, so this establishes the necessary connection information. The next thing we need to do is go ahead and create a document that will be stored within MongoDB's collections within our Sandbox database. So we'll navigate to the Package Explorer to create our new document. And we'll just create a new class within the com.o'reilly.boot package, and we're going to name this class stock. Within the stock class, we'll add the document annotation to the class declaration, and then we need to build out the fields within our stock class. So we're going to have a stock ID, a string for the company name, a string for the symbol, a string for the CEO, and then a double for the price. And we'll go ahead and generate those accessors for each of those fields. We'll format our class, and then we need to annotate the stock ID field with the ID annotation. So we'll go ahead and save our stock document, and now we're going to navigate to the SpringBoot Mongo application.java file, where we're going to establish our application. We'll need to modify our SpringBoot Mongo application to be a REST controller, so we do that by adding the REST controller annotation, and then we are going to auto-wire the MongoDB factory, and this is a bean provided by Spring that will allow us to access underlying components that can work with the Mongo database in order to perform persistence operations. This bean will automatically be configured for us by SpringBoot's auto configuration. Now we need to add an endpoint to our REST controller, so we're just going to add the stocks endpoint, and this endpoint is going to return a DB object, and we'll name the controller method stocks. And then we'll import the DB object type, and now we can build out the implementation for our controller method. Within this method, we'll create an object of type DB, and we'll name it DB, and then we'll use our MongoDB factory to invoke the getDB method, and we'll reach and grab our Sandbox database. Let's import the DB type, and then we're going to declare an object of type DB collection, and we'll name this object collection, and then we'll use our database to get the stocks collection from our data store. Using that collection, we can then insert a new record, and we do that by using an object of type basic DB object, and then we can just append different fields to that object. So in our case, we're going to create an object that has a field named company name. We're going to say that name is Ford. We'll append another field, the symbol field, and we'll specify the symbol as F. And we can go ahead, import those types. And now what we can do, since we've inserted that document into our collection, we can go ahead and find that document using the find one method on the DB collection type. And once again, we use a basic DB object, and then we just build the object out to specify the criteria that we would like to search by. So we're going to search where there is a document with a symbol of F, and that should return our newly created document. With these changes in place, let's run our demonstration. So we'll navigate to the Package Explorer, and we'll right-click on our project, and then run as a SpringBoot application. And now we should be able to navigate to our browser, where we'll navigate to localhost on port 8080, and then we can navigate to the stocks endpoint, and there we see we get our newly created document, which was inserted into our MongoDB data store. We were able to create this application and quickly wire up to a Mongo data store using our MongoDB factory bean, which was injected into our application and our REST controller, and it was automatically configured for us because we just specified some information within our application.properties file about how to connect to the data store, and we added the starter POM for MongoDB within our POM.xml file. So SpringBoot performed all that auto configuration on our behalf, making it very simple to work with Mongo. SpringBoot is also able to auto-configure a MongoTemplate bean for us to use when working with a MongoDB data store. The template offers convenient ways to perform CRUD operations against MongoDB. It provides simple mappings between our domain objects and MongoDB documents, so we're able to convert from something like a plain POJO over to a MongoDB document stored in the repository. In this lesson, we'll see a quick demonstration of how to get started with this bean. Within our SpringBoot Mongo application class, we're going to remove the MongoDB factory, and we're going to replace it with a MongoTemplate. This bean is automatically provided by SpringBoot's auto configuration. With the template in place, we can then change the implementation of our stocks method to rely upon the template instead of the more native Mongo components. You'll remember that the template is capable of mapping our domain objects to a document, so it's a little bit more plain when working with a document. For example, we just create a new stock, and let's give this stock a company name, and we'll say it's for Tesla. And we can then set some of the information. So for the symbol, we'll say it's TLSA. For the CEO, Elon Musk. And then we'll set the price. And at this point, we have created our stock. Now, using the template, we can very simply invoke the insert method on the template, and then we just need to pass in our stock, and alternatively, we can specify what collection that document is inserted into. The template also has query features. So for example, we can invoke the find one method on the template, and this requires us to specify a simple query using a basic query object, and that query just accepts a string where we specify the field and then some criteria for that field. So we're going to query by the symbol where it is equal to TLSA, and that's going to return Tesla. And then we can provide the class of our document. And once we import the types, we can then just modify our method to return a type of stock. And because it's a REST controller, it's going to return the JSON representation of that object. So you can see how much more concise it is to work with the MongoTemplate as opposed to the more native components that we work with when using the MongoDB factory. This template is provided out of the box by SpringBoot's Autoconfiguration for Spring Data Mongo. So very little configuration on our part. So let's go ahead, let's launch our application, and then we'll navigate to the browser where we'll go to localhost on port 8080, and then once again look at our stocks path. And there we see we were able to insert the Tesla document into our collection and then return it using the MongoTemplate within our application. The most convenient way to work with MongoDB is to use the MongoRepository. By default, SpringBoot will scan the class path to identify any Mongo repositories and declare them as beans within the container. If you have used Spring Data in the past, you are familiar with this approach. Our repositories will be automatically configured to connect to the underlying Mongo data store using the connection information provided in the Application.Properties file. Let's take a look at how simple it is to use the repositories within a SpringBoot project. The first thing we'll do is navigate to our package explorer, and within the com.o'reilly.boot package, we're going to create a new interface. We'll name this interface our stock repository, and then we're going to extend the Mongo repository interface. So select the Mongo repository interface, click OK, and then we can hit finish. Now, once our interface is created, we can add the repository annotation to our interface. Then we'll define the generic type parameters. So I'm going to specify that this is for the stock class, and the ID is of type integer. And then we'll go ahead and import our different types. Now, on this repository interface, let's declare a query method. So we're going to return a stock object from a public method named findBySymbol, and that method is going to accept a string named symbol as an argument. So what we'll see is that when this query method is invoked, we only need to speak in pretty much object terms, where we're working with a stock object and a simple string, and the repository will do the underlying work of spelling out the query for us. So we don't need to know how to construct different query strings to work with a Mongo data store. Let's now navigate over to the SpringBoot Mongo application class and modify our application to use our newly created repository. You'll notice that we are auto-wiring the MongoTemplate. Well, let's upgrade to use the repository. And I'll just name the repository repo. And now it's just replacing some of the calls to our template. So we need to save our stock object. And then here's where the real value comes in. You'll notice we are using the basic query and we're constructing a string to perform the query. There's also kind of a criteria builder that's a little bit muddled to work with. And you'll see how simple it gets now with the repository because we just invoke findBySymbol, and then we can specify the symbol of the stock that we would like to return. It's that simple to get started working with the repository. And it's because all the complexity has been removed by SpringBoot. It is performing the underlying configuration of that repository. So with our changes in place, let's go ahead and launch our application, and we can see the power of SpringBoot and Spring Data firsthand. So I'll navigate to my browser, and we'll navigate to port 8080, and we'll hit the stocks URL. And there you see we were able to create the Tesla stock with our repository, and that created a document within our Mongo collection, and then we were able to use the repository and its custom query method to return our document from that collection. You can see that the repositories offer a lot of advantages over the template or the MongoDB factory. I would always recommend working with the repository when possible. In this chapter, we'll focus on using caching with the support of SpringBoot. Caching may not seem all that exciting, and in most cases, it is almost transparent, but it can go a long way in improving the performance of our applications. If you have resource-intensive methods within your application that are good candidates for caching, you may want to pay close attention to this chapter. Let's talk a little bit about the content of the lessons in this chapter. We'll start out by building a SpringBoot starter project, and it's going to leverage SpringBoot's caching starter POM, and we'll get quickly set up to perform caching within our application using a generic caching implementation provided by SpringBoot. Next, we're going to switch to a more powerful and well-known caching provider, EHCache. EHCache is one of the roughly 8 caching implementations that SpringBoot supports. You'll also find support for caches provided by Redis, Guava, and JCache. For our purposes, we're strictly going to focus on EHCache. The configurations of the different caching providers are so similar that it's not worth your time to walk through the configuration of each caching implementation. If you can configure EHCache, you shouldn't have any problems with the other caching implementations supported by SpringBoot. SpringBoot does the majority of the work for you. It's going to auto-configure many of the necessary beans that will be needed to perform caching. And that's where we're going to head to next. We're going to work with caches explicitly within our code by leveraging the Cache Manager bean created and configured by SpringBoot. While this is not the recommended approach, normally you can just use annotations and work transparently with caching. It can be useful for testing situations, so we will take a look at and explore how to work directly with a cache. In this lesson, we'll explore SpringBoot's caching support. SpringBoot makes caching easy to set up, allowing you to configure your application to avoid unnecessary method calls. This strategy can be used to avoid multiple invocations of resource-intensive methods. This increases the performance of your application code. We'll begin by creating a new Spring Starter project. We are going to name this project Spring-Boot-Cache. We'll also be sure to change the artifact ID to match our project name, and then we'll go ahead and hit Next. Now, within our dependencies, we're going to search for the cache dependency, and we'll add that to our new project and then hit Finish. STS will then begin to build out our new SpringBoot project, and once it's built, we can go in and explore. The first thing that we'll do within this project is we're going to create a new class within the com.o'reilly.boot package. So we'll open the new dialog and find class, and once again we're going to make a stock class. Now we've seen this class before, so I'm just going to copy and paste the implementation for this class, and then we'll navigate back to our package and add another class. This class will be named Stock Tracker. The Stock Tracker class will be a bean within our Spring IOC container, so I'm going to add the component annotation so the class is picked up during component scanning. Next, I'm going to add a method to the class that returns a double and will name the method getPrice. This method will accept a string parameter that we're going to name symbol. Within the method, we're going to return the stock price for the stock associated with the given symbol. So what we're going to do is just use a random. So I'm going to specify a random number between 20 and 200. So we need to provide our min value and then add the difference between our min and max values. And then we can multiply that by a new random object, and we can invoke the next double method. So this should produce a random double value between 20 and 200. Now also within this method, I'm going to print out just some console output to know that we have actually invoked this method. So I'll just say generating the price. And we'll go ahead and we will save our stock tracker class. And then we're going to add the cache result annotation to this method. So this is a JSR 107 annotation. The annotation is contained within a JSR 107 artifact that we can add via our pom.xml file. So I'm going to navigate to the pom.xml file, and I will then navigate to the Dependencies tab, and I'm going to enter the group ID javax.cache, and you will then see that we get a number of artifacts, and we want to select the cache-API artifact. So go ahead and import that into your pom.xml file, and then you can close your pom, and once our project builds, you'll see that we can import the cache result annotation. This will cause the method to be cached when we have a value that matches the symbol supplied. So now let's navigate to our SpringBoot cache application class, and we'll begin to build out our application that will leverage the caching support provided by SpringBoot. The first thing we'll do within the SpringBoot cache application class is add the enable caching annotation to our class. And then we're going to have our class implement the command line runner interface. So we'll go ahead and import the command line runner type, and then we are going to add the appropriate methods to satisfy the interface. So we then have the run method added to our class, and now we need to provide an implementation of the run method. So the first thing we're going to do within this method is we're going to print out some console output, and we're just going to say the price is, and then we are going to iterate through a loop, and for each invocation of the loop, we're going to print out the price of a stock. Now, in order to do that, we need to auto-wire our stock tracker bean, and we'll just name this variable tracker, and Spring will inject the stock tracker bean for that field, and then we can leverage it within our run method. So let's use the tracker, and we're going to invoke the getPrice method, and let's get the price for the stock with the symbol of T. Before we run our demonstration, let's discuss the results we expect to see when we run this application. So we're going to iterate through our loop, and each time we're going to invoke the getPrice method on the stock tracker bean. If we take a look at stock tracker, we see that the getPrice method can cache its result. This means that when we invoke the method, the argument supplied will be used to search our cache to see if there is a value within our cache that corresponds with that argument. If there is, the value will be returned from the cache. So the first time we invoke the getPrice method, we will actually execute the code within the body of the method, and we will see our console output be printed. Subsequent executions of this method will not actually execute the code we see in the body. Instead, the result will be returned from the cache. So let's navigate to our Package Explorer, and we can right-click on our project, and then we can run the project as a Spring Boot application to see our demonstration. If we navigate to our console, we'll see the output generated from our application. You'll notice that we only invoke the method once, and that's indicated by the fact that generating the price was only printed to the console one time, and then subsequent executions of our loop print out the price, but not the generating the price string. So that tells us that our caching was taking effect and we were not actually executing the body of that method. So in this lesson, we learned how to take advantage of Spring Boot's support for caching within our applications. By default, Spring Boot's caching support provides us with a generic implementation of a cache. If we would like to use a more powerful or widely accepted cache, Spring Boot makes it very easy to switch our caching implementation. In this lesson, we're going to switch our cache over to Cache, which is a widely used open source Java cache. To get started, we'll need to add the appropriate dependency to our pom.xml file. So within the pom.xml file, we'll go ahead and hit the Add button, and then we're going to look for the group ID net.sf.ehcache. Amongst the returned artifacts, you'll notice the ehcache artifact that has the managed tag on it. And that's because Spring Boot is able to specify the appropriate version that we'd like to use. Select this artifact and hit OK. At this point, you can save your pom.xml file, and now we'll navigate to the Package Explorer. Within the Package Explorer, we're going to create a new file, and we're going to name this file ehcache.xml. This file will contain the configuration for our caching provider. We're going to give a very basic configuration for our cache. So just start out with the ehcache tag, and then within this tag, we're going to create a new cache, and I'm going to name this cache price, and then we specify how many entries can be on our local heap, and I'm just going to say 200, and at that point we have configured our ehcache.xml file, and this will be read by our caching implementation and used to create our price cache. Now, since we have a named cache, we need to navigate to the stock tracker class, and on the stock tracker class, we need to specify the name of our cache on the cache result annotation. So we use the cache name element, and we specify that we are going to use the cache price. And that's all it takes to switch your caching provider when using Spring Boot. So let's kick off this demonstration by launching our Spring Boot app, and then we'll watch our console to see its execution. You'll notice that our application once again relied on the caching support provided by Spring Boot that made configuring our ehcache provider very simple. Just to prove that we are using our ehcache provider, let's navigate to the Application.Properties file, and within that file we can set the debug flag to true, then relaunch our application, and if we take a look at our console this time, we can indeed see that the ehcache configuration was matched and the auto configuration for ehcache was used. There we see the ehcache cache manager being created and leveraged when we eventually execute our application logic and invoke the caching support. When using Spring Boot to support caching, a bean of type Cache Manager will be available for auto-wiring within our applications. By injecting the Cache Manager into a bean, you can directly work with caches. In this lesson, we'll take a look at how this is achieved. To get started, the first thing that we'll do is register the cache manager bean within our stock tracker class. So I'm going to declare a variable of type cache manager, and I'm going to name it manager. And then I'm going to add the auto-wired annotation to that field on our class. Now, when importing the types, be careful. You want to choose the net.sf.ehcache.cache manager type, and once that type is imported, we can go ahead and build out a new method that will use our cache manager bean. So this method is going to return a type of double, and we're going to name the method getPriceWithManager. This method will accept a string parameter named symbol, and then within the body of the method, we're going to work with our cache manager bean to retrieve a cache. So we'll declare a variable of type cache, and we'll name it cache, and then I'm going to invoke the getCache method on the cache manager. Now, the cache that we'd like to retrieve is our price cache. So we have declared that there will be a cache named price within our application, and that's the cache we'll be working with. Now, once again, we need to be careful with our imports, and we would like to choose the net.sf.ehcache.cache type. Once we have retrieved our cache, then we can work to return our double value. So I'm going to invoke the static value of method, and I'm going to pass in an object from our cache. So I'm going to use the cache, and the first thing I'll do is invoke the get method, and we pass in the symbol. So just think of this almost like a hash map. You pass in the key, and then you get the value. But we do need to invoke the getObjectValue method, and then I am going to invoke the toString method on that returned object. At this point, we have set up our getPriceWithManager method that relies upon the injected cache manager bean in order to retrieve a value from our cache. Now we're going to navigate over to the SpringBoot cache application class and build some logic into our application that relies upon this method. So let's now begin adding our application logic to invoke our new method. So within the run method, I'm going to add a little bit of logic. The first thing we're going to do is invoke the system.out.println method, and we're going to print some console output. We're going to say getting price with new method. And the reason we're putting this in there is so that we can discern from the invocations of the getPrice method and invocations of our new method. So then we're just going to once again add some console output. We'll use our tracker bean, and we can invoke the getPriceWithManager method, and we'll pass in t as the symbol. So let's talk a little bit about what's going to happen. When the run method is invoked, we'll print some console output, and then we're going to begin iterating through our loop. We'll get the price from the stock tracker bean the first time, and then every subsequent invocation of getPrice will be cached. But at that point, we will have a value in our cache for the symbol t. Then we're going to come down, print out our new console output, and then invoke the getPriceWithManager method on the stock tracker bean. Now, what's different about this method is that it will not rely upon the cache transparently. Instead, it will explicitly invoke operations on the cache using the cache manager bean that we have passed in and dependency injected into the stock tracker bean. Okay, so let's go ahead and launch our application, and then we'll inspect the console output to see what we get. So there we see, as expected, we invoke our getPrice method once, and that's going to put this value within the cache, and here we see we get that same value out of the cache When working with the newly created method and the cache manager bean. So in this lesson, we saw how to use the cache manager bean, which will be auto-configured by SpringBoot and made available for dependency injection. In this chapter, we'll focus on ways that SpringBoot supports the developer themselves. So as a developer, there's certain things we need to do. We get into different flows within our IDE, and we also need to look at things like logging in order to get important information from our applications, which is useful for analyzing their execution. SpringBoot provides support within these two areas that we can leverage as developers. So within the lessons in this chapter, we're going to go in detail on those two areas. The first thing we'll do is we'll look at how SpringBoot can support automatic restarts and a feature called LiveReload. These two features within SpringBoot allow developers to automatically see changes, whether it be when we make a code change and SpringBoot automatically recompiles and deploys our application, or when we make a change and it automatically appears in our browser. With some simple configuration, SpringBoot is able to detect these types of changes and then make them available to us, and this eliminates some steps when working in our IDEs. These features will support a faster development pace and eliminate some tedious actions that we need to perform. Next, we'll start taking a look at SpringBoot's support for logging. There's a lot of automatic configuration or auto-configuration that you'll see provided by SpringBoot. It's very simple to have logging out of the box, and we can work to adjust that logging by setting properties within our Application.Properties file. So we'll see how to adjust the logback behavior, which is the default logger within SpringBoot, and we'll see how we can tweak the different log entries that we collect from our applications. After that, we'll take a look at some more advanced logging setups where we can actually write to files and where we can conditionally choose our logging configuration based upon the profiles within our applications. When finished with this chapter, you'll see some additional ways that SpringBoot supports you as a developer and some very specific tasks that we commonly see within our jobs. When building an application, we are all familiar with the pattern of writing a little code, then restarting our application to inspect the changes. You've seen the pattern throughout this course and have probably done it tens of thousands of times during the course of your career as a developer. Luckily, SpringBoot provides an automatic restart capability as part of its developer tools. Developers can choose to have their applications restart automatically whenever a file on their class path changes. This creates a faster feedback loop and eliminates another task for the developer. To see this feature in action, let's go ahead and create a new Spring Starter project, and we're going to name this project Spring-Boot-Tools, and then we'll make sure that the artifact ID matches the project name, and then hit Next. Now for this project, we're going to include the web dependency as well as the DevTools dependency. With those two dependencies selected, I'm going to go ahead and hit Finish, and STS will begin to build out our new project. The first thing that we'll do within this project is open up our Spring Boot Tools application class, and we're going to add the REST controller annotation to this class. So we'll go ahead, add the annotation, and then import that type. And then with the type imported, we're going to add a request mapping to the root of our class path, and we're going to attach that mapping to a method that returns a string, and we'll name that method hello. And this is simply going to be a nice little hello world method that returns the string from our REST controller. Okay, so nothing fancy here. Let's go ahead and save our class And now we're going to right-click on the class within the Package Explorer. We're going to go to Run As and then Java Application. This will start our application, and we can watch it start within our console window. And we see that it's started, so now we can go to a browser, and we get our Hello World output. Now let's return to our STS IDE, and we're going to pull up our console window a little bit because I want you to see what happens. So we have loaded our app. It's currently up and running and servicing requests. Let's go ahead and make a little change to the app though. Let's say, hello Spring users, this is automatic reloading. So we'll go ahead and add this output. Now as soon as I save this class, what is going to happen is STS, or Eclipse in the background, is going to compile the class and add it to our class path. Now with SpringBoot's automatic reloading, it is monitoring our class path to look for any changes. Once it detects that change, it's going to restart our application, making our changes available to the developer for testing. So I'm going to go ahead and I will save. And now let's watch the console. See, it just kicked off and now it's reloading our application. And I can just go over to the browser, and if I navigate to localhost 8080 once again, we see that we get our new message. So I didn't have to restart my application. SpringBoot did that automatically for me. This is a very handy feature if you're doing development and making constant changes. Some developers may not wish to have this functionality enabled. If you would like to disable automatic reloading, it's pretty simple. Just go to Source Main Resources and click on your Application.Properties file. And now you can set the spring.devtools.restart.enabled property, and it accepts a Boolean value, so I'm just going to go ahead and set it to false. Now you'll notice that we did have automatic reloading on prior, so it picked up that change on our class path and did reload. So let's go ahead and stop the application, and I'll clear our console. And now we're going to restart it as a Java application, and we'll go back to our class once we're sure everything is reloaded. So at this point, we have reloaded, and now let's make a change and see what happens. So let's say, hello Spring users, this is automatic reloading disabled. And we'll go ahead and save that change. And now you'll notice that we do not restart the application. And if I were to navigate to localhost 8080, I get the same message. I don't get the newly updated message. In order to get my most recent code changes, I would have to restart the application. So if you would like to disable this feature, that is also an option. So in this lesson, we took a look at how to automatically restart our applications for changes that we make that wind up on our class path. And this saves us time, and we're not constantly reloading the application while doing development work. SpringBoot is capable of detecting changes on our class path and automatically restarting our applications as necessary. This is a handy feature for developers. However, the folks at Spring have taken it a step farther with integration for LiveReload. With LiveReload, these changes can automatically appear within our browsers. Let's take a look at how this works. So what we'll do to get started is we're going to start our application by right-clicking on our class and going to Run As and Java Application. Now let's closely pay attention to our console output as the application starts. If I look for LiveReload within our output, you'll see that we have a LiveReload server that is running. And this server is capable of serving up changes to our browser. Basically, when we make a change, there is a trigger in the browser, and the browser refreshes and displays our latest code. In order for this to work, we need to add a browser extension. So I'm going to navigate to Chrome, And I'm going to go into more tools from the options, and I'm going to go to extensions. Now, within extensions, at the bottom here, I can get more extensions, and I'm going to look for LiveReload. I'll scroll down, and there we see the LiveReload extension, and it's offered by LiveReload.com. So it's free, so I'll go ahead and add it to Chrome, and I'll add the extension, and Chrome comes back, tells me the extension has been added, and now let's take a look. So let's first go to localhost 8080, and we get the message telling us that automatic reloading is disabled. Well, the first thing I'm going to do is click on the icon here to enable live reload, and then I'm going to head back to STS. And the first place we'll go is to our Application.Properties file, and we're going to re-enable our automatic restart. So I'll just remove that property from the Application.Properties file, and then I'm going to navigate to the SpringBoot Tools Application.Java class, and we're just going to change our message to indicate that we are now able to perform automatic reloading. So we'll just say, hello Spring users, this is automatic reloading, and then I'll hit save. Now, at this point, we should not automatically reload because we did not start the application that way. So let's stop the app, we'll go back and restart it as a Java application. And this is exactly what we're trying to avoid, doing this every time. So now our application loads, we can take a look at the browser, and we get our new message. Now let's say we want to change that. Let's go to SpringBoot Tools Application, and let's add a little bit different of a message. Let's say, hello Spring users, this is a great way to save time. Okay, so you'll notice that my class is not saved yet, so let's pull the console up so we can see the automatic reloading once again. I'll save, the reloading will then kick off, and let's head to our browser, and look at that. Live Reload already loaded our changes into the browser. I didn't have to navigate back to the URL and send a new request. It was done automatically for me. So this is another great way that SpringBoot has integration with another tool to make our lives easier as developers. And that tool is LiveReload, and we saw a quick demonstration of the benefits it provides to us. Logging is a fundamental component of any well-designed application. It provides developers and administrators a glimpse of program execution, which can be invaluable for troubleshooting system behavior. Within Java applications, many frameworks exist that allow us to make log entries. In this lesson, we'll see how SpringBoot supports logging within our Spring projects. It's very simple to see our logging support in action when working with SpringBoot. All we need to do is go ahead and launch our application as a SpringBoot application, and then if we inspect the console, we'll immediately notice that we're getting logging output, and that is provided by SpringBoot's default logging implementation, Logback. Logback will print all info level log entries to our console by default. Now, for those of you not familiar with Logback, it is the successor of the Log4j project, which is a popular Java logging framework. The Logback framework implements the simple logging facade for Java API, or SLF for J. If we would like to modify the logging behavior within our applications, we can turn to the Application.Properties file, which provides us with some convenient properties for adjusting our logging. So for example, we can set the logging.level.root property to one of the different logging levels. So for example, I'm going to go ahead and set the logging level to debug, and then I'll save the application, and then I am going to go ahead and relaunch the application. And actually, it may have been done for us. Yep, because we have DevTools set up. there we see that we are launching the application and we are now logging entries that are at the debug level. And we're getting way too many entries there. So the next thing we're going to look at is how we can be more specific about what entries we actually do log at what level. So I'm going to go ahead and shut down the application, and then we're going to navigate back to the application.properties file. And within this file, what we can do is we can provide more granular logging configuration. So for example, I can say that I only want the Spring Framework web package to be at the debug level. Everything else can be at info. So this is going to prevent us from getting all those Tomcat entries on our log. So let's go ahead and relaunch, and now we can see that the only debug entries we get are those coming from the org.springframework.web package. And you'll notice that we had a lot less latency with our console output because we're not throwing so much out into our logs that we are really holding the system back with how much logging is being performed. So we're able to really, at a granular level, adjust logging. Now, what else we can adjust is where our log files are written to. So right now, we're just logging to the console, but if we specify a log file, we can redirect our output to an actual file within the file system. So I'm going to send everything to a file named mylog.log. And then if we reboot our application, we can navigate to our package explorer, and if we hit F5 at our project level, you'll notice that we now have a log file appear. And that log file is going to contain the output from our system. And there we see our log file. Within the application.properties file, we can specify the exact name of our log file, or we can specify the logging.path property, and this is going to allow us to direct our log to a specific path. So let's go ahead and we'll restart our application. And now if we look within our project and hit F5 again, we're going to see the log directory is created and the spring.log file is placed within it, and this file is going to contain our console output as well. So we can configure exactly what files the logging mechanism writes to using the application.properties file, and we can also specify the appropriate logging level. And more likely than not, we'll be adjusting that logging level for our application. So in this lesson, we took a look at some logging basics and how SpringBoot supports logging within our applications. When using various logging systems with SpringBoot, we can place a configuration file on our class path to dictate the various behaviors of the logging system. For example, when configuring logback, we can add a logback-spring.xml file or a logback.xml file to the class path and specify the configuration of the logger. If you consult the SpringBoot documentation, you will see that various other configuration files can be used, such as the log4j.xml file, which is used to configure a log4j implementation. This approach can be used when we have an advanced configuration need for our application and the application.properties file just won't meet our needs. So let's go ahead and remove our configuration from application.properties. And now we're going to navigate over to our Spring Boot Tools project. And within the source main resources directory, we're going to create a new file. So we'll type in file into the wizard, and then we will build out a logback-spring.xml file. This file will contain our advanced configuration for the logback logging system. So I'll go ahead and hit finish, and then our new file will be created. And within this file, we're going to specify our advanced configuration. This file is configured very much like a logback.xml file, except we can add some specific Spring tags within it. But the first thing we need to do is we need to specify our XML version, and we'll set that to 1.0, and then we're going to set the file encoding to UTF-8. So we have that tag in place. Now the next thing we add is a configuration tag. And within the configuration tag, we are going to have two Spring profile tags. So I'll go ahead and just duplicate the Spring profile tags. And the first profile we're going to name dev, and the second profile is going to be named prod. So this is representing different environments that we would like to have different logging configurations for. So within the first environment, we can add a resource to be included, and it's going to be org.springframework, then /boot/logging /logback, and then we're going to point to the base.xml file, which is going to contain some specific configuration for logback that SpringBoot provides for us. Now, within prod, we're going to have a similar include tag, except we're going to reference the defaults.xml file. Now, inside of the dev profile, we're going to go ahead and add a logger, and the name of this logger will be root, and we are going to set the level to debug. So we'll go ahead and close that tag. And now inside of our prod configuration, for this profile, we're going to add a property, and we're going to set the property name to log file, and then we specify the name of our log file that we would like to see. The next thing we do is we include another resource, and we once again point to a resource made available within the org.springframework /boot logging /logback /file appender.xml file. So this file will configure a file appender for our application. And just take a moment right now to make sure you have these paths spelled out correctly so we don't have any errors. And there I can see that I missed a / between boot and logging, and I'll continue validating these paths, and everything looks good. So the final thing we do within our prod configuration is we're going to add the root tag, and we'll set the logging level to info, and then we're going to point to a file appender, and that's going to be our reference to the actual file there. Okay, so at this point, we have our custom configuration for logback. Now what we need to do is we need to navigate to the run configurations. So the first thing I'm going to do is just run this application, and it may fail. But I want to make sure that we have a run configuration to work with. So I'll run it as a Spring Boot app, and once everything loads, now we can go in, go to our run configurations, and here we're going to see our Spring Boot application, and we can go ahead and add an argument. And the argument we're going to add, if you remember, is the spring.profiles.active argument, and this is going to allow us to specify the profile we'd like to use. So let's go ahead and first we'll use dev. So I'm going to apply this, then I'm going to close the run configurations dialog, and I'm going to relaunch our application. And what you'll notice is that we then begin to log to our console all of our debug output. So this is using our dev profile. Now, if I stop the application, I can go ahead and shut down the Spring Boot application. And it takes a little bit when you're in debug because so much output is coming out of Tomcat. So there we go, we're shut down. I'm going to remove our launch there. And now we're going to go back into the run configurations and we're going to switch over to prod. So I'm going to apply that and we'll close that configuration window and then I'll relaunch the application. And what you'll notice this time is we're no longer getting any output within our console, but if we do navigate over to the Package Explorer, we get the temp.log file, which is now collecting all of our log entries. And that's because within the logback-spring.xml file, we set up a profile that used a file appender to collect our logging output into a specific file. And because we've activated that profile, SpringBoot will apply that behavior to the logback logging system. So in this lesson, we saw how to use a XML file to configure advanced configuration for our logging system. And in this case, it was for logback, and we used a configuration file that is really based upon the logback.xml configuration. But because we used the logback-spring file, we are able to include some of the Spring tags such as the profile, and we leveraged that in order to manipulate the application's logging. In this chapter, we'll take a close look at the SpringBoot Actuator. The Actuator provides features that allow us to monitor and manage our applications via HTTP endpoints. These endpoints provide us with a variety of information about the application, such as what beans are used, what auto configuration is used, the status of the system. The endpoints also provide an easy mechanism for viewing log files or performing thread dumps. In general, the Actuator is a great tool for developers to use to monitor their applications. As we work through this chapter, you're going to be exposed to many tools that allow you to monitor and manage your SpringBoot app. You'll see tools that allow you to view the log files, to run a thread dump, to see information about heap usage. There's all sorts of valuable information exposed by the Actuator endpoints that we're going to explore in this chapter. We'll take a look at the most prominent and widely used endpoints of the Actuator, and then we'll see how we can extend and customize these Actuator services in order to satisfy custom needs that we may have for our applications. Many of the features of the Actuator can be customized to change their behavior, and we can also provide our own implementations of some of the Actuator beans in order to collect additional information about our application. And we'll even see how we can make our own custom endpoint that will be exposed as an HTTP resource on our Actuator. So there are a lot of options with the Actuator, and you'll notice that we can look at all of these endpoints. So this is the list of endpoints that are available to you as a developer by default. We'll take a look at the majority of these, paying very close attention to things like the health endpoint, the info endpoint, the metrics endpoint, and also taking a look at some of the very useful features such as the dump and trace endpoints. Also, remember, you can build your own endpoints. So really, the Actuator is very extensible. It's a great tool for developers. And as you work through the chapter, you're going to see the Actuator performing a lot of behaviors that you may have built into your own applications via custom code. So now you have this functionality via a nice standardized interface. In this lesson, we'll configure a new project to leverage SpringBoot's Actuator. Using the actuator, we can monitor and interact with our application using various HTTP endpoints. These built-in endpoints can provide us with various pieces of diagnostics information about our application. To get started using the actuator, we're going to create a new Spring Starter project, and we're going to name this starter project Spring-Boot-Monitor. So make sure that you have the name and the artifact ID specified, and then go ahead and hit Next. And then when we select our dependencies, we are going to select the web dependency as well as the actuator dependency. Once we've selected these two dependencies, go ahead and hit Finish. STS will then begin to build out our new project, and once our project is built, we're going to go ahead and add a controller to our project. So I will navigate to the source main Java directory, and within the com.o'reilly.boot package, I'm going to add a new class, and I'll name this class Simple Controller. Once I've specified my class name, I'll hit Finish, and I'll have my new class. Now we'll make this a REST controller, and we'll import the REST controller annotation. With that annotation in place, I'm now going to go ahead and build out a mapping on this controller, and the mapping is going to be to the execute path, and we'll put that annotation on a method that returns a string, and we'll name the method execute, and then we're simply going to return a string that says invoked, and we can go ahead, add our request mapping annotation to our class, and then save the class, and we now have a controller method. Now I can launch our application by right-clicking on the Spring Boot Monitor project, and then going to Run As, and then Spring Boot App. This will start up the application, and the application has the actuator enabled, and we're going to head to our browser to take a look at a number of the endpoints exposed by the actuator. So the first thing we'll do is we'll navigate to our local host on port 8080, and we're going to take a look at the mappings endpoint, which is exposed by the actuator. This endpoint will list all of the request mappings registered with our application. So if you look closely, you'll see the /execute path is registered as a request mapping to our simple controller execute method. You'll also see a number of other request mappings that correspond with the actuator itself. So for example, here we see the /env endpoint. We also have the /info endpoint, and we'll learn more about these as we move along. One that you will also see configured is the bean endpoint. So what we can do is we can take a look at the bean endpoint, and actually that's beans as opposed to bean. And when we take a look at the beans endpoint, what we'll see is that all of the beans registered in the Spring IOC container are now displayed via a JSON-like syntax. So we can take a look, and there we see our simple controller bean. We can see some information about the bean, that it's a singleton. We see the actual fully qualified class name. And this is a great way to see exactly what is within our dependency injection container. As you can see, there are quite a few beans configured just for our very simple Spring app. Now, if we were to invoke our execute method on our controller, then we can go take a look at the trace information, and this is going to display some of the latest HTTP requests that the application has serviced. So there we see the /execute path was in fact visited as part of this request, and we get all of the information about that request. Another thing that we can do is we can run a thread dump using the actuator. So here we see a thread dump once again in JSON format, but look how easy it is to access this information instead of opening up something like an SSH session with your server. However, you may need to do that. There's a lot of security normally involved, and you're logging in possibly through multiple interfaces, so it's a lot easier to have this available to you. So these are just a few of the endpoints exposed by the actuator. It's very convenient and very accessible. It's a great way to run diagnostics when you're doing development simply by using an HTTP endpoint. Once you start working with the actuator, you may wish to customize the configuration of the actuator endpoints. In this lesson, we'll use the Application.Properties file to adjust how we access the actuator and what endpoints are exposed on the actuator. So if we launch our application, we can take a look at another endpoint that is exposed by the actuator. So I'm going to navigate to localhost on port 8080, and we're going to look at the autoconfig endpoint, and this will display all of the information about the auto configuration decisions made by SpringBoot. You'll notice that by default, the path is /autoconfig. Let's change this via our application.properties file within our application. So I'll open the application.properties file, and then what I'm going to do is I'm going to use the endpoints node, and I'm going to then look within the subnode autoconfig, and I can adjust the path. So let's just say I want to set the path to /AC. Well, I can go ahead and relaunch our application and then navigate back to the browser, and you'll notice when I try to navigate to /autoconfig, I now get an error. However, that resource is now available via our new path that we configured. Now, let's say we didn't want to allow the autoconfig endpoint to be exposed. We just didn't want people to see that information. We can go ahead and set the enabled property on the autoconfig node to false. And now we will not see that endpoint exposed at all. So we'll relaunch our application, navigate to the browser. Now, once again, we'll need to use the autoconfig path, and here you'll see that it is not available. So once we navigate to that path, Spring says, I don't have anything, I don't know what you're looking for. Now, if we were to set it back to true, save our application.properties file, and then return and hit that same URL, we then get a response because the endpoint is made available. So there we see how we can toggle the endpoint on and off. Now, another thing we can do is we can adjust the path that we use to get to all of the actuator endpoints. So for example, I'm going to set the management.context path, and this will adjust the path we use to get to the actuator. And this can be useful if you're trying to avoid default paths for security reasons. So let's just set this path to manage, and we can relaunch our application. And now when we navigate to the browser, in order to access our autoconfig endpoint, we need to add the manage path, and that's how we access it now. So we've globally configured how we access all of the actuator endpoints. Another thing we can look at is the sensitive property on our endpoints. So for example, we can expose a health check, and this basically reports on how our application is behaving, whether or not certain services are up. So by default, the sensitivity of the health check is set to true. We're going to leave it at true, restart our application, and we'll take a look at what we receive back. So we'll navigate back, and now we're going to hit the health endpoint, and it's very simple. It just says the status, the application is up. Now, if we wanted to receive more information from the health endpoint, we can set its sensitivity to false. And now, when we are not logging in, we will get more information. So we don't need to authenticate to see further information about the health of our application via the actuator's health endpoint. And there we see we get some information regarding disk space, which we may not want to always expose to just anybody. So we can set whether or not an endpoint requires authentication to either see the endpoint or to get more details about the endpoint. And to do that, we use the sensitive property. So you'll see that there are various properties available for our endpoints, and these properties correspond with the various endpoints exposed by the SpringBoot actuator. We're not going to see all of these. So for example, we're not going to dive into the flyaway actuator endpoint, but we will see the majority of these. You can easily use the application.properties file to configure the behavior of the actuator. SpringBoot exposes a health endpoint that provides diagnostic information about the status of a running application. This can be useful for monitoring our application in the case of a production outage. The health endpoint relies upon several health indicator beans, which monitor various application components. SpringBoot provides many auto-configured health indicators for popular components such as JDBC Datasources, Mongo, and Redis. In addition, we can create our own health indicators. In this lesson, we'll learn more about the provided health indicators and see how to create our own custom indicator. To see the health endpoint in action, we're going to open our pom.xml file, and within the POM file, we'll click on the Dependencies tab, and we're going to add two dependencies to our application. The first is going to be the JDBC starter. So we're going to use the group ID org.springframework.boot. And then if we scroll down, we can find the spring-boot-starter-jdbc entry, and we'll include that artifact. And then we'll come back and add a relational database. In our case, we're going to add the H2 database, and we'll simply select the H2 artifact within the com.h2 database group ID. Once we've selected that, we can go ahead and click OK, and we'll save our pom.xml file. Now I'm just going to go and launch our application, and now we can navigate to a browser, and we'll start to access the health endpoint. And when we view the health endpoint, you'll now see that we have an object corresponding with a DB that has been added to the JSON output. So this is an example of the health indicator monitoring one of our components, a JDBC data store, and providing us with diagnostic information about that data store. So if we were running in production and your database was actually down, you would get that notification by the actuator. Returning to STS, we're now going to learn how to create a custom health indicator which will leverage the actuator and display more information to us about one of our application components. So to get started, we'll minimize the pom.xml file, and then we're going to create a new class within the com.o'reilly.boot package. So I'll just go ahead and create a class with a new dialog, and I'm going to name this class Custom Health Indicator, and then we're going to have this class implement the Health Indicator interface. So we can go ahead and hit OK, and then hit Finish, and our new class will be built for us. Now we need to add the component annotation to this class so it's picked up by SpringBoot's component scanning or Spring's component scanning and turned into a bean within our IOC container. Now within the body of our class, we need to return a health object which indicates the status of whatever component we are providing the health of. So you may have some other type of service that you would want to indicate is alive and healthy. For example, maybe you're connecting to some web service and you're going to do some logic here to say that service is either up or down. So your usage of this method is really going to depend upon your needs. In our case, we're just going to return something static back. So if we look at the health class, we'll see that it has some static methods that we can use that act as a builder. So we can indicate that the component is down, and then we can say with detail, and this is going to provide some additional output in the JSON output provided by our health indicator. So let's just say error message, and then we'll give some reason why it's down. We'll say there is no connection to the service, and we'll leave it at that. Then we just have to invoke the build method on that builder, and we have our custom health indicator in place at this point. Now, if we were to relaunch our application, we can navigate back to our browser, and we can once again hit the /health path, and we should get additional information, including the message from our custom health indicator. And there, in fact, we do see that we get the status of down, and we get our error message included. Now, normally you would perform some for logic within this class to indicate an actual status. So in this lesson, we took a look at the health indicator and how it can provide us with status information regarding the functionality of one of our components in our application. And we also saw how to create a custom health indicator, which can be used to provide health information regarding a custom component in our applications. Another endpoint exposed by the actuator is the info endpoint. The info endpoint can be used to display information about our application. This information is configured as properties under the info setting in the Application.Properties file. So if we were to launch our application and then navigate to a browser to visit the info endpoint, we're going to be a little bit disappointed because we will not receive anything in our response other than an empty JSON object. So what we need to do in order to get properties to display when we visit that endpoint is we need to add the info node, and then we can add anything we would like. So let's say info.name, or let's go with app name. And then we can set it to whatever we'd like here. Let's just go with example SpringBoot app. And we can also set something like the info. Let's say we give some information about the framework we're using, and we'll say Spring, and we'll put SpringBoot after that. And if we then save our Application.Properties file and relaunch our application, we're now going to find those properties are available from the info endpoint. So there we see that information we put in the Application.Properties file can now be accessed by one of the REST endpoints on the actuator. Now, one of the neat things about this is if we have an endpoint where we would like to reference information from our Maven configuration, we can do that. So let's say we want to go with info.artifact. Using the @ symbol, I can then reference a Maven property. So here I'm going to let's get the artifact ID, and let's say we want info.name. We can grab the project's name from Maven. So this is a way of having our information be written once, and then we're referencing it across our configuration, so you're not duplicating everything. So now, if we relaunch our application, we're going to find that those additional properties are exposed and their values are set to Maven property values. So there we see that the name of our application is set to spring-boot-monitor, and our artifact name is also spring-boot-monitor. And that information is coming from our pom.xml file. And it's a way of not repeating ourselves, and it's a handy way to populate that information within the application.properties file. So in this lesson, we took a quick look at the info endpoint and how we can use it to expose information about our project. The log file endpoint provides an extremely convenient way to view our logs from within a browser. By simply accessing an HTTP endpoint, we can quickly view log entries for our application. This sure beats an SSH session. So let's start up our application, and then we're going to navigate to a browser, and we'll attempt to invoke the log file endpoint. Now, you're going to be a little bit disappointed because we will not receive any output. So in order to make this feature of the actuator work, we have to be sending our log entries to an actual file as opposed to just the console. So if you remember, you can set the file property on the logging node to a file you would like to send your log output to. In my case, I'm just going to send it to mylog.log. And then I will relaunch my application, and I should notice immediately that I get my new log file. And then from the HTTP endpoint log file, I can access the contents of that file via the browser. So there you can see I'm able to view my log file simply by invoking this HTTP endpoint. And that's another great feature of the actuator, providing us with quick and simple access to our log. So if there were something we needed to debug within our environment, we would not need to go through all the normal mechanisms of getting to our logs. We get it at our fingertips via a web browser. When working with SpringBoot's actuator, we can make the links to all of the actuator endpoints accessible via a discovery page provided by the framework. This discovery page provides hypermedia resource representations for each of the available resources on the actuator. Configuring this functionality is extremely simple. All we need to do to expose these hypermedia resources is add an artifact to our pom.xml file. So I can add an artifact from the org.springframework.boot group ID, and the artifact I'm going to be adding is the spring-boot-starter-hatios artifact. And hatios is the hardest acronym to say in tech. It stands for Hypermedia as the Engine of Application State. Well, that sounds pretty fancy. What it really means is we're going to have a bunch of discoverable links that detail our site's REST API, and it serves as almost the root of our REST API, and it can be used for navigation by various resources such as web services or even people. But it's a great way to provide a map of our REST API. So we're going to go ahead, and all we need to do is add that artifact onto our project's class path. We restart our application, and then we can head to a browser, and we navigate to the local host on port 8080, and then we visit the actuator endpoint, and this is going to provide hypermedia links to all of the different resources provided by our REST API. So here you see the different links. We visited many of these, but you may see some that we have not. So for example, here is the environment endpoint, and we can just copy that endpoint into our browser. If this were another machine visiting it, they might find this endpoint, visit it in an automated fashion. But here we can see the different environment properties that our application was launched using. So here you're getting a little bit closer look at my system and its file structure. But this is all made possible by the way the actuator is able to expose its resources via this hatios approach that uses hypermedia. One of the great things about the Spring Boot actuator is that it is very extensible. It allows us to create custom endpoints that can provide information about our application. These endpoints easily integrate into the actuator via Spring's IOC container. In this lesson, we'll see how to create our own custom endpoints. All we need to do to get started is to create a new class within our com.o'reilly.boot package. I'm going to name this class Custom Endpoint, and I'm going to have this class implement the endpoint interface. Once we have selected our interface, we can go ahead and hit Finish, and our new class will be built. Now, we do need to provide a generic type parameter for our endpoint, so I'm going to use a string. This can be any object that will get serialized to JSON, however. Once we have added our type, we can add our unimplemented methods, and then we can provide implementations of this method to satisfy our interface. The first thing we'll need to provide is an ID, and the ID is a type string. In our case, we're just going to use custom. Now, the ID will wind up being the path that our new endpoint is exposed under. So by specifying the ID of custom, this means we will access our endpoint by using /custom. Next is the invoke method, and this is simply what will be returned by our endpoint when it is invoked. So you could do a lot of logic within this method. In our case, we're just going to return a simple string, and it's going to say successful endpoint test. And we'll go ahead and we can save our invoke method. Moving on, we need to set our Boolean for the enabled property. In our case, we're going to say that this endpoint is enabled by default, and then we'll just move on to the sensitive property or field, and we'll say that it is also not sensitive, so we'll leave that at false. And this is our new endpoint. Now, in order for our endpoint to be discovered, we need to add the component annotation to the type so that it is discovered by Spring's component scanning and declared as a bean within our Spring IOC container. Remember that the content provided by the endpoint is determined by this invoke method. And you could return other objects than a string here, and they will be serialized to JSON. So with all this in place, let's go ahead and launch our application, and then we're going to navigate to a browser, and we'll hit localhost 8080, and we're going to navigate to the custom path, and that should invoke our new endpoint. And there we see the message returned by the invoke method, and we have successfully configured a custom endpoint within our application. So in this lesson, we took a look at how we can extend the Spring Boot actuator to include custom endpoints that can relay additional information about our applications. The Spring Boot actuator also provides a metrics endpoint, which allows us to view metrics on our running application. The metrics endpoint provides a variety of information collected using the metrics service, which operates using gauges and counters. A gauge records a single point in time value, while a counter tracks the number of occurrences of a simple event. In this lesson, we'll see how to access the metrics endpoint and to collect metrics within our Spring Boot applications. To get started, the first thing we'll do is launch our application, navigate to a browser, and then visit the metrics endpoint. You'll notice that the output of the metrics endpoint contains various pieces of diagnostics information about the performance of our application. There we see our free memory, we see the number of processors, there's all sorts of information provided. We get information about the heap, the average system load. We can see information also about our data source. You'll notice that we have here the activity on our data source, the usage on our data source. So we get all this great information about what is occurring within our applications. And as we add various components to our application, the metrics service is going to collect additional information about those components and display it via this endpoint. So it's very simple to get up and running using the metrics endpoint exposed by SpringBoot's Actuator. However, we may want to collect other information from our applications about what's occurring. So we can add different services within our Spring Beans to collect these metrics. In our case, we're going to navigate to our simple controller. And within the simple controller, we're going to collect information about how many times the execute method is invoked. To do that, we are going to inject a bean of type counter service, and I'll name that bean counter service, and actually I'll make it private. And we're just going to add the auto-wired annotation, and this will cause the bean to be injected from the Spring IOC container, and then it's available for use within our execute method. So what we'll do is we'll grab our reference to the counter service, and we will increment a particular metric each time the execute method is invoked on our controller. So I'm just going to say simple.service.execute, and this will cause our simple.service.execute metric to be incremented each time this method is invoked. And you can provide whatever metric name you would like here, and it will show up when we visit our metrics endpoint. So let's relaunch our application, and then we are going to navigate back to our browser, and the first thing we're going to do is we are going to execute. And once it's loaded, you can see we can execute. I'm going to do it a few times, and then our final time here, we will navigate to the metrics endpoint, and at this time we can look and we see that our simple service.execute metric has been assigned a value of 6, which corresponds with how many times we visited our execute endpoint invoking that controller method. So this is a great way to add some metrics easily into your application and be able to see how different components within your system are being used. So in this lesson, we took a look at the metrics endpoint exposed by the SpringBoot Actuator, and we learned how to collect custom metrics within our applications. Congratulations! You've reached the conclusion of the course. In this lesson, we'll spend some time reflecting on what we learned within the course, and we will discuss where to go from here. First, let's review the key takeaways from this course. SpringBoot is a powerful framework that makes building Spring projects incredibly easy. In the past, you needed to have a moderate understanding of the Spring framework's configuration in order to be successful. As you've seen, SpringBoot has completely eliminated this learning curve, using starter POMs and auto configuration to perform this work on behalf of the developer. It has never been easier to download STS and start building Spring applications. I expect this new approach within Spring to propel even greater adoption of the framework and further embed the library as the go-to choice for Java developers. For almost the entire Spring portfolio, SpringBoot provides these efficiencies. The startup cost has been extremely reduced for exploring a new module under the Spring umbrella. SpringBoot has essentially unlocked the door for developers to explore the entire portfolio. It's now much easier to take a look at a new module, evaluate it, and then incorporate it into your project. In the same way that Spring has opened the gates to the different modules within the framework, it has also unlocked the third-party libraries that we integrate with. We've seen support for things such as Hibernate, Redis, MongoDB, and Cache. We find the support for these frameworks within Spring Boot, and as new technologies arise, they will also find their place within Spring Boot's integration support. So when you know and understand Spring Boot, it's much easier to start adopting third-party libraries supported by Spring Boot. So Spring Boot really acts as a bridge to other technologies and other modules within the Spring portfolio. Aside from these benefits, Spring also provides a new set of tools that aid developers. Within this toolbox, developers will find support for features such as restarts, logging, and diagnostics. Boot furthers Spring's mission to make the developer's life easier. In the future, additional modules will be added to Spring Boot. Using the concepts taught in this course, you should be prepared to interact with those modules to quickly get started using new technologies. Many modules will follow similar application patterns that we saw within our lessons. So it's been a great course, but what's next? Well, the first thing, and this is something I always advocate for, is go out and apply the lessons of this course. And how do you do that? You write code. Write code in your own projects, write code at work, write code in your dreams. It's the best way to apply new concepts, new techniques that you have learned, and it's the best way to further your career. Always be writing code. Another recommendation I have is to go out and actually research some of the traditional Spring configuration. If you're not familiar with some of the older forms of configuring Spring, such as XML or Java configuration, this will really demonstrate to you what Spring Boot is doing on your behalf. And then ultimately, when you do hit that snag, you will have a better chance of debugging inside the framework, understanding what's going on, and resolving your problem without consuming a lot of time. The final recommendation I have is for you to continue expanding your skill set. Continuous education and continuous learning are huge in the developer field. We are getting new things thrown at us all the time, and you got to keep up with them or else you're going to fall behind. So I would recommend looking at areas such as aspect-oriented programming with Spring, maybe looking at Spring Social or Time Leaf, or if you want to go more advanced, look at something like a bytecode manipulation framework. These are all areas that I feel are well worth your time as a Java developer. Finally, I'd like to say thank you for taking this course. And I'd also like to commend you for continuing to explore within the new technology space. It's a great area to learn, a great area to develop your career, and you're doing yourself a great service by exploring, learning more. Even if you don't directly use this information, it will be beneficial to you in the future if it's not only to apply the concepts. I'd also like to thank you because I really enjoy making these courses, and they really provide me with an area of personal growth. And without you, this would not be possible. So thank you very much.